If you want to learn how to build dApps, if you want to learn how to build decentralized applications quickly, then this course is for you. And really, it's so much more than a course, it's a whole experience. This whole experience is for you. Because this course will teach you how to create dApps from scratch using simple JavaScript. And we will be using Moralis Web3 platform in order to make it as simple as possible. Because Moralis really manages most of the complexity when it comes to dApp creation, so that you can quickly build your dApp on Ethereum, Binance Chain, Polygon, Arbitrum, Avalanche, even Solana and Elrond, and so on and so forth. And it's very easy to do, and it's all cross-chain by default. And you can launch your app on different platforms. For example, if you create a decentralized app, you can launch it on the web, you can launch it on iOS, you can launch it on Android, you can launch it on Xbox, on PlayStation. We have all kinds of integrations and SDKs so that you can easily take whatever idea you have and you can go to market within days. And this is what developers that use Moralis actually tell us, that they save up to 90% of development time. And when you convert it to dollar amounts, you see that it becomes very, very big very, very soon. Because if we shave off 90% of development time and we make it easy for you to build, you save a lot of time, a lot of money, and you go to market quickly and you capture opportunities faster. So that's why Moralis is so important. And as you will understand when you go through this course, it's very practical. You build along with Chris, who will be the instructor for this course. And as you can see in our documentation, if you go to docs.moralis.io, it's very straightforward to understand the structure of the course if you just look here on the left. Because we will be going through step by step, starting with how to log in a user, how to log in a user on all blockchains, how to log in a user no matter which wallet they use, how to use Wallet Connect, how to do it quickly and simple with just a few lines of code with JavaScript. You can also log in your user with email if you want. For example, if you build a game or some kind of app where you have users that don't have any wallet, they don't know what crypto is, but you still want to onboard them in a familiar and easy way, you can log in with email and then you can connect a crypto address. You're gonna know how that is done. You can merge addresses. So this is an important feature. Let's say you have a user and they have many different addresses. Maybe they trade using different addresses, using different dexes, and you want to show them a list of all their transactions across all addresses. Well, you can merge addresses using Moralis into one single user profile. So you can know what your user is doing across all chains if they connect all their addresses to their profile. Very easy to do with Moralis. Then, of course, you're going to learn how to send assets, how to send NFTs, how to send ETH, how to send tokens. And this is cross-chain, of course, because the same method applies for Polygon, for Binance Chain, and other blockchains. It's all cross-chain by default. Then we're going to teach you how to use the Web3 API to get all kinds of information, for example, about the transactions of a user, for example, about the native balance, the token balance. You go to token section here. We're going to go everything in depth, by the way, but here is all about the tokens, the NFTs, the metadata, the token price, everything you're gonna learn in this course. And it's gonna be so simple, because if you look, for example, how to search NFTs, you can search any NFT you want. I mean, if you truly look at it, it's one line of code, Moralis Web3 token search NFT, and you can find any NFT based on just a search string. Then we're gonna teach you how to sync smart contracts and user transactions. So for example, you have a smart contract, each and every time something happens on chain, you can get a webhook, you can get SMS, you can get text message, you can get an email, you can run custom code, whatever you want. And the same applies to the user. When the user does something on chain, they send a transaction, they do something, they interact with a smart contract, you can watch it in real time. It's very easy to do. Then you're going to learn all about how the Moralis database works, so that you can save information, you can create relations, you can query the information easily. You can even get updates in real time through live queries. It's so simple. Then you're going to learn about cloud code, basically your own custom code that Moralis can run for you, simple JavaScript, and so much more, guys. As you can see, this course is massive. It's very, very massive, and you're going to learn a lot, and it's all simple. I mean, at the end of the day, it's all going to be simple JavaScript, and that's the magic of it. If you ever get stuck, you can ask us to help you in the Moralis study group. So if you go to studygroup.moralis.io, you come to this forum, and you need to sign up. So please, the first thing you do now is sign up and then introduce yourself in this thread. So I will link it below the video. You can introduce yourself. And then you will find another link below where you can get any help you want. So Moralis, let me actually create this, Moralis course help thread. So if you don't understand something, write here if you need help. We have full-time instructors here in the academy, so that you can easily go here anytime you want and you can get help with this course so you move ahead. So if you need any kind of help during this course, just go here, Moralis course help thread. And just write here, you can reply, you can write what you don't understand, we help you instantly. So now you know what the course is gonna be about, now you know that you're gonna learn everything you need to know to build cross-chain dApps, you're gonna be very, very surprised by how practical it is, because you will be building a lot, you will be following along, you will be building real projects, real apps, and you know that you can ask for help in the forum. And finally, if you go to moralis.io/certification, you can sign up so that you get a message when we launch Moralis Expert certification. Let me talk a bit about that because it's very important. So as you know, in Moralis, we are starting this program called Moralis Experts. The reason why we're starting it is because if you go to our Discord and you go here, for example, to hire Moralis devs, and by the way, you should join our Discord as soon as possible. If you go here to hire Moralis devs, you see that it's so many messages, people asking about, hey, can we get some developers, we need developers, everyone needs developers. Or you go here to job offers all the times, every time I look here, there's a new message, someone needs developers. So we are creating a database of Moralis certified experts that we can recommend whenever somebody is looking for someone to join their team. So if you are interested in becoming certified, you need to do this full course, but after the course, you need to also do certification. We don't have it yet, but if you sign up using the link below, this one, moralis.io/certification, you come to this page, you can sign up here and we will email you when it's time. And then you're gonna get instructions how to get certification. So please do it if you are interested. If you're serious about becoming a Moralis expert and serious about working in this industry. And that's the best thing about crypto, that if you really become active here, it's so many opportunities. You can work instantly. If you know what you're doing, if you know Moralis, you have a job tomorrow. I'm telling you, if you watch this course and you know everything that is here in the left side of this menu, you have a job tomorrow. I'm telling you, you have a job tomorrow, because this industry needs developers. And with Moralis, we save the development time, we cut down development time by 80-90%. I mean, in many cases, people tell us it's 90% that we've saved. So between 80 and 90% that we save developers, this is a no-brainer for projects. So when you say that, hey, I know Moralis, they take you instantly. This is the feedback we've had this far, and this is the opportunity in front of you. So guys, to summarize, 3 things. Number 1, you know the course, watch it until the end. Number 2, you know the forum, you can get help. Number 3, sign up for Moralis Experts using the link below. You also find the code for this video below as well, so you can see when you follow along, you see the code. And that being said, guys, I hope you will enjoy. I hope you will learn a lot. And now Chris Bailey from Moralis, a senior blockchain developer, will teach you from scratch what Moralis is, how it works, and your life will be changed. If you watch this video until the end, if you watch this course until the end, your life will be changed. I promise you. Remember that and then tell me if it happened. If you're completely new to crypto, your life will be changed. But also if you are already a blockchain developer, your life will also be changed. If you don't know Moralis, it's life-changing. See you guys. Before we start, it's very important that I tell you how this course is structured in terms of language. This course is done in vanilla JavaScript. Why? Because everyone knows vanilla JavaScript. Everyone understands how everything works in vanilla JavaScript. But of course, Moralis is also fully supported in TypeScript. We have everything you need in order to get going in React using TypeScript. And this is, of course, how you would do it in a project that is going to production. You would be building something in React, you would be building something using TypeScript. And so here, if you go to Ethereum boilerplate, you find the link below, you can see a full boilerplate here using React. So this is completely using React. You can get started here. You can see how it works, and it has everything. For example, it has a working DEX. It has balance list when someone logs in. You have a wallet where you can send assets. You have transfers. You have NFTs. You can interact with contracts, and so on and so forth. This is a fully fledged React repository with everything you need to know, all the hooks, all the components already figured out. The same thing applies to React Native, which I will also link below. You see that we have React Native boilerplate with, of course, everything already figured out and written for you here, so you can get started building mobile apps very, very quickly. So this is very important for you to know, because when you watch this course, you will be mostly learning the different features and functionalities in vanilla JavaScript. But there is full TypeScript support, and there is full React support, there is full React Native support, and also we're adding VueJS, we're adding Angular as well. And if you go to our documentation, and we have already, by the way, most of them, if you go to our documentation here and you go to getting started, you go to boilerplate projects, you do see here, for example, the React boilerplate, you see React Native, you see Angular. So Angular we have already, you can get started here. We have, let's see, we have also Vue.js, and the Next.js is coming soon as well. But the most supported one, the most supported one is the React one. So if you know React, this is the most supported one for you. But you don't need to know any of that when you're following this course. I just want you to know that there is full support for all these libraries. But in this course, we do vanilla JavaScript. So that you understand how it works, it's easy for everyone. Anyone can understand that. Nobody is really going to get intimidated by some React syntax or Vue.js or Angular. It's for everyone. And that's the goal, that everyone understands this course. That being said, good luck, guys. Let's start. So what are the prerequisites for this course? Well, number one, you need to know JavaScript, because this is a JavaScript course. We'll be using JavaScript in this tutorial. But also you need to know what MetaMask is. So if you're new to blockchain development, watch this video, MetaMask for Developers. And you'll find this playlist, Web3 Programming Prerequisites, linked in the description. Then it's also useful to know the blockchain development stack. How do blockchain apps work from the most top level, which is the user interface, down to the bottom level, which is the blockchain data, how it is stored, and the different layers in between. So you can watch this as well. But other than that, there are no other prerequisites. Of course, a big prerequisite is that you're interested in crypto. And hopefully before watching this course, you all are already a bit in crypto. You know what tokens are, NFTs are, how you send transactions and all of that, although the MetaMask video that I just showed you will also teach you. And you need to be genuinely excited about this space, because as you'll see, there is a lot of lingo here. For example, NFT, non-fungible token, or when you look at, for example, the token itself, what is token, what is ERC20, ERC71. So ERC20, for example, that's the technical standard for a token. ERC71 is the technical standard for an NFT. So these things, they may come up during the course. And for all of you who are in crypto, of course, it's not an issue, because you probably know it already. But if you're doing this course and you have some questions or some lingo that you don't understand, please post here, Moralis course help thread. Because if you don't know, we're here to help. And it's okay, you can ask anything you want. We're gonna help you. So guys, hope you enjoyed, hope you learned something. Let's get started with practicalities.
Hello developers, welcome back to the channel. It's Chris from Moralis, and in this video we'll give you an introduction to what Moralis is, how it can help you, why it is the ultimate Web3 development platform, and why developers are using it for their applications. I've got some slides prepared for you, so let's jump into that now. When you think about it, all applications need to do exactly the same thing for their users. They need the ability to log the user in, they need to fetch the user's balances and transactions and their history, they need to be able to fetch smart contract events, get real-time alerts when something happens on-chain, build an index, for example, if the database changes, send assets and transactions. And that is pretty much the majority of what an application would do. So we're constantly finding that developers are coming into this space and trying to reinvent the wheel, do everything from scratch, which is completely the wrong way to go about this. So they go out and they get servers, they get RPC nodes, they go and get subgraphs, they build a team, they put a huge amount of time and energy and resources into building their APIs, but they find out that maybe they can't sync balances, they can't sync NFTs, they spend more and more money, get more and more bugs, and very quickly realize that interacting with an RPC node is a horrible experience. Simple fact is, you just cannot filter an RPC node, and more infrastructure will not help you do that. So it can take a lot of time to get any application to market by following this kind of process. So our advice to any developers that are doing it that way is don't reinvent the wheel. You just need a Web3 operating system instead. You need a solution where the work is already done for you. There's a packaged server solution ready straight off the shelf with a one-click launch, and a solution that can easily allow you to, for example, use it in iOS or Android development, or even in Unity game development, or even just standard JavaScript for regular applications. That's what you would need to save you some time so you're not having to worry about working on the infrastructure. And so now that's what Moralis is here to do, and that's what we want to focus on. So you can think about Moralis as being the Firebase of crypto. If you know Firebase already, then you'll understand quickly what the Moralis server can do for you. So all you'll need to do is go ahead and log in. And once you've logged into your Moralis account, then you'll have access to your servers, or you can create one if you don't already have one. And inside your server, you'll be able to bring up your database when you just click on one down here in the dashboard, which will take you to this. And as you can see, I've got 22 users that have logged into this application already, and it automatically pulls into my database the ETH balances, the NFTs, the token balances, all the transaction history, and I have some custom tables which I've created in an application separately. But all of that data is ready to use with just one line of code. Let me show you some examples. What you'll need to do in your application is log your users in, and that can be done with just one line of code. Once they have logged into your application, getting transactions from the database, one line of code. Getting the ETH balances, one line of code. Getting ERC20 token balances, one line of code. Getting NFT balances, you got it, one line of code. That will return you an object of data, and you can use that data inside your application however you would like to do. So rendering that information can be done very, very easily using Moralis. But there's more. You can send assets with just one line of code. You will be able to send Ethereum or Matic or BNB, one line of code. For sending ERC20 tokens, one line of code. And the same for NFTs. All of these powerful functions can be written with just a single line of code by passing in some options, and all of that is explained for you in our incredible documentation. Even our plugins can be installed with just one line of code. At the moment, we have a DEX plugin, which allows your users to swap tokens like they would get if they used a service like 1inch or Uniswap. We have the OnRamper plugin, which will enable your users to buy crypto straight from your application, which can be installed in your app with just one line of code. And there are so many other features which we will cover through this tutorial series that are available to you with just a small amount of JavaScript embedded into your application. That's the power of Moralis. You should not be focusing on infrastructure, guys. It's a waste of time. You should be focusing on what your users want from the application that you're looking to build. Use a packaged solution, and that's exactly what Moralis is offering you to use. So go and use our documentation if you're looking to implement this into your application already. Our documentation is fantastic. Our support is fantastic. You can find out more from our community section regarding forum and Discord channels. And if you want more information about what Moralis is, then watch this video here by Ivan. But in the next video, we're going to be looking at spinning up our first server and getting started. Hello developers and welcome back. It's Chris from Moralis. And in this video, we will be looking at spinning up a Moralis server so you can take advantage of what we can offer to you as the ultimate Web3 development platform. All you'll need to do to spin up a server is create a Moralis account if you haven't already done so, and then log in. Once you've logged in, you'll be taken directly to the server dashboard page. And from there, you'll be able to create a new server if you don't already have one. I've got 6 currently. You'll normally with a free account only get access to 3, and when you upgrade to a premium account or more, then you will be able to have more servers. But most people will fit within the 3 server limit, so you should be fine if you're just getting started. Now, on the left-hand side, you've got some different options. This is the server page that we're seeing right now. We've got the Web3 API option for you, so you can go and take a look at all the different endpoints that we have available for you to be able to hook into with your application. And we're looking at native balances, NFTs, transaction history, all different types of options here. And there's some really fantastic resources that you can take advantage of. These endpoints for the API are also part of our SDK, which you can call from within your function, within normal JavaScript functions within your application. And we'll go through that in another video. The Web3 alerts are coming soon, and our speedy nodes are available for you. So there's Ethereum, Binance Smart Chain, Polygon, Arbitrum, and Avalanche. And by the time you come to watch this video, perhaps there's different ones there as well. Okay, back to the server options. Across the top, we've got 4 buttons here. The first one is for documentation. If you need any assistance, then that will be the first port of call. And then if you do get stuck implementing any of these functions into your application, go and put a message into our forum. Our forum team are there pretty much 24 hours a day, 7 days a week to help you if you get stuck. There's also the Moralis DAO, the Discord community channel that you can join over here, and our YouTube channel is available up the top. On the right hand side, you can change your account settings, change your password if you need to. There's also two-factor authentication as an option that will be enabled, and you can use these tools here to embed that into your application as well. Super important. And when you do need to create a brand new server, if this is blank for you, for example, just simply click on the green button here and you'll be presented with three options. You can either create a mainnet, a testnet, or a local dev chain server. Now, all the differences here are based on what information gets pulled into your database tables. Now, if you choose mainnet server, what that will mean is that every time a user interacts with your application, it will pull in information from that user based on their main net usage. So for example, it will pull in their transaction history, it will pull in their tokens, and it will pull in their NFTs from the main net. If you choose testnet server, then it will automatically pull in that information from their test nets that they're interacting with, and the local dev chain server is for the local dev chain interactions. Now, it's not to say that it will only use that information. It's just that when you populate a new database, that's what automatically gets pulled in from a user. You can add as much information to your database as you like. So we're going to use the mainnet server just for this example, and feel free to experiment with the others if you wish to as well. So under the mainnet server, choose a name for it, whatever you like. Choose a region closest to you. It will be the mainnet that we've selected, but you can change it here as well. And then you can choose the chains. Now, our servers are cross-chain by default, and at the moment we have ETH mainnet, Polygon mainnet, Binance Smart Chain mainnet, and Avalanche mainnet. Perhaps there are more options by the time you come to view this video. And so you can click all of those, add the instance, and after a few minutes, the server will spin up and it will be ready to use. And you'll have a panel that looks something like this. You can expand the panel by clicking on the three dots over on the right. It gives you some more information. But the server name is here. The details are accessible here, and the version number is here. This current version number is 272. The most up-to-date version, I believe, is actually 278. So you can update your server as and when you need to, depending on what new functionality you want to take advantage of. So let's just look at the details first, because whenever you need to connect to a new server with Moralis, you're going to need to choose, or copy and paste, should I say, your application ID and your server URL. And you'll need to do that in every new application that you create. And this is where you find that information. So under the server details, you've got the server name, the server URL, the server application ID, or just the application ID. And you can copy those into your clipboard by clicking that button. Now, sometimes in the more advanced developments, you'll be required to pass through a master key, or you might need to find that in your application. And this is where you will get that information here. The dashboard user and the dashboard password. Now, that's really if you just ever needed to log directly into your database externally, rather than going through this admin panel with Moralis. I haven't needed to do that yet, but if you did, then this is the username and password that you will require. I'll take you into the dashboard in just a moment and we can see the database tables. We can also get our CLI API key and secret. You might not need to do that straight away, but if you, for example, wanted to interact with your Moralis server using the command line interface to do things like writing cloud functions from your Visual Studio Code editor directly into your Moralis server, you'd need that connection, that bridge, and you'd require your API key and API secret. There's already some documentation around the CLI that you can use to interact with that if you need to. And then there's the MongoDB IP as well. Just moving along across the top, the settings, that is if you need to create your SendGrid account to send a verification email to new users if they sign up, or have them reset their password if they need to do that as well. There is a video that's produced recently by Malik that will help talk you through the SendGrid setup, and this is where you would use that page to put in your details. EVM configuration is choosing the chains. This is a server that's just specifically for the mainnet only on Ethereum, but yours might have more ticks in these boxes. The sync page, now that is really if you need to watch certain smart contract events. If you're looking at pulling in information when a particular event fires or triggers on a smart contract, this is where you could watch that and it will automatically pull that information into your database. Super powerful tool. Okay, so that is that. And then if we just expand the server, and down the bottom left hand side we have some buttons. The first one is to delete the server, pretty straightforward. update and restart the server. That's also pretty straightforward and will be useful to do if your server is a few versions behind, for example. The dashboard is the database, and there are some other options available. If we click on that, this particular database is not very big, but there are automatically some tables that have populated here because I have some users that have interacted with the app that I built using this server. And as soon as a user interacted with it, there was data that was pulled from those users into these tables, the ETH balance, the token balance, and these users don't have any NFTs, but if they did, then they would appear in this table as well. So I'll just show you another one, for example, that maybe does have that data. Let's go and look at maybe server 2 and load that one up. Might have a few more users. It does. Okay, so there's quite a lot more users, and you can see the tables. ETH NFTs are in there as well, and this particular user has only really or this particular group of users has only interacted with the Ethereum chain. So it hasn't pulled in anything else from Binance, for example. So these are your database tables, and all of the user details will be stored in here automatically as soon as a new user authenticates with your website, and you'll have the details that will be stored in here. You can create new tables as part of your application. I've created this, for example, this portfolio table in this one, and creating new classes and adding new data of any type of data into your classes is very, very straightforward, and we have very extensive documentation helping you do that. So that is the dashboard. And the last thing just to mention with the dashboard is that if you need to do some error checking, for example, with your backend cloud code, then you can do so under the logs section here. There's also an API console for REST, GraphQL, and JavaScript if you need it. And you can take care of the webhooks and the jobs. But the majority of the time you're really going to be spending is in the browser window and the logs window. Okay. So that is the dashboard. The plugins. Now we currently have 2 available at the time of recording, which is the Fiat on-ramp plugin and the 1-inch DEX or aggregator plugin. There might be more by the time you come to watch this. To install a plugin, super simple. You just click on it and then add it to your application. There'll be a button that will appear. And when you authenticate a new application or initialize Moralis in your application, it will automatically enable the plugins. So there's not really that much work that you'd need to do other than just install the plugin that you want to use and then use it. So that will be the plugins. We also then finally have the Cloud Function panel here, and you can write Cloud Function code directly into this window and it would save into, you'll be able to use it from the front end, and this will be the panel where you could write as many Cloud Functions as you would need to and find them here anytime you like. So that, guys, is a quick crash course on how you would create your server. Once you've got it, you then just need to go on to the next step of initializing Moralis and connecting it to your application. So that will be covered up in another video and another section of the documentation. But I hope this was useful. Look forward to seeing what you create with Moralis, and we'll see you in the next video. Welcome back to the channel, developers. It's Chris from Moralis, and in the next couple of videos we will be looking at the users section of the documentation. From moralis.io, if we head on over to documentation, scroll down to the users section, and you'll see from here there are a couple of sections we may have covered already. For example, the crypto wallet login, the email login, and also how to get information from the current logged in or authenticated user. But over the next couple of videos, we're going to be covering off the rest of these sections to understand a bit more exactly what the Moralis.user object is. Now, we've already briefly touched on crypto login and email login. We did that when we built our boilerplate code previously. And you're familiar with the current user object as to how to find out whether a user is authenticated into your application or not. Now, in this example, we're going to go back to the boilerplate code here, which is just allowing us to authenticate our user with MetaMask if they're on a desktop. And once they're signed in, you get this. You have a logout button, which when clicked has this alert attached to it and then takes you back to the sign-in page. Now, I'm going to be using an emulator for my phone here. So this is just exactly showing you what you can see on my mobile. And when we click on the sign-in button from the mobile version of this app, instead of just getting an automatic MetaMask login, we now get this. And this gives us different options that we can connect to. So if we want to use MetaMask, we can click the MetaMask icon here and MetaMask will load up and then give us our connect, which we can click. And I'll click sign. And then it says we can go back to the browser. It's actually hidden here, but the link is underneath this recording button. So I'll just click back and you can see that we're logged into our application. So we'll click log out. And we've got the same alert, and then we'll click sign in again, but this time we'll maybe use a different one. We'll use trust, And that asks for a signature request as well down the bottom. Once we click that, then it will, I might have clicked that twice. It then says we can go back to our browser. And there we go. We can see that we're logged back in again. So let's start off with the documentation. We'll go under the intro first of all, and we'll just explain that whenever you have a new user that gets authenticated into your application, their information is going to be added to your database. So if I spin up my database here, let's load up the server page and open up a dashboard for one of my servers. The left-hand side, you'll see that there is a number of tables that populate. There is a user table here, which is where the user data is stored. And all of this sort of balance and token and transaction information is based on my users. As soon as a user authenticates with my application, the server will sync their address with my database. So all of their transactions and balances are pulled in directly into that database. If they've been on AVAX or Binance Smart Chain, Ethereum or Polygon, it will pull that data in automatically. So this section of the documentation explains that the Moralis.user, that user table with all of that data, is a subclass of the Moralis object. And it's got all the same features and schema and key value interface as the other tables that you'll come across in the database. And there are some specific security functions with this user table. It's a little bit more locked down than some of the other tables that you'll find, for example. And you can add information to your users if you wish to. It goes on to explain that authentication can be done in different ways. You can log a user into your application with a crypto wallet, or you can log them in with a combination of a username and password or an email and password. But let's jump first of all into the crypto login. So the Moralis authentication allows you to authenticate users on any blockchain with just a single line of code. The single line of code that we have been using was moralis.authenticate. That was it. That's what this would do. Okay, that's moralis.authenticate. Automatically assumes that you want to use MetaMask. And this is the instructions for how you can do that. Just be aware that whenever you do use MetaMask, there is no gas required to request or sign a signature. It's just used as proof that that is the owner of the account that you're trying to interact with on your application. There's a bit of information about how that works. There's a video there about MetaMask authentication, but you may already be familiar with that from our previous part of the videos. Now, Wallet Connect is another option. So Moralis.authenticate with no options in there just assumes you want to use MetaMask, but you might not. You may want to use a different crypto wallet login. And Wallet Connect is a provider that you can use for that. There's a 5-minute video here from Malik that explains that, how to use that in JavaScript, but also in React.js. And if you want to use Wallet Connect, there's just a couple of other steps that you need to follow. For example, you need to install this script tag in the head of your HTML. If you're using NPM, you'll need to install Wallet Connect /web3-provider. And then once that's done and you've installed it one way or the other, you'll then need to call it call the authentication method like we've done before. But this time we're going to pass in this object, an extra option that says provider is Wallet Connect. Okay. There are other options in addition to this if you want to provide, for example, the default chain that it automatically loads up. You can pass in the chain ID as an option here. If you need to know more about what the chain ID is, let me load up a website that might help you. Here we go. This is chainlist.org, and this will show you the chain ID for all the different chains that you might want to populate as default, providing we support them. So Ethereum, Binance Smart Chain, Polygon, Avalanche, etc. You'll be able to find those chain IDs here if you wish to. Let's close that down, come back. So that would be if you wanted to specify a chain ID. Now you remember, if we go back to this emulator over here, when I clicked sign in, we had 6 different options here that you could use as a Wallet Connect crypto wallet login. Now the reason we can only see 6 here is because I actually copied this particular code into my application. And this allows you to filter the mobile linking options and reorder them depending on how you want them to appear in this list. So this list now shows Rainbow first, and then MetaMask, and then Argent, and so on and so on and so on. The majority of the time, MetaMask or Wallet Connect as a solution will be more than adequate for you, but there may be occasions where you want to use a custom wallet, and it is possible to use any Web3 provider. If you want more information on that, please use this section of the documentation. You'll need to import, I believe it's Taurus will be the solution. You'll need to import the provider. You'll need to overwrite the standard Moralis enable method with this particular code, and then you'll need to create the Taurus provider as well. So it's a little bit more copy pasting, but after that, it should be good to go. And then you can enable Web3 by following this particular code here. I personally don't, or have never needed to use Taurus, but if you do need a custom wallet login, these will be the instructions that you'll follow. For everything else, Wallet Connect to MetaMask will be just fine for you. You also have non-EVM chain login options available. So Elrond is an example. If you need it to be working for your application, there's a bit of a setup that's required here. Here are the steps to do that. There's a video by Ryan here that walks you through that process as well. And then once you've done the authentication and you have a user logged in, whichever method you've chosen, you will then be given a user object. And the user object typically will return information that will look like this when you call it. And in there, there'll be the class name, the ID, and more importantly, you have your attributes, the user attributes. And in there, you'll typically find your ETH address and the accounts that may be connected to that particular user if there are more than one, the access control list as to who would have access to this particular user object. And by default, it's the user only that will have access to it, but you could change it if you want to. And then the username, that's automatically or randomly generated with a crypto wallet login. And you could overwrite that if you wanted to by setting something else. The ETH address has its own table in our database, which is typically down here. And you can see the different tables that would appear in here. And under there, it just shows you that typically it would be updated with information like this. Okay, now we mentioned on the left-hand side of our table that there's a whole bunch of extra tables which we didn't create. They were automatically generated. So depending on the usage of your users and where they've been across those chains, it may populate these extra tables based on the chains that they've used. And because you're constantly watching the user, thinking their on-chain activity, more tables may be added depending on what they've done. These are the different chain prefixes that will appear, for example, at this part of these tables. And just before we go into the code, it is worth explaining that if you ever need to delete a user from your database, don't just go into the users and delete that one user. Make sure that you also follow these instructions to delete the user session, the balance, and the address from the corresponding tables. The other thing I did change when I was signing in using my crypto wallet login is the sign in message. So I changed my sign in message here. So to view that message, we just go back to the emulator here and I'll just click on Trust Wallet, click on Connect, and there you go. So you can see here, my new custom message, hello. And that's how you would change it. I'll show you how I did that in the code in a moment. And scrolling down, changing the app icon in MetaMask. Well, the instructions to do that are actually on MetaMask, so you can follow that link if you need to do that. Okay, so let's hop over to Visual Studio Code and see what we did here. And this is boilerplate code, very, very similar to what we produced together to create the login, logout Dapp. And I've just made a couple of changes. I removed jQuery and Bootstrap from up the top. Not important, it wasn't being used, I didn't need it. I added the Wallet Connect script. That was the first thing that we saw as an instruction in the documentation. So I added that here. If we scroll down, I've got the new initialization function. We talked about that in previous videos as well. And the login function. Okay, so in here, I've done a couple of things. So the first thing I did is initialize a variable called current user. We check the moralis.user.current method, and that will provide us with a user object if a user is logged in. So what we want to check first of all is, do we have a user logged in or not? If we do not have a user logged in, then we need to authenticate them. We need to sign them in. So from here, I run a check to see whether or not, are they using a mobile device or are they using a desktop? And that's not always the easiest thing to check. So I've got this sort of crude solution here that just checks the type of screen that the user has. Because if the screen orientation is undefined, it's typically a mobile device. But if it's not undefined, then it's a desktop device. And using that, we can handle which method they see when they're logged in. So on a mobile device, I want them to show the Wallet Connect login. So I've got the Wallet Connect login here. Now we're saying it's one line of code with Moralis, and it certainly can be. You can just use this one line of code. Await Moralis.authenticate and then pass in the provider Wallet Connect. That's it. That will work just fine. but I wanted to customize it. And rather than have it all on one long line that goes off the edge of the screen, I've just separated it so it looks like it's on multiple lines. But the options that I'm passing to it are a provider, which is Wallet Connect, same as it is here. I'm also then providing it with a signing message called my new custom message hello. We saw that on the Trust Wallet example. And then I'm providing it with this mobile links array, which organizes my options to these 6. Okay. So if we're on a mobile device, this is what we're going to be using as our authenticate. However, if it's not a mobile device, so it's just a regular desktop, then we'll just use our standard Moralis.authenticate method, and that's it. Okay. So that's what this login function now does. And then it checks the user and it handles the CSS based on whether they're logged in or not. The logout hasn't changed. The check user function hasn't changed. The only other thing that I added was this document.addEventListener, this handler at the bottom, because I use a Apple phone. And when you try and use Wallet Connect with an Apple phone, once you've signed your transaction, Apple pop up a different window that can sometimes cause the authentication to not work as expected. Let me show you what it happens when it's not there. Blank that out and go back to the application. Let's just refresh that. And then we'll click sign in and we'll go to the Trust Wallet again. And then we'll sign this. It says go back to the browser. So we'll go back to the browser and you get that. So open this page in Trust. So you're like, okay, fine, open. So it takes you back to Trust Wallet. And then you think, okay, well, that's a bit confusing. So then you come back and it doesn't always log you in properly. So I just find that this is a bug specifically with Wallet Connect and iOS. Nothing to do with Moralis. It's specifically with Wallet Connect, and they're aware of this. And on the forums, that's where I got that snippet of code. So once you go back and remove that, update your app and refresh and sign in, back to Trust Wallet, connect, confirm, go back, then that message is gone and you've logged in. Okay. So that was just a simple fix. And I think it's only specifically iOS. Certainly was irritating me. So if you're an iOS user, you probably have the same issue, but I think Android, it's fine. So you shouldn't need to use this particular piece of code at the bottom. You could remove it or comment it out or keep it there for iOS users, whatever you like. So that is the application. So that has, if you like, handled a different authentication method for your user based on whether they're on desktop or mobile, using either MetaMask directly or Wallet Connect, giving them lots of other crypto wallet options. If you want to give them an option to log in with Wallet Connect, whether they're on a desktop, then just remove this whole section of handling this screen orientation. Just remove that and just only use this Moralis.authenticate with these options as your main login authentication. All right, guys. So in the next one, let's go and take a look at the username, password, or the email login section. In the previous video, we were looking at the crypto wallet login in more detail. And now, as promised, we're going to look at the username and password or the email login. Let's jump back over to the documentation. We recently were working through the crypto login, but email login is a little bit more straightforward. It just simply allows a user to sign up using the Moralis.signup method or user.signup method. And a typical example will be a username and a password. Now, this will authenticate your users and enable them to use the functionality of your application. But what it won't do is have the same benefits of using the crypto login in terms of syncing that user's data on-chain into your database so you can use it in the application in some way. If they only sign up with a username and password, then your app will have no idea who they are on-chain. So you probably would prefer to use the crypto wallet login, but this is obviously available for you as well. The most common combination we find is that people are using the crypto wallet login, but they're also allowing the user to have a username and password that they can then sign in with separately. So it links the accounts, and that's where merging addresses and linking accounts will be helpful for you later in the series. So as we scroll down the documentation, we can see here that it's possible to authenticate without a wallet using a username and password, and it gives access to that Moralis.user class. You would use Moralis.user.signup and you would pass through the username and password. We've done this once before because we produced this together, which was our authenticate users boilerplate code, which we did previously. And that just enables you to sign up your users. So you should be familiar with that functionality. In this snippet, it also talks about setting additional information to your user. For example, setting the phone, setting an email address, and then at the end of that, you don't need to save those attributes. You just simply await the user.signup and it will automatically save them and add them to the table. If you want to come back and change those details, then you would just simply call a user.save. Okay, now this method of username and signup might mean that the user could forget their details, forget their credentials. It also might mean that you'd want to verify them because they could just go on there and create any information like I just have here. You can put in any details there and just spin up, 100,000 accounts, and it's going to really put a strain on your server. So what you'd probably want is to have a verification. So if you look down this documentation, scroll down to verifying, it would see here that there are some instructions for how you would use our SendGrid integration. And that will enable you to use or send out verification emails to the users. Whenever they sign up, maybe you would handle it with an email box that you'd have in here as well. And then your code will automatically be able to fire off an email to that particular user address. We've already done the login with username. We did that in a previous video. This was the verification of emails. And typically what you'll find once you have sent out the verification emails is that your tables will show. Let's just see if we can bring up a user table here. There is a column here called email verified, and currently it's set to undefined, but it's typically a Boolean, so true or false. And then once you have verified your user, then this particular value will change. So that's all handled automatically with our SendGrid integration. You'll just need to follow through the steps of getting that set up and verifying yourself in order to take care of that functionality. So if you have the case where a user has forgotten a password, if you have set up your SendGrid properly, then when they click on the reset password link, it will automatically take them through this process of resetting. It does require a bit of setting up from your side. So take a look at the video I showed you a moment ago from Malik, and also this sending email page, and that will help your users receive their new password and log in to start using your application again. The reason that this might happen is for the simple fact that when you're using a crypto wallet login, you don't need a password. It's all stored in your private keys, which are held inside the wallet. So for that reason as well, for simplicity, it might also be in your benefits to just continue to push the crypto wallet login. Okay, let's move down to merging addresses. So there'll be a time where you might have a user that has multiple Ethereum addresses. Maybe they've got 4 or 5 different accounts that they use their MetaMask for to interact with your application, and they're switching between them. You might want to connect that particular user to those Ethereum addresses, or at least give the user the option to do that, and they can choose yes or no whether they want to link them. If they choose that option, it will mean that any transactions that are made on any of those addresses will be synced to that particular user, and all of that information will get pulled into your database. In the users table, you'll see the accounts column, and inside there'll be an array. So if there's more than one account that's linked to that user there, or more than one address linked to that user, it will appear in this array. There is a tutorial on the demo section in the application where it might be worth looking out for you. Under the getting started, clicking on demos, it was a tutorial that was produced by Jeremy, and I believe it was this user profiles one. I'd highly recommend taking a look through that code to find out how the different address linking can be incorporated into your application. That also does solidify some of the things we're looking at inside this user section as well, like changing passwords, saving additional information to the user object with authentication for both username and MetaMask. To merge your addresses, you just simply need to use Moralis.link function. And once an address is linked to that user, it pulls in all of the information from those users as well. So this is an example of how you might incorporate that into your code. So Moralis.onAccounts changed. So when somebody swaps in MetaMask between one account to another, it would run an anonymous function where it passes through the accounts of that particular user. And then you can simply have an alert or a confirm that's asking the question to the user, do you want to link this address to your account? And if they've said yes, it simply runs a Moralis.link and it takes the most recent account in that user's array because that's the one that they're using at the moment. Now, using this particular feature does have a warning, because whenever you call moralis.link with an address that is already associated with the user, then it will throw an error. So you will need to provide some error handling there to find out which of the addresses the user has already linked. If Jeremy's tutorial doesn't handle that for you, then you might want to write a cloud function to search your database for that user's address to see whether it already exists. Again, there's a merging addresses video here from Ivan. It's well worth taking a look at that one as well. You can link Elrond addresses, and they can be linked to the accounts using this particular code, await moralis.erd.link address as well. And that'll prompt the user to authenticate on the ledger device. So you'll need to make sure that that's plugged in as well. Okay, great. So we're moving on now to the current user. And we've briefly touched on this one already, where we would check in to see whether a user was already logged in. So we can use that moralis.user object, and we specifically did it with moralis.user.current, which then passes, or returns, should I say, the user object. And then you would store that into a variable, and then you could query that variable and ask, is there a user? And if so, do stuff. If there's not, then send them back to the sign up or the login page and make them authenticate. And whenever you use the sign up or login methods, whenever you have someone authenticated in your app, the user will be cached inside the local storage or any other storage that you configure with Moralis. And so treat that cache as a session. And so when you go into the database, you'll see the different sessions that you've had, or different devices that people have connected on in your session table. If you configured any of your own storage, moralis.setAsync storage is a method that you can use. Then you'll just need to make sure that when using the platform, you call the current async instead. I don't tend to use that personally, and you can always clear the current user by logging them out regardless of which methods you will be using. And that's just moralis.user.logout, which we've used before. Now you may have your own authentication routine and may want to handle your user sessions in a slightly different way. So for example, if you want to get a track every time a user logs in and every time a new session is created, then you can use the moralis.user.become method, and you can pass it the session token here. But just this particular area adds an additional line to your database. And if we scroll down, this part will often be overlooked by new developers that just want to jump into their code. And that is making sure that they're locking down the security for their user objects. So the Moralis user class is secured by default. Data stored in there can only be read or modified by the user. However, other classes and other tables are not going to have that lockdown level of security, and you might want to apply the security to them. So this following snippet shows security policy in action. So for example, this first snippet here, this is showing a user that's trying to log in and then change their username to a new username, and that will allow them to do that. So the user awaits moralis.user.login, they log in with their username and their password. They then call a user.set method, which hooks into the username table and then allows them to assign a new username, and then calls user.save to save that. And that will succeed because the user is authenticated on the device, and it will allow them to do that. So in this particular example here, this is an example of something that's going to fail. So let's just say somebody's trying to hack into your database and change your username. What they're doing here is they're running a new Moralis query. They're running into the moralis.user table. And then what they're doing is they're running the query to try and get a particular user from their object ID. Let's say it's your object ID that they want. And then what they're going to do is they're going to try and set your new username to another username and then run the save. Well, that's going to provide an error for the simple fact that the user that's trying to do that is not authenticated as the user that it's trying to change. Only you can change your username, and no one else could do that for you, or only somebody that's logged in as you or authenticated as you would be able to do it. So let's demonstrate a little bit about the security for other objects. Now this section is specifically related to locking down some of the classes that you'll have inside of your database. So for example, if I just load up one of the databases that I have, this one over here, it's fresh for this exercise. And inside of this database, I've got 4 users, and I've created a new class called Note. And inside that note, we've just created some messages, which I'll show you the application for in a moment. So The application will look like this, very, very basic. It's just our boilerplate code that we programmed together, which when we log in, will have the ability for an authenticated user to post a message. So if we log in, then this is the list of messages. Now there are 6 notes, but what I've done is I've created some security on these notes to mean that users will only be able to see the notes that they post or that they have access to. So in this case, Catherine, the user, has access to these 4 messages. 2 were written by that user and 2 were not. And this is where the message was written. If we log out, log in with, say, the second user down here, then we will see that that user only has access to 2 messages, this one and this one. And then there was a final user down here, user 101. I pressed the wrong button, pressed comment. The user 101, if we log in, has access to these 3 messages. Okay, so let's head over to the database and take a look at the security features first of all. In this notes section of the database, we can see this column here called ACL. That stands for Access Control Lists. And that is literally controlling who has access to individual items in the table. So if we click on this particular one at the bottom here, double click on that, it loads up and says that the public does not have read or write access. But this particular user, this is the object ID of the user, and the username is Catherine33, has read and write access. Okay, so we'll just cancel that. I'll go into another one. This particular note has public read and write access, but also has access for user 101 as well. Although that wouldn't make any difference because the public read-write access would overwrite everything anyway. This next one here doesn't have public read-write access, but it does allow access for user 101. So this particular message is only visible by user 101. It says, given the speed at which developers are moving from Web 2 to Web 3, so on and so on. Let's go back because we're logged in as user 101 here. And there's that message, given the speed at which, and so on and so on. Okay. Back into the database, if we take a look at this one, it doesn't have public read or write access, but it does allow access to 3 users, Chris, Catherine, and user 101. So that means that the public, if they were not logged in, would not be able to see these messages, but these 3 users can. Okay, and 101 is able to see that message. Moralis is the number 1, it says. This one, Moralis is the number 1. Okay, and the same would be for the others as well. No public read-write access, but Catherine has access in this case. And this one is actually it's a different user. This is a MetaMask user, and you can see the username is randomly generated. So this was just logging in using a regular MetaMask authentication. But again, no public read-write access, only read-write access for that user. Okay, so you can set an ACL one of 2 ways. You can either go into the database and literally change it. So for example, if you wanted to remove Catherine's read-write access, you can delete that and then save the ACL. And then it says that the only way to access that message is with a master key only. Or you can just go and add the user back in by either typing them in, or you can copy and paste a user object. For example, if we go over to the user table, you'll see that these are the 4 users we have, Catherine, Chris, user, and this MetaMask authentication. So for each one of these users, they have an object ID, which is unique. So you could use that as the username instead. If you know the username, great, but if not, you can use their object ID. And you could just put that object ID directly into this ACL field and then choose what the access would be. Okay, so at the moment then, if we just look down these ACLs, we can see that every single one of the messages except for one is not publicly readable. This one here has public read and write access. If we went to the front end of the website, for example, and logged out and bring up our console, then we can actually run a command that would search the database for all of those notes and bring the data back. Let me show you an example. So let me load up a query here. We'll go into queries in a lot more detail in the database section. So this is just a very quick overview. But we can run a new query. So we'll declare a variable called query. We'll run a new Moralis.query. We'll query the note table. And then what we will do is we'll just run the find method on our query variable and save that into results. And then we'll just bring up results, see what we have inside there. And we can see that we have an object subclass, which inside there is one item that is returned. If we go into that, go into the attributes, and we can see the content. Bitcoin is set for a new or for an all-time high. And if we go back to the notes, we will see that that particular message here is the only one that is public, read and write. So as you can see, we would be able to, with very, very little understanding of what else is in the database, be able to retrieve information because it's publicly available. So that's one thing you've got to be aware of. Whenever you create a new class inside of your table, you must make sure that you're locking down the basic security. And the most common and easiest one to do is to just add whoever created the post or whoever created the item in the database, have it only accessible to them. And maybe that's a good place to start. And that's exactly what we've done in the back end of this app. So I'm going to show you how we've automated now. So whenever we create a new note, for example, let's log in with user 101. And we will say that this note will automatically have an ACL for user 101. And we'll just save that note. And it shows up automatically in the list. This note will automatically have an ACL for user 101. And if we refresh the dashboard, we should see that the new note appears. This note will automatically have, there we go. And then we double click inside that ACL, it does specifically remove the public read-write access and add read-write for user 101. So how and why has that happened? Well, let's go into the code and just take a quick look at the application. The application itself is quite straightforward in as much that it's just the boilerplate code that we're familiar with. Shouldn't have changed a great deal up here. I'm just scrolling down, just taking a quick look. The Jumbotron looks to be pretty much the same. There's some buttons in there that will be connected to JavaScript and some text explaining the users. We've got the new initialize feature. We have a function called post comment, which is where the ACL is going to be set. So what we've done here is we have created a new variable called note, of which we've then run moralis.object.extend. So we've created a new class in the table basically, and then we've we're creating a new note each time the post comment function is run. And then we just check if a user exists. We then go and get the value from the field that they're writing the note in on the front end. And if the value is empty, then it just returns. It won't let you send or post it. But from here, what it will do is it will set some fields inside of your new note class. It's going to set the content field, which would be the comments content. We're going to set the note user to be whoever the user was, whoever's actually signed into the app at that time, and the writer of the message, which is the username of that user. So we're actually putting in a whole object into this note user, and we're just putting in a single field inside of the writer. And then what we've done is we've created a new ACL, and you can use the documentation to copy and paste what's needed. But what we've done is use the set ACL method, and inside of that, in the side of the parentheses, we write new moralis.acl and then pass in the user object. After that, you save the note, and then I've just made the new comment field blank just to remove it, and then rendered the comments again, which is a second function. The render comments just searches the database using a cloud function, which we'll cover another time, and just pulls all of the data onto the front end if it passes the ACL. We can ignore this function. This just creates a new role. We'll look at that in the database security section. We can ignore the run code. It doesn't do anything at the moment. The render comments is just running that cloud function we mentioned. It's not passing in any argument or parameters. It's just running get data, and get data just searches the database and passes back the data. And then once we have a result, it then cycles through them like a for loop, and then just posts and renders the HTML on the front end. And that's it. Then we've just got the standard functions: log in, log out, register a user, sign in a user, check if a user is signed in, and then render the CSS. And that's it. And then some click listeners, nothing else to it. So really the main two functions were the post comment and render the comments. Okay. And the setting of the ACL happens inside the post comment. As soon as you submit that message to save to your database, that's where you set your access control list. And the access control list just simply says, set it to the current user, and then behind the scenes, it will take care of everything for you. So let's go back to our documentation. And this is pretty much what we've just explained. The simplest way to use a moralis.acl is to specify that an object may only be read or written by a single user, and that's what we did. And we initialized a new moralis.acl and passed it the user object. Once you've got your ACL in place, it will then only be accessible to the user that created it, to that current logged in user. But of course, it will be accessible for any device where that user is signed in. Now, we did a standard ACL, which it grants permissions for reading and writing to that particular user. If you want to set individual permissions, such as the read access, maybe removing that, or write access, maybe removing that, then you can do so by using these particular methods. So in this snippet example here, this is a group message that's being created. It's a moralis.object.extend message, and then we're creating a new variable, a new message, of which we're doing a group ACL. And that group ACL is a new Moralis ACL, and that will be the variable where that ACL is stored, and then we can add information to that ACL. So in here, for example, we've got the group ACL.set read access to the particular user, and then you set that value to true or false, and then group ACL.set write access for the particular user to true or false. Now, this example is assuming that there is an array of users which you're cycling through. Let's say there's 50 users that you want to be able to access these messages. You'll pass that array into this for loop, and each one of those 50 users will be added to that ACL. And then at the end, you save the group message.set ACL to the ACL that you've just worked on in here. And that's what that example is doing. So you can individually set different permissions if you wish to within your ACL. So that will be individually setting those permissions, but you can grant permissions to all users at once by just using the set public read access, which was the message in the backend that we saw a moment ago. When you double click on this one, for example, that's the public read and write access flag here. And by public read and write access, we're talking about the read and the write that's clicked as public here. And that's the introduction to security for other objects. Now, when we get into database security, we'll take a look at this in a bit more detail, because we've looked at access control lists, which are specifically within a class or within a database, within the individual items within the database. But there are also class level permissions. So this whole class could have its own permission, which we will take a look at. And then there are roles, and perhaps the roles have a certain level of permission, and different types of security that you can apply to your database. So we'll look at that in more detail in another section. But for now, that wraps up the security for other objects. So let's hop over to sessions next, and we'll finish up this user section together. Okay, so sessions, well, what are they? Well, they represent an instance of a user that's logged into a device, or logged into your application using a device. And they're automatically created when users log in and sign up, and automatically deleted when users log out. Now, you would find the session data over in your database. Now, in this particular case, I only have one session that's ever used this app, and it's me. I've used different users, but it's only ever been one session, just one IP address if you like, and it will be this one. So there aren't that many sessions in here. But in a different database, for example, we would have a lot more information. So in this one, where other public users have accessed this application, there would be more sessions. And you can see there are 26 sessions in this particular example in this database here. Okay. Session objects are automatically stored into the session class, which we've just looked at in the database there, and you can view those from your data browser in the dashboard. And Moralis does have a set of APIs for which you can manage your session objects if you need to. Session is also a subclass of the Moralis object, and you can query and delete the items in the same way that you can with the user object and other custom objects as well. But in this case, in the session class, you shouldn't really need to automatically create the session objects, because they'll be created automatically for you. Now, as you become more experienced with the Moralis server, you'll be looking into triggers, which is further on in this course, and before save, after save are two examples. But unlike regular Moralis objects, the session object will not allow you to use Cloud Code triggers. Okay, let's take a look down at session properties. Okay, so session token is for authentication on the Moralis API requests. So as an example, when I was writing this application to post comments, I used the session token inside of a cloud function, because when I call this cloud function, if I remember where it was, render content, this get data, when I try and run that, I need the cloud function to know that the person trying to get the data has an active session, and that they are an authenticated user, and that they will pass that ACL. So inside of the find function, or find method, to collect that data, I passed it the session token. I'll quickly show you what that looks like. Let's go over to the dashboard. Cloud functions. This is the function here. It's the function called get data. It's just a simple Moralis query in descending order. And the results will simply find whatever is in there. So it just searches all the notes and sends them back. And then the find function will be passed the session token, which is just the user's session token. Automatically, when you run a cloud function, you get this request object, and inside there you'd have the user's details, the user ID, the session token, all of these things. And you can access it by request.user and then just get the session token, which is one of the attributes of the user object. And then it just returns that information back to the front end. So that would be the session token. Okay, so the user, well, that's read-only. It's a pointer to the user object that this session is for. So what is a pointer? What does that mean? Well, if we go back to the database, you can see here that these are the things that we're looking through. And this is the user field here. And you can see that this is like a button. So when you click on that, it's got this object ID in it. When you click on it, it takes us out of the session table into the user table, and it highlights that particular user's object ID. It just turns out that that's user 101. So when you go on session, this particular session is from user 101. So when we go back to our front end, we can see that we are logged in as user 101. Let's log out, and we'll log in as Catherine. And log in. And then go back to our session, refresh. And then we'll go back and see that now when we click on that user object, it is for Catherine33. So the pointer is for the whole user object for that session. The created with field is to tell you a little bit more about how the session was created. And we can just wind up. The action was a login and the auth provider was a password. The action field could have a number of different values: login, sign up, create, upgrade. And the majority of these actions will be automatically generated, such as the login and sign up. But create is when you might automatically or manually create a session by saving a session object. The auth provider key could have multiple values. It can have password, anonymous, Facebook, or Twitter. We don't use Facebook or Twitter really. Password will be the most common. And there's additional information that expires at an installation ID, which you can have a look at in the documentation as well. If during the application build you start removing sessions from the database, either with cloud code or manually doing it or via an API, you might run into some issues where there are going to be some invalid session tokens. So as a rule of thumb, maybe just don't remove those from your server. But if you do run into errors, then this section will be useful for you. And there's also some topics that were opened up on the forum where people have had issues with invalid session tokens as well. So feel free to go and check those out. Okay, down to the session security. We briefly looked at object-related security, but this is now for the specific session security. Session objects will only be accessible by the user in the user field. All session objects will have an ACL, but you can't change the ACL. So querying sessions will only return those that match that particular user. Now it says here that you can configure class level permissions, which we have not yet covered. So that would be like just any other class in the database. But once you've understood a little bit more about how they work, you may want to revisit this section and just read through how you can apply some of these common use cases for session CLPs. And guys, that is our users section. So we've gone into a bit of detail on the logins and authentication and how the information is stored in the database, how you can reset passwords, merge addresses. The linking of accounts, we didn't specifically show an example for, but I will in the next series of videos because we're going to build something that will use that particular feature. We looked at the current user and the current user object, attributes included within there. We looked at building our own custom classes, such as the notes from that app that we built. We looked at security of the objects and how you can retrieve the information. There's quite a few things there that we've started to dive into. So next up, we're going to move over to sending ETH tokens and NFTs and also take a look at the Web3 API, all of which will be incorporated inside of a project that we're going to build together, which will be our web wallet. Now, you may have seen a little bit about this in some of our magazine-related videos, but that's what we're going to build together to get that app working, to utilize this functionality all in one place. So come and join me in the next video, and let's jump straight into it. Hello developers, welcome back to the channel. It's Chris from Moralis, and in the previous section of videos, we looked at the moralis.user object and the users section of the documentation. But now we're going to go over to the documentation and look at something new, and we will be looking at sending ETH, tokens, and NFTs. We're going to build an application that will enable you to send native assets like Ether, BNB, or Matic, and that could be either on the mainnet or a test net. We'll also be looking at transferring ERC20 tokens, and I'll show you how you can send ERC721 and 1155 tokens as well, so they would be NFTs. Now, transferring assets with the Moralis SDK is super straightforward. It requires just a single line of code in most cases. All you need to do is pass it options inside of that function. Now, you can send assets using a bare bones low-level library like Web3.js, but it can be really, really difficult to do because you would need to, for example, know the ABI of certain smart contracts if you wanted to send NFTs. But if you went to head over to Web3.js, and for example, you've got the API reference down here, and under web3.eth, if you went down to send transaction, click on that, it will take you down to the documentation for it. And you can see that in there, if you want to send a transaction to the network, you can do so. The transaction object to send would require these parameters, and some of those parameters might be quite difficult to do, specifically the data. So we have simplified the process to try and make it super straightforward to use, so you can have access to this functionality in your app with just a single line of code. So take a look through this video, and then we will be looking at transferring native assets to start with. And we'll be building through a simple application that would look like this. We're going to transfer a native balance. We're going to transfer ERC20, and I'll show you how to do it for NFTs as well. So when you enter information into these fields and click submit, it will load up MetaMask. You can sign the transaction, and then it will complete. It will appear on Etherscan. You'll be able to verify the transaction, and you will be able to do all of that by following me along in this tutorial. We're going to need to go and get this HTML template. So it's a component that I got from the Bootstrap website. So we'll go over there and grab that in a moment, and then we'll load up Visual Studio Code and go through it together. I'm going to remove myself down here from the bottom right hand side of the screen so I don't interrupt with your coding, and I'll see you in the next video. Head on over to getbootstrap.com, click on examples, and download the examples. It will download a zip folder with all of the following snippets and custom components inside that folder. So go and put that download somewhere where you're going to be working from, because the component that we're going to be using will be the dashboard. It will look something like this. We're going to need to download this, open it up, reconnect everything, delete this chart, delete this table, and just tidy it up, maybe add a sign in button up here, get rid of some of the things that we don't need, and that's what we will use for our exercise. So this is the download. I'm just going to extract this. Once that's extracted, I'll go into the folder and just take out the dashboard code that I want. So I'm going to copy these files and paste them in here. Okay. Now we go over to Visual Studio Code and load up this folder that I want to work from, because these are the files we need to change. So I've loaded up Visual Studio Code. Let's open the folder. There we go. And then find the folder you want to work in. And then once you've found the folder, click on select folder, and it will load up the files in here for you. It may be in another subfolder. Just go and find them once you've loaded that up. Close down these boxes, and then we can jump into, first of all, the index.html. Now, if I right click run this, it's not going to work very well because a lot of things will be broken. If we right click inspect, we can see that it is failing to apply a couple of the styles here. So we need to go and fix the links. The first one is this one here, which is bootstrapmin.css. Now that is inside of this Bootstrap folder, and you'll notice that in the folder we extracted, it actually has the name of the file twice. So we need to go and find and reconnect that. So now it's actually just directly in the Bootstrap folder. So I'm going to remove this and start typing Bootstrap. There it is. It's found it. And then it's found the second folder. It's in assets. It's in dist, in CSS, and it's that one. Okay, good. And so if I save this, it should get rid of one of the errors. I can see on the right hand side, it's gone from 3 down to 1. So let's go right to the bottom, fix the other one, which is this one. Okay, and it's the bootstrap bundle min.js. So I'll try and find that folder again. There it is, assets, distribution. This one's in JS. There it is. That's the file. Good. Save that. Go back. Okay, there we go. We're pretty much where we need to. So let's delete the chart and the table. So we'll go into, oh, there's the table here. So we'll just go from this table tag up to the top. We can just remove that. In fact, we can remove the table responsive div. Keep the title. Now this canvas can also go because that's where the chart will be, and that will probably cause an error. So let's go back to our file. You can see the chart, the table's gone, but it has an error here inside of dashboard.js. It's looking to read an object that doesn't exist. So let's go and remove that. It's going to be this one and possibly this one, but this is the one we don't need anymore. Don't need a new chart. Okay, so this is an immediately invoked function expression. So I'll just put old bootstrap code, and we'll remove this top bit that we don't need, and we'll put our Moralis code in here. So we need to go and initialize and have some login functions and things like that we'll come back to shortly. Let's just go back into our HTML and remove these buttons and maybe just change one of them to a sign-in button. Okay, so that'll be this one here. So let's delete that button and also this button. Maybe have this one as login. And we'll keep the classes as they were. We'll just maybe have ID login. Obviously, you can change that to be whatever you want. So that's just our basic template to get started. Okay, let's get our Moralis boilerplate code inside of our JavaScript. So the three main things that we need to do is to initialize Moralis. So we can just use our typical initialization function here. We'll just make sure that you paste in your own server URL and application ID. And we also need to build out two functions, one to log in and one to log out. Standard stuff. I've seen this many times already before. And we don't need the check user function because I haven't any need for that in this example. But the function for login, we'll connect that to the login button. It's just going to await Moralis to authenticate. And then this one will just be to await moralis.user.logout. So we just need to then connect those buttons. So we'll just paste in a couple of click listeners and then connect them to the HTML buttons. So we've got a HTML button that we'll call btn login, and another one called btn logout, and that will run the individual functions. Let's just make sure that we do have btn logout as an ID in our, that's the login. So btn login, where's the logout? So I think it was called sign out. There we go. We'll just put an ID on there, btn logout, and then we'll just test that, see if we've got any errors. Moralis is not defined. Okay, that's because we need to install the SDK and the Web3. So we need to go back to the HTML, and at the top in the head, we need to paste our Moralis SDK code. So get that from the documentation. Quite ugly, this template, but feel free to reorganize it however you like. And then I'm just going to paste the Moralis SDK in here. There we go. So refresh that page and let's see what other issues we've got. That current server has expired. After updating that, I'll just replace that with my function, my new function, save that, go back to my app. And that should work. So if we log in, there we go, authenticate, and we're signed in. So we don't have anything handling a signed in user, so the page is not going to change. So we'll just check that we get Moralis user object back. And we do. Excellent. So we are signed in. Let's just check the sign out button, run the same function, and it's null. Good. So that seems to work just fine. So now we can use the Moralis functionality. Okay, so let's go over to the documentation. We are going to be taking a look at a few things. So in our sending ETH tokens and NFTs documentation down the left, we already know that sending assets using bare bones low-level libraries like Web3.js is difficult. And now I'm going to show you just how easy it is with Moralis. So if we click on transferring native asset first of all, so that would mean transferring Ether or BNB or Matic on either the mainnet or test nets. And we're going to be looking at running that together. Now, in order to send any native balance, we use await Moralis.transfer, and we need to send through some options. And the options in here, there's a few. There's the type, which we need to hard code as native. It's a native balance that we're transferring. If it was an ERC20 token, we would type in ERC20. And that's what the difference would be here. If it was an NFT, we would be transferring ERC721 and so on. Okay, so this specific version, we're going to be using the type of native. Then what we need to do is provide it with an amount that we want to send, and we need to convert that amount because, for example, if we want to send 0.5 ETH, we need to convert that down to WEI. So that means a calculation is needed to convert it. Now, there is already a helper utility that we can use. It's moralis.units.eth. So if we type in the amount of ETH that we want to transfer, then it will convert that into the number of WEI that it needs to send. That's the second option. That's the amount. And the third option is the receiver. So it's the address that's going to receive the native token that you want to send, or the native balance that you want to send. We need to pass across 3 pieces of information there. This first one we will hard code, but the second 2 we can have as an amount that we will change. So let's go over to our HTML and just produce a simple form with 2 input fields, one for the amount and then one for the receiver's address. At the bottom of those 2 fields, we'll have a button that just simply says send. Okay, so in our code, let's go to our HTML. Let's just find a piece that we want to write into. This is our left-hand side menu, and I think this is going to be the bulk of the content in here. Let's change section title to just application for now. And let's put our first one in here as just native balances. Okay, and this is where we'll put our content. So if we head on over to Bootstrap now, and so we'll just go back in our browser. There we go. And up in home, or maybe docs, we want to find some information about forms. There we go. So let's just go to forms. We click on overview here. And if we scroll down, yep, that'll do. So we've just got 2 input fields and a button. That will work just fine. So inside of the form tag, because I'm not going to actually take the form tag, I'm just going to take the divs. I'm going to copy that HTML, go over to our form, paste that in there, see how that looks. And that should work just fine for now. And then we just need to hollow this out and just make it as we want it. So we'll go back to HTML. I'm going to remove the labels. And just keep the inputs. I'm also not going to have these divs with the text inside it. Just remove those. And I'm not going to keep that checkbox. So I'll remove that as well. Get rid of the label. And all of the divs that are not needed. Let's just refresh that. Okay, we need some placeholders, and maybe we'll just make this sort of like maybe 6 columns or something like that. I'll put that title inside of the div, and then we'll just make the div call medium 6 and add a container. Okay, well, that's just a centralized bit. That should be fine. And so we'll just put a couple of placeholders into these so we know what they are. So the first one will be the amount. And the second one will be the address to send to. Save that, go back. Oh, there we go. Amount send, address to send to. And then this submit button will run a function which we need to write. So we need to put an ID on this. And we'll just call it something like transfer native. Okay, let's tidy up the HTML. I've noticed that this has broken. So we need to close that div. So that connects to this one, and then this one connects to this one, and then that's the button, and then this would connect to this one. Okay, let's save that. And then that just separates the 2 input fields. Okay, fine. So now what we need to do is go and write a JavaScript function that is going to collect the information from both of these fields, and then package it up and send it into our Moralis function when we click this button. So there's 3 different things we need to do there. Let's go and write those out. Let's get the details from these fields first. Do we have IDs from those input fields? We do, but they're pretty ugly. So we'll just say, we'll call this native amount, and then we'll put another ID of native address. Okay, I'll just copy that, save that, go over to our JavaScript here, and we'll just write an asynchronous function, which is transfer native. So let's go and get the values from those input fields. So the first one that we'll do is the address was the first one I remembered. So const address equals document.getElement by ID. The element was native address, and then we need its value. We can copy that, and then we'll go and get the native amount, and we'll call that amount. Okay, so that's the first 2 values from the item. And then what we need to do is go back to the documentation. And then we need to go and get this function. So we'll copy that, paste it in here. And this is the actual sending part. So The options object that we will start to form, well, the first thing is type native. We can hard code that in, that's fine. The next one is the amount, and it's moralis.units 0.5. Well, it's not 0.5, it's going to be an amount that we will give it, which will be this. And the receiver, well, let's just separate these out into different lines here just for simplicity. Okay. And the receiver is going to be an address, which we will give it as the address. Now, what you want to do inside of your code is make sure that you have some kind of checking here, because this address will need to be a certain amount of characters, for example. So you might want to put in some handling to check that. The amount will need to be an amount. It can't be text. So you need to make sure maybe that the HTML or the validation of those fields are in place. But for now, we'll just assume that we're going to enter correct information for this example. Just tidying up that function. And then we would pass that options object into this await moralis.transfer options. So that is transfer native. We need to attach transfer native to our button. We need to create a new click listener here. So I've copied this one, and then we'll attach that to our submit button, which has an ID of transfer native. And then when that transfer native button is clicked, we need to run the function transfer native. Save that, go back to our application. So amount to send, well, let's just see. I think I am signed in. Maybe I'll go to something like Rinkeby. There we go. So with Rinkeby, I've got 7.3 ETH. So let's go in there and try and send an amount. Better just make sure that I have logged in, because the application will need to run moralis.authenticate in order to use these features. So even if I am actually logged in, as I come to this application, it's worth just clicking the login button again to make sure that it runs moralis.authenticate. And then if I go to send one, and to this address in my clipboard, let's see if we get any errors. No errors. And even better, we actually get a MetaMask pop-up here. And then if we just expand this out, Rinkeby test network, it wants to send one to the address that I want to send it to, both Chris test. Let's confirm that. And then we wait. So in our MetaMask, we will see that there is a pending 1 ETH transfer here. I've got 7.32 ETH in one of these accounts. And in the other one, which I'm trying to send to, I have 5.15. Now you can see it only took a few seconds or so, but that one is 6.3. The other one is 6.1. And the transfer was complete. Fantastic. So that is the first part done. That is how you would send balance from one user to another using just one line of code, which includes some options that we're sending through to it. Single line of code, and you can transfer money cross borders from one address to another straight out of your application using Moralis. How easy is that? Okay, let's go back to our HTML then, and let's just change this because it says application, but it's not really application, is it? It's transferring native balance. And then what we want to do is just minimize this one. Okay, so it goes to there. Let's just copy that HTML, move it down one block, because we're going to move over to the next function in our documentation, which will be transferring ERC20 tokens. So when sending an ERC20, you need to know that the contract address of the token and the number of decimals are required as part of your options object. So we're going to be using one line of code, which is await moralis.transfer, exactly the same as before. But the options object will be slightly different this time, because not only do we need the amount and the receiver like we had before, we need to provide the contract address, and we need to provide type ERC20. So what do we mean by contract address here then? Well, if you tried adding any kind of new token to your wallet, for example, in MetaMask, then that's one thing that you'll typically be asked for is what is the token address for that particular asset. So when you try and import a token, it says there, token contract address. So it does not refer to the address that holds your personal tokens, which is just your normal receiver address. It has nothing to do with that. To find out what the address is, you're probably best off going on to something like Etherscan /tokens, or maybe just doing a search for it there. But essentially, it's asking for the address of the location where the actual token contract that manages the logic for that token appears, because each ERC20 token was generated via a smart contract, which just conformed to the ERC20 standard of tokens, but it's the address of that smart contract for that token that you need to find. So let's just take a look inside the MetaMask to see whether I have any tokens that already have a token address. So in this one, I have link tokens. Click on view on Etherscan. Then it will give us a contract address right here. Now, if you don't have any ERC20 chain link from the Rinkeby network, which is what I'm currently using, or the Rinkeby chain, then you can just go onto Google and just put something like free Rinkeby ERC20 or something like that. Sorry, not Rinkeby, free chain link, and then Rinkeby, perhaps, something like that. And then if you scroll down, it will say, here we go, acquire testnet link. So we can just click on that. And then there's some instructions here for how you can go to the testnet link faucet and go and get the tokens that you'd need. Okay, so let's just go back to this and copy that address and just close these ones down. And I'm just going to go back into the code and paste, while I'm thinking about it, that address that I've just taken, which is here. Okay, so let's just comment that out. So we'll just say that that's the chain link address, Rinkeby, something like that. Okay, so what do we need to do next then? Well, we need to go and build a new function, which we'll call transfer ERC20. We'll move that down. And in here, we need to build a new object and go and get some new information from our front end, because we're not going to be using the old one that we built in our HTML. So if we save that for the moment and come back, let's go to our HTML, minimize the native balances. And now we're going to change this to ERC20. That's just the name of the div that we're going to be using. And inside there, so transferring ERC20, let's just change these out. I'm just going to remove some of the HTML I don't want. Let's just maybe put a horizontal rule in between these two. Go back to our app. Here we go. So this will be the next one that we're going to do. And if we go back to our documentation, so contract address and the type ERC20 is what we'd need. So let's hard code ERC20 into our JavaScript, into this one. And we're going to need a contract address. So I'll just go and put that at the bottom. And what did it want us to call that contract address? So we'll call it contract address. And then we're going to be giving it contract, which we don't yet have, because we need to go and find that. I can probably just copy that down. And then we'll create a new, 3 new fields. So we need to go back to our HTML and get our element IDs. So native amount is not going to be that. It will be ERC20 amount. Just change wherever it says native to ERC20. We need a new input field. So I'll copy that whole div. Just tidy up this HTML a little bit. And so that's going to be ERC20 contract. So amount, address, and contract. Amount, address, and contract. Swap these out. Actually, I can just change that to ERC20. Yep. Amount, address, and contract. That's good. Okay, if we go back to the documentation, we're going to be using moralis.units.token. This one was moralis.units.eth, so we need to change that to token. Now, this method actually takes in 2 parameters instead, or 2 arguments instead. And the first one is the amount that we want to send, which is fine. We can pass it that. But the next one will be the number of decimals. Just go back to our Etherscan here. And we'll just see whether it tells us. It does. Okay, so it's 18 decimals there. We'll go back to our code. And we'll just have decimals there. And we'll use that in a moment. Save the changes we've made to our JavaScript and our HTML. Go back. We have to make a change to this one that says address to send to, but actually it's not the address. This is going to be the contract address. And we should also, and this is not ideal, but we should be putting the decimals in there as well. ERC20 decimals. Oop, spell it right. Decimals. And We'll just leave that there for the moment. And then I think we need to go back to our JavaScript with this decimals. We need to collect that information, which we'll just call it decimals. And we'll find it from that value. And then we need to pass it into this, because if we go back to our documentation, close this one. It was passing in two pieces of information into this token method. It was passing in the amount that we want to send and also the decimals. So we need to put the decimals in there as well. So that's the amount. They're the decimals. There we go. So are we using all four? We're using the address, we're using the amount, we're using the contract, and we're using the decimals. And then it will run that transfer function. So we'll save that and let's test it. We'll see whether or not it works. We need to go and connect the button down here. So transfer ERC20. And we need to run the function. We'll copy this one. We'll call this something like function click listeners. And when this one is clicked, we will run this function, but it's going to be called transfer ERC20. There we go. Make sure you change the name of that, otherwise you'll have two functions with the same name. But back in on Etherscan, you'll remember that the contract address was here and the decimals were here. For the sake of this tutorial now, let's just use this information. Later on in this course, I'll show you how you can find more of the details of all of the tokens that you own, but we need to use a different function that we have not yet covered. So for now, let's just use this. So this is the contract address and the decimals to use. We've got that saved down here already. So if we go over to the front end of the application, always make sure that when you test a new function that you just re-authenticate by re-signing in using MetaMask. So let's try this out. We'll try and send 3. Let's try and send some to an address that I have on my clipboard here. There we go. And the contract address we already have copied into our clipboard from the Etherscan. So we can paste that in there, and we know it was 18 decimals. If we click submit, no errors, and there we go. It gives us an opportunity to send it. And then once we click on confirm, that will go through. So we can go and look at what we have. So there's a pending 3 link transfer here. And currently our assets are 117. So this now will change from 117 down to 114 when that transaction goes through. And there we go. It almost did it literally immediately. So it changed to 114. And that's it. That is how you would transfer. So using just, if we go back to our code, one line of code, Moralis.transfer, with some options, we're able to transfer ERC20 tokens cross borders from one address to another using our application with Moralis. And the options that we sent it required some information from our front end. The only 2 tricky things to find were the contract and the decimals, but I'll show you a much, much easier way of finding that from a user in the next section when we look at the Web3 API. But the address, the amount, things like this, super simple to add in. You pass it the type, which is hard-coded as ERC20, wrap that into an object, pass it through Moralis.transfer, and there you go. Very, very simple. And to finish up this section of documentation, there are instructions here for transferring ERC721 tokens and transferring ERC1155 tokens, which are semi-fungible. So what's the difference between the two? Well, typically with an ERC721 token, you will only ever have one of those items, and that would be an NFT, for example. You'll only ever have one of that particular NFT. It'll be completely unique, non-fungible, and so quantity-wise, you will only be able to transfer a single one of them. 1155 tokens, they're also NFTs, but they are semi-fungible, which means that you can actually transfer more than one of them. So maybe there were 100 of them minted originally, or 1,000 or 10,000 of them, and you might want to transfer 5 or 10 or however many. With 1155 tokens, you can do that because there will be more than one of them. But the process for transferring an NFT is exactly the same as transferring any of the other assets that we've transferred already, such as the ERC20 and the native assets. You simply build an object which requires some information, you need to type in ERC 721 or ERC 1155, depending on what type of ERC it is, what type of NFT it is. You need to pass through a receiver's address for who's going to receive the NFT. You need to pass the contract address for the NFT, and you need to pass the token ID for the NFT as well. For this example today, we're not going to actually run through this until we've covered the Web3 API, because most of the time you won't know what this information is off the top of your head. You need to find it somehow. And this Web3 API section will show you how to find that information. So what we might do is just defer the demonstration of this to a later part of the course in here, once we know how to use the Web3 API. And that's it, guys. That is the section for sending ETH, tokens, and NFTs complete. I'm looking forward to getting into the Web3 API section, because our API is a beast. There are so many functions inside this Web3 API that will help you build your applications so much faster. So I'm super looking forward to getting into that. So join me in the next video. So it's now time to move on to a new section. Previously, we looked at the transfer section of the documentation and we covered off a lot of Moralis functionality. But now we're going to be moving over to the Web3 API. So let's head on over to the documentation. We'll click on documentation, and once that loads up, down the left-hand side, let's go to Web3 API, token balances, NFTs. Now, Moralis Web3 API is very, very fast, very, very powerful, and you can connect to it in multiple ways. For example, you can use the standard SDK, so you can install it directly into your application and just call the commands directly. Or if you've built your own infrastructure, then you can just hook into the actual API endpoints directly and go in that way yourself. So for example, if we go to Moralis and then let's just log in and just put in your server login details here. And once you get over to the dashboard or to the logged in section, on the left-hand side, you'll have the Web3 API over here. And you'll see all the different endpoints that you'll have available that are categorized into native, account, resolve, DeFi, and the new one here, which is storage. And in there, you'll be able to get some more information about how they work and what information you would need. So for example, in the curly brackets, you can pass in arguments or parameters to the endpoint to get back different results. And this would be the example of the block endpoint. You've got date to block, all these different ones we'll go through one by one in just a moment. So there's a couple of different ways that you could interact with your API. And of course, this is compatible with all different types of languages. So you could do this using JavaScript, or you could use using Python, or whichever other language you want to build your application in. We're going to start off by looking at using the SDK version of the Web3 API. So that's directly inside the JavaScript. Once we've installed it, we're going to be using functions in vanilla JavaScript. And then we'll come back and take a look at how to use those in React as well. So the rest of the page we've already covered, but these are the 4 categories of the endpoints that we're going to be covering as we go forward. So let's jump into native first of all. The first one that we're going to look at will be get block, but you'll see down the right hand side that there's a number of different endpoints that are available here under the native section. And it'll be the same for account, token, and resolve, and the other ones as well. But what we'll find is that whilst I'll show you how to call these functions and what the information does and what these different parameters or arguments do and how they affect the outcome of the call, I also want to try and incorporate this into a live application that you'll be able to use as well. Now, the scope of this course is to talk to you about Moralis and show you how to use the Moralis functionality. It's not how to create an application using HTML, CSS, and JavaScript. So this is an example of an application that will use the Web3 API, but I'm not going to talk in great detail about how to build this application. I'll just provide you with the code and I'll walk you through function by function rather than build it line by line like some other tutorials that we have. So as an example, we have over here on the native section of the Web3 API, get block as our first endpoint. And we can call this particular function with one line of code by awaiting moralis.web3api.native.getBlock and pass it some options. And this particular endpoint, this particular function has 2 options that you can pass it. You can pass the chain and you can pass the block number or the hash. What it will do is it will retrieve the contents of a block by the block hash. So what does that mean? Well, it will literally provide you with data like this for a specific block in time. So you can almost go back and retrieve a snapshot of the information at a particular time. And it will provide you with additional information as well, such as the difficulty, the gas used, and all of these different output items as well. Let's see how we would build this into a simple application in that case then. We'll go over to our Visual Studio Code. And for the purpose of the Web3 API Native section, I've just built a Web3 API Native HTML file. Inside that, I've got all the HTML and JavaScript that's needed to run this single page. Let's just load that up. And this just gives you some basic ideas of how you might use the functions in the API. So for example, get block data, just retrieve the contents of the block as we've said. So let's just choose a chain. We could use a simple select box for that. We'll choose Rinkeby, let's say, and we'll choose a block of say 100,000, whatever it might be. Get block data. And this particular function just dumps that information onto the screen so we can see what it's got. And you can see quite a lot of information that will come back from it. There are no transactions in this particular example, but with yours it might be different. And then what you'd need to do, of course, is go and fetch that information because it will just post an object on the screen here. You'd want to handle that in your own way, perhaps running through it with a loop. But like we said, the front end side of things is outside of the scope of this. So we're not going to be talking through how you would handle the data, just simply how you would go and fetch it. So the get block data function, if we go and find that, we'll just do a search for get block. There it is. So it's just an asynchronous function. And in this particular example, what I've done is gone and collected information from the front end. And then I built an options object, which passes the chain from the front end and the block number hash from the front end as well. And then with that options object, you just pass it into the function. Await moralis.web3.native.getBlock with options. And then from there, the rest of the code is just about handling it and then passing it into the front end. And you're just appending a simple div element to the front end content div, which is made empty every time the function is run. Super straightforward. So that's how you get the information from getBlock. Let's move on back over to the documentation. So that's get block. The next one that we have here is get date to block. And the idea of this particular function is that if you pass in a date into your options object, it'll run the code and return you back a timestamp and a block. So you could even feed this function with the result of that one. So they would be almost chained together. Get into the habit of always passing through a chain. The default value is going to be ETH if you don't pass it anything. And the date is required. You'll need to pass it in any format that is accepted by Moment.js. So a typical date function or format, something like this, would be fine. So if you were on the front end of your site using something like a date picker, so for example, this one, get date to block, if we were using a date or timestamp picker here, and let's say we chose that date, then you'll just need to make sure that your date function handles that and turns it into a date that's more useful. Alternatively, you could provide it with a timestamp as well. So we went, for example, and looked for Rinkeby for the 20th of October 2021, and it's going to return us with the timestamp, the block, and that would be the date. And we'll just take a quick look on the function for that one. Get date to block. Again, similar sort of thing we have here. The majority of the code is going to just be handling the HTML. My options object I've just spread across a couple of lines so it's easier to read, but obviously you could put that into one line if you wish. But the main one line of code is await moralis.web3api.native.get date to block with the options object. And then everything else after that handles what we get back as a result. So in this example, all I did is I took the value from the date picker field on the front end and I just ran a new date and then got time, divided it by 1,000, turned it into a timestamp effectively so I could run it through the function. You might handle it a slightly different way, and as long as you get a result, it makes no difference. So we'll just go over to the API section as well, click on date to block, click on try it out. You can choose Rinkeby, and in the date you could use milliseconds or a date string. So for example, on our app here, we had a timestamp that came through, so we could just make sure that that is going to return the same thing. Execute that, and there you go, there are the details. Okay. Now, we probably won't demonstrate each one of these endpoints because they're exactly the same. You'll be able to figure those out quite easily once you've seen how it works on the SDK, but I just wanted to show you a couple to give you a feel for it. Okay, so that's get date to block. Now we've got a new one here, which is get logs by address. Get logs by address simply retrieves the logs, and so you've got a number of different parameters that you can use here. It would be you're required to pass in the address, the smart contract address. You also have event topics that you can pass through here as well. And there are a few others, for example, the to block and the from block. So you can take a snapshot of a particular to and from point. You just need to provide in the block number of the beginning and end of the search or the filter. And you can do the same with the date as well. Once you've provided those parameters, you will then get an example result that will look something like this, which includes the data. You also have the block hash. You'll have the block timestamp on the block number as well, and the transaction hash too. So there's some additional information if you need it. You will require some information about the smart contract to use that particular function, however. Okay, get contract events. This particular function will require the ABI of the smart contract that you're looking to query. And what it will do is simply get the events in descending order based on the block number and return an object of the contract events. And so you can pass through the ABI, the smart contract address, and the topic of the event in a format similar to this. So you would put the ABI as an object, save it into a variable called ABI like this. Then you would build your options object with the chain, the address, the topic, and then the ABI variable. And then you pass that options object into Moralis's one line of code, await moralis.web3api.native.getContractEvents. And the example result that you'll get will look something like this. Now, you won't be able to copy this exact code and paste it into your browser because this has got a sort of a shortened address here. So you'd need to make sure that you would paste in a proper address. So these two functions, this get logs by address and get contract events, are all based around smart contracts. And as you already know, a smart contract is a piece of self-executable software that's autonomously activated once certain pre-imposed conditions written in code are met. And they're typically going to be used for swapping tokens, executing trades, withdrawing funds, depositing funds, adding liquidity, things like that. And that information can be emitted out onto the blockchain, and you'll be able to look into that information. So how do you do that? How do you actually find some of this information to use these contracts? Well, if you head on over to Etherscan, and once you've loaded up Etherscan, just do a search for a contract of some sort. So if I was to search for example, Yearn Finance, and just load that up, there's all kinds of information that you can look through on Etherscan about Yearn Finance. So if we went over to contract, for example, you can see all of the contract information that's down here. So we know that, for example, there, the decimals of Yearn Finance would be 18. We would know that the governance, for example, this would be the contract address here. So if we clicked into that, we could then go and get more information about that specific contract. And if you scroll to this contract tab here, you'll be able to take a look at the source code for that contract. And in there, you'd be able to find different events or whatever it might be that you want to have a look at. The contract ABI is available here, and you could use that if you wanted to in some of the searches. But for now, not going to run into that. I'll leave you to experiment with those and try and find some that suits the application that you're looking to build. So let's move down. And the next one that we're going to take a look at in the documentation will be get NFT transfers by block. If we go back to the documentation, it's this one here. And so that retrieves NFT transfers by the block number or by the block hash. Provides in two options. You put the chain and then obviously the block number or the hash. That is required. And if you don't add a chain, then it just defaults to ETH. And this is something that you would get back as an example result. If we go back over to our little application, bring up the console window, and we'll click the button which has been preloaded with the function here. We can see that we get 17 results back from the function that I've just called, which uses this block hash number on the Binance Smart Chain. And we've got 17 different results here that come back, and you can go into all of that information and find out more about that specifically for NFTs. And that is all there is to the get NFTs by block. So that could be super useful if you want to go and find information from a particular block regarding those NFTs. And if we scroll down to get transaction, this one again is another simple one, just two options that you can provide. The transaction hash is required. but the chain is optional, and if you don't pass in a chain, it defaults to ETH. This particular function simply gets the transaction by the transaction hash and returns a transaction object, which would look something like this. And again, there's quite a bit of information that might be included in this. Inside the logs of this particular output, you do actually get information about data and topic. So let's head on over to our application and see if we can get that working as well. And in there, let's just clear the console window. And I've preloaded this button to run this function. It would simply build an options object with the chain as Binance Smart Chain. It looks like we've just duplicated this from the previous one, but let's see if we get the same result. It looks like it's thinking about something, so we'll just wait for that. Oh, there we go. And it has returned a different response. So this is a different function. I think it's just the front end that's not correct. But if we just look at the output for this, we can see that we have new information. And by storing this output into a variable, you'll be able to call any of this information out and use it in your front-end application. So that is how to get the transaction data. Again, super straightforward. And the last function in this section, this native Web3 API section, is run contract function. And it does exactly what it says. It runs a given function of a contract API and returns read-only data. It's asynchronous. There's a few more options compared to some of the previous ones here. The chain is standard amongst all of these. This is a common thing that you're going to find. Function name is going to be the function name. How do you find that? Well, if you go over to, for example, where we were before on the Yearn Finance, the functions that you can see down here have a name next to that. So, for example, function sub, or function div, whatever it might be. Or if we go back, for example, where we were before, here we go, allowance, balance of, decimals, governance. These are the kinds of things that would also be available for you to use. So if we come back to the documentation, that's the function name. It's required. We also need the smart contract address, another requirement, and we need the contract or function ABI. And what's different about this one compared to the previous ones up here, get logs by address, for example, I think was talking about the ABI, or maybe it was the next one, sorry, contract events. Yes, this one here. What's different with the run contract function is that the ABI needs to be passed as an array. So just make sure you wrap it in an array, otherwise it won't work. But again, store it into a variable, put the array inside, put the ABI inside an array inside that variable, pass it in as an option, and then wrap the option in an object and put it through the function. Moralis.web3API.native.run contract function with the options object. The example result that you'll get will obviously depend on the function name that you're running. And this example result, it says string, then depends on what it is that it was trying to get from this information up here. But if we go to the front end of our application here, I'm going to be using, I think I've just copy and pasted the code from here, but I think I'm using a different one. So let's go to the code, run contract function. So that was the old one. The new one, okay, so I've got an ABI here, it's in an array. And we're going to be getting a decimals function. So that's going to return a number based on decimals, and it will be based on this contract address, which is on the Binance Smart Chain. We're going to be running the decimals function. So presumably it's going to provide a number like 6 or 12 or 18 or something like that. Go back to the front end. Run the contract function. Let's just clear the console. Run the contract function 18. Okay, there you go. So that just simply ran the function of decimals in this case and return the number. If you choose a different function to run, it will provide you with a different output, of course. So that's quite a simple run through of the native section of the Web3 API in the documentation. I've shown you how you can run all of the code that's in here and how you can go and find or fetch the information. I've shown you how you can convert some of those functions to front-end applications by utilizing, for example, selects and inputs, and going collecting that information from the front end and then running the function from the application. What you do with the data is obviously down to you, and that comes down to your ability to handle HTML, CSS, and JavaScript in your application. And this is just a basic vanilla tutorial for how to use the native section. I've also shown you how you can go and get the data from the endpoints, requiring the same information as I've just shown you from using our SDK version. So that's great. So that is the native section. In the next section, we'll go and take a look at accounts, and that's when we can start bringing it to life and we can start building an application like this. So this is just a simple web wallet that we've built using the Web3 API functionality. So for example, if we log in and authenticate, then on the left-hand side, we have a transaction section. So you could type in a chain, go and get your Ethereum address. If you want, you could put in a date range from and to. Let's go for October. And then you can go and get those transactions, and it will simply fetch them and detail them on here. And there's options that you can link that off to Etherscan or however else you want to work with this, and all sorts of things you can do to play around with your data. It just sort of brings everything to life. So the hard work that Moralis does is gives you the data, but what you do with it for a great user experience comes down to your skill as a developer. Next thing we can do is look at the tokens and balances. So you have ERC20, the native token balances. We'll be looking at NFTs as well. We'll bring in all of that in. We'll then move on to, once we've completed the account section, we'll move on to the Web3 API token section. And in here, I've got a lot more information to share with you. There's a lot more functions in here. And so we'll go through all of those as well. Great. So join me in the documentation and let's move over to the account section. Okay, let's move on with the account sections. And we'll just quickly take a look through some of these endpoints here. So we've got get transactions. That is just simply going to provide a list of all of the transactions from the user for the specific filter options that you put through, which we'll go through together. Get native balance. Now that is specifically to do with Ether. That is a native balance from the Ethereum network. BNB is the native balance from the Binance Smart Chain. Okay, so they are different to token balances, which is the next one. So token balances would be ERC20 tokens. And so that would be things like your chain links or USDCs or whatever else you might have on the Ethereum network, or other tokens, for example, on other blockchains. Token transfers makes sense. It's to do with your ERC20 token transfers. Get NFTs. Now that's different to token balances because NFTs are ERC721 or ERC1155 tokens, not ERC20. So getting NFTs will simply provide the NFTs from those particular token types. Get NFT transfers is the same thing for the transfers, and get NFTs for contract. Now that's something that's just a bit different because this one will return an object with the NFT count for the specified contract and an array. So the main sections that we're going to be looking at here will be transactions as one section, balances as a second section. So that will include native balances and ERC20 balances separated. And then NFTs would be the third section. Okay, so we'll build all of that into the dashboard application, which we briefly looked at in the previous video. So on the left-hand side of this application, let's just run through. We've got a menu of the different options available in this wallet: transactions, tokens and balances, NFTs, and the Web3 API token section, which is the next video. Further down, we've got the transfer section, which we covered in a previous section of this course, where you can send Ether, you could send ERC20s, or you could transfer NFTs. So I'll show you how that also comes to life as well. And then a bit further down, there is this section which is not going to be in this section of the course at all, which is a portfolio tracker that you could build. That would be a great project for you to build. And then building into our plugins, for example, buying a crypto with fiat and also swapping tokens, which would be the sort of decentralized exchange idea. So that would come later on. Let's refresh this application and let's start from the beginning. So that will be under transactions. So if we go back to the documentation and we'll go back up to get transactions and reading from the documentation, it returns the transactions from the current user or address, and it returns an object with the number of transactions and the array of native transactions. It's asynchronous, so wrap it in an asynchronous function. And then you can pass it any of these options if you wish to. There are some required ones. For example, you'd need to provide the address for the user. And ideally, you'd want to provide the chain as well. Otherwise, it just defaults to Ethereum. So for example, if we go back to the dashboard here, I'm actually logged in to an account on the Rinkeby chain. So if you don't include a chain, then it will you'll get the wrong information from it, and that might confuse you. The address is required. So you can put in your own Ethereum address or anybody else's Ethereum address if you wish to. And if we go back to the documentation, we have the from date and the to date, the from block and the to block, an offset and a limit. So if we go back over here, so let's choose Rinkeby. The address, just go and choose your own ETH address or copy one in. If you're not sure what your own ETH address is, you could utilize a simple function like this one, where you just goes and gets to your own ETH address. The date range, I've put a date picker in here, so I'll just maybe choose this to this. And behind the scenes, I've just converted that and we'll leave these ones empty. We'll click get transactions, and normally it just returns an array and an object, and then you'll need to go and find a way of handling that data, and I've done so with this. So these link off to Etherscan, and I've also shortened the transaction hashes as well. The block number also goes off to Etherscan, and again, that's based on the network that you choose here. Depends on whether it goes to Etherscan or BSC scan or whatever it might be. The age is the age of the transaction. The outgoing is whether it's coming in or going out. The fee that was paid and the value of the transaction. So that's the information that you'd get. And so this is the filter function here. And so you could even choose it by the block range, for example. So I've only got about sort of 8 or 9 different transactions in this list, but maybe we could go back to the block. So 9.3 million maybe, up to maybe 9.6. And then if I get transactions, it should give us more. There we go. All right. That goes all the way back to 9.3. And perhaps there are transactions that are older than that even still. There are. Okay. So that's how you would use the filter function, and what it would be. The offset just simply would offset that. So you could maybe put in an offset of 10. And that would just chop off some of the ones from the bottom there. You could limit the amount of results that you'd get as well. Say 5, and then it would do that, and then maybe you could do an offset. So that is the transaction. Okay, what's next? Get native balance. So what you should just be aware of here is that you'll generally have native balances and ERC20 token balances, and they are different. So for example, on the Ethereum blockchain, the native currency is Ether. Not an ERC20 token as such, it's the native balance of the Ethereum network. Be aware of that. It would be the same on, for example, the Binance Smart Chain. The native balance would be BNB. So that's why we have these two different endpoints here. So for get native balance, typical example of that would be over here on the left-hand side of our menu. Our native balances, if we just click on that, it's going to go and search all the different balances that we have on the different networks. So it's done a search for Ether or Ethereum network. It's done a search on Ropsten, Rinkeby, Gurley, Kovan, Matic, and so on and so on and so on. It shows how much you've got. Now in this particular application, I've also got a transfer function here. So it will block out any of the networks that you're not logged into. And then obviously it highlights the button that you can transfer. I've not connected that function, but you'd be able to do that if you wanted to just send you over to the different section of the app. So how does that work? Well, if we go over to the documentation, we have 4 different options that we can send into this function. One of them is required. That is the address for which you want to be searching for. We have 2 options that are available in the documentation here. One is just a single line of code. So the variable balance just awaits moralis.web3.account.getNativeBalance with nothing passed in. Just be aware that that may now fail because you do require the address as a parameter inside that. But give it a try, see what comes back. And if it fails, then that's the reason why. It's saying the address twice here, but they've now moved. The reason they've added it is because it's now a requirement and not an option. And the second option is something we're more familiar with, as in we have the same line of code, but as inside that function, we're passing the options object, which we need to build. And the 3 options in that case then can be passed through in that options object. The result that you'll get back is simple. It just provides you with the balance. If you want to search for Ethereum and your, all of those individual balances like I've done here, that will require you to make 8 separate calls for those. You can't pass through an array. You'll need to provide each individual one. But most of the time, you're only going to want the balance of the person that's actually logged in to the application. But most of the time, you'll only want the balance of the user that's logged in to the chain that they are currently logged into. Okay, so that is native balances. Let's move down. Okay, so get token balances. That is specifically talking about ERC20 tokens or equivalent, depending on the network, and it will return an object with the number of tokens and an array of the token objects. So let's go and have a look and see what that would do. If we go, for example, into this one, so your ERC20 token balances, let's see what it provides back. This provides a table. It shows 3 particular tokens on this network. So I've got Zenus, Venus, and Chainlink token. Now, I'm logged into a Rinkeby network, so none of this is real. And the additional information here comes from the metadata of these particular tokens. So I've got Zenus as the name, I've got Zenus symbol, how much balance is in there. It actually says 12 ETH, but the symbol itself should probably be used instead. And then the number of decimals and the contract address. So that's potentially pretty useful. So over in the code, I've just gone down to the HTML section of the application, and inside the accordion, because that's what that is on the front end, I've found the ERC token balances, ERC20 token balances. And I've already hard-coded in just a basic table header and an empty table body, which I'll inject content into from the JavaScript. And in the JavaScript side, the function itself does a few things. Now, I've written a function here called getNetworkText, which is going to utilize a Web3 function in order to go and get and return the chain ID. So I've had to initialize Web3, and then I have called to get the chain ID and return that back to this function here. And then by using the chain choice, that's what I'm passing into my options object within the Moralis function. So my Moralis function is tokens, and I'm just going to await moralis.web3.account.getTokenBalances. I'm going to pass it the chain as an option, which will be my chain choice that comes back from this function. So whatever chain I'm logged into on the front end, Rinkeby in this case, it will pass back from that function and put it into my options object. And I'm also going to pass it an address as well, which will be the ETH address. And what I've done is I've initialized an ETH address variable, and I've left it blank. And I've got an if statement here to handle whether or not a search item has been entered in here. Because if somebody wanted to put in a different Ethereum address, for example, they could put that in there, and that's what would return. Otherwise, it just uses the default one for whichever one the user has got. And the rest of this function is just handling that data in HTML. I would probably do this differently if I could refactor it now, so make it more compatible with a React component. So just simply render it a slightly different way and not use this .innerHTML. But this had the effects that I wanted when I was building it in vanilla.js. Okay, so I actually only used 2 options in my options object, and that meant I didn't use the third one, which was this toBlock. So the toBlock, the reason that that's useful is that you could go back to any specific point in time and check what the balances of that particular user had at that moment. So that could be good for record keeping or doing tax, for example, or auditing, whatever it might be. You know, that could be a useful feature for you. Now, I've already handled the data and put that into the application like this. But if we go into the console here, we console log out some of that data. This is the type of information that you get back. This will be the object itself, so you can see the balance, decimals, logo, name, symbol, thumbnail, and the token address. So I've just taken the information that I wanted and put it into this table here. And there are 3 objects because there's link, weenus, and zenus. So each one of these 3 objects would be the different tokens. Let's close this. Let's go back to the documentation and let's move down. So now we have token transfers. Getting the token transfers is very similar to getting transactions. The difference being that transactions would take into account everything: native balances, ERC20 token transfers, and also NFT transfers, whereas this one specifically looks at getting the ERC20 token transfers only. That's from the current user or the address that you use. It returns an object with the number of token transfers, and it's asynchronous. You also have another sort of 8 options that are available here to help you build your options object. And the documentation shows 2 options that you could use. So you could send through the single line of code without any options, but that might fail if you don't have an address that you're sending through. I remember that the address parameter was going to be used in the majority now. So if that's the case, just send through an options object like you're already familiar with. You don't have to send through all of them. The majority of them are optional, but get into the habit of always sending through an address. The example result would look like this, which is less detailed than the options object that you get back from getTransactions. Looks like this, a lot more information in here. But that's because sometimes you're looking at different data, because you might be looking at a different asset. So that is for get token transfers. And let's go and take a look on the front end. Again, just super simple user interface here with drop down. So again, we'll just choose Rinkeby, then paste it in there. And let's see if that gives us anything. So we'll just go, oh, it does. Okay, great. So in this results table, it's pretty similar to the transactions table. I've got a from and a to here, rather than a few of the other options in transactions. It doesn't show what the token was that was transferred, but if you clicked on the transaction hash, it takes you over to the relevant scan site, and you can see that this one was Chainlink, which is ERC20, of course. The next one down was Venus, again, ERC20, and so on. So inside of the result object, you'll have some information that you could use to go and find more information about it. And that's how I did it in my application. So I checked the network that you're on, Rinkeby, and then handled the link for the transaction hash based on the network that you're on. All right, so that is to get the token transfers. So we've covered the transactions, we've covered native balances, and we've covered ERC20 tokens. Let's move over to get NFTs. It does exactly what it says. Now it's going to get all of the NFTs from the current user or address. It supports both ERC721, which is fungible, and ERC1155, which is semi-fungible, if you remember from the previous videos. And it will return an object with a number of NFT objects and an array of the NFT objects. It's asynchronous, so put it inside of an asynchronous function. Now I've only got a couple of options here. Again, address, always recommended that you put that in, and chain, if you don't put one in, it will default to ETH or Ethereum. These three examples that you can see on the documentation here, the first one is just running the function with no parameters included. It may fail if no address is included in there. But the second one has a chain of Ripston. Again, it may fail if there's no address in there. And the third one is more familiar to what we're used to. We build an options object, and then we call the single line of code with that options object included. And the single line of code is moralis.web3api.account.getNFTs. Okay. The example result would look like this. So the output, for example, here shows the information that you'd get from that. It's not particularly user-friendly, so you would just maybe build a for loop that cycles through each one of the tokens that you get back from your function, and then it renders, let's say, the metadata onto some sort of card, bootstrap card in the front end, and then it just makes it easier to use. If we go to the front end of the dashboard and go over to our NFT section, for example, and let's just take a look on Rinkeby. Let's go and grab my own address and then get NFTs here. And then, oh, there you go. That's the example that I had in mind. So you would have just some cards. It renders through. There are 5 NFTs in this particular account. And then it just goes and renders the metadata of each one of those and passes it through. Let's see if it... There we go. And we can see that we have the 5 different objects from each NFT. And inside those objects, you've got that information. So you can see here that there is metadata. Now, the way that I resolve the metadata is to run a JSON.parse. So let's go and take a look at how we use the metadata in the code. So this is the getNFTs function. First 2 lines are just collecting the information from the front end. This line actually doesn't have a separate options variable. We've just put the options object inside of the function call. And then the rest of getNFTs function here is just about using the data. So we have a loop. We are running through all of the NFTs, and for each one of them, we're running some HTML. Again, you could render this a slightly different way, but to get the metadata, I've just gone within each one of the NFTs .result. I have done a JSON.parse around that. And then with that data, you can then call it inside of your template literals and render it into your front end. So this is with vanilla JavaScript, but in React, you'd be utilizing your props when you're building your components. So you would just do it slightly differently. And that's it. And then I've just simply rendered it to the front end with that information, which gives us this. Okay, good. So that is how you would get your NFTs. Let's go back to the documentation. Okay, get NFT transfers, the penultimate endpoint here in this section. Does what it says. It gets the NFT transfers and it returns an object with the NFTs, an array of the NFT transfers. You will always be passing it an address and the chain that you want to search. Otherwise, it's going to be ETH. Now, the rest of these, some of them might be new to us. We've seen offset before and we've seen limit before, but what we haven't seen would be the order, the direction, and the format. So format is quite simple. It just is related to the format of the token ID. So when you get response back from this function, you'll have the token ID here. This is an example of decimal. But if you choose hex, then it would look something more similar to, well, maybe not this because that's quite a high number, but you'll see something that is going to be a relatively larger string. Direction. Now that decides whether it returns both incoming and outgoing NFT transfers, or only ones that you've sent out, or only ones that you've received. When I say you, I mean the address that you've used in this search down here. Okay, so that's the direction. The default value is both, so it will just return incoming and outgoing transactions. And order. Now, this is something that might throw people off a little bit. Now, order, you can choose a number of ways or fields from which to order it in. So, for example, the result is going to be this. And these are all the fields that you can sort by: token address, token ID, so on and so on and so on. Perhaps the most common way of sorting is going to be by block number, because that's just, it's sort of date related, and it would be sequential in some way. But what you're going to do is you're going to be passing through the option of order, and it would be the field name followed by whether it's ascending or descending in capital letters. So if I just show you in a piece of code, let's go and take a look at this on the front end. And if we head on over to the NFTs and scroll down to NFT transfers, again, I've just put all of the different options that are available here into input fields. And so we'll just choose Rinkeby. We'll just go and get my address. Maybe I'll just limit this to 6. And I think I remember putting all of this where when we call this function, it's going to dump it all into cards directly underneath this button. So let's just call that, see what happens. That's the data, or that's the object, options object that I've sent through to the function. And this is all of the data from the search. It's quite small, but you can see all of the details. And I'm just looking at the first 3, for example, because I want to show this order field here. So if I just look at block number 620, 920, 930, 920, so they're not ordered by anything at the moment. So if I just put in block number into this order option, that's not enough. We would also need to then put whether it's ascending or descending by appending the .asc or .desc directly after it like that. And then once you click on search, give it a second to do what it needs to do. And after it catches up, you can see that now it's ordered. So 919, 919, 919. So all 6 of those are now ordered. We're only bringing in 6, so all of the others are not going to be there. You could change the offset if you want to pull in different results. You could also probably refactor the code that I've very crudely written in this particular function, because in here the majority of the code is just HTML management. I've pulled in all of the data from the input fields. I built my options object with those input fields, and then I pass it in. I've console logged the options object, but you pass it into the function moralis.web3api.account, .get NFT transfers, pass it the options object, and from there you then handle it. So I've just pasted it with a for loop, gone through everything, and I've used object.keys to go and for each one just put that information into a card, basically. So again, you could probably refactor that and do it a slightly different way, but that's how I did it in this example. And that is how you would get information back from the get NFT transfers endpoint, but particularly I just wanted to highlight that order. Okay, and then finally, we will head back over to the documentation and finish up with get NFTs for contract. It returns an object with the NFT count for the specified contract and an NFT array as well. There are a number of different options. We're familiar with most of these now. The standard ones, chain and address, we're already familiar with. We have order, which we briefly looked at before as well. So just make sure whichever one you choose, whichever field you want to order it by, you just put .asc or .desc at the end of it. We've got the offset and the limit. We've seen that before. And the format, that's based on the token ID as to whether it's decimal or hex, same as previously. Token address will be the address for where the NFT currently is right now. So the address of the contract. The build is exactly the same as usual. You create an options object with any one of these options that you want to use, and then you feed that options object into moralis.web3api.account.getNFTs for contract. That is it. Now this is interesting here because sometimes you might search for a particular NFT and it's not been indexed yet. So any request, which includes a token address parameter, will start the indexing process for that collection for the very first time if it doesn't already exist. So that's good. And the output would look something like this. If we go over to the front end, take a look. Again, I've just put the options, or the inputs into these front end options, and I've got a couple of things we can use here. This is a Matic example where we can use a user address and we can use a contract address. I've just copied and pasted the user and the contract into those two fields here. And it says Matic, so that's Polygon. So let's put that there, and then we can put get NFT transfers. That will probably be in the console log. Let's go and have a look. Here we go. There's an object that's returned here. The object at the top, I believe, will be the options object that I've formed. And then the response will be this one here. And it only has one that's come back. But inside there, you will find it's an ERC 1155 from OpenSea Collections. So go and feel free to take a look into different ways of playing with that particular NFT endpoint. The code for that particular function, super straightforward. Get NFTs for contract. The majority of the first half is just building the inputs from the front end, then building the options object, console logging the options object, single line of Moralis code to get the information which is stored in the NFT data. And then with that, it would then, you could handle it and pass it over to the front end like this. Again, it's just put it into a card, but you might want to render it in a different way. And that's it, guys. So that has taken a look at the transactions, the native balances, the ERC20 token balances, NFTs and NFT transfers, and how you would use the Web3 API to pull in all of that information, in most cases with just a single line of code once you have built the options object. I hope my explanation has helped explain to you what some of these parameters are and how you can use them. And I really look forward to seeing how you're going to be able to build these into your application and recreate and refactor this dashboard. In the next section of videos, let's take a look through the next section in this API documentation, which is the tokens. Join me in the next one. Okay, tokens. So there are quite a lot of endpoints in here, and I'd imagine that there will be more that are added to all of this Web3 API section as time goes by. But we'll go through each one of these, and again, I've built them into this application over here. Let's just close the console, move over to our Web3 API token, and I've just put them into an accordion of sorts, just so we can see, and then built some examples that we can go and find to get the data. So starting off, the first one, get token metadata, returns the metadata for a given token contract address. It's asynchronous, and the data that you'll get back will typically be the name, the symbols, the decimals, and the logo. An example would be this one here. This is the address, this is the example object result that you would get back. Be aware that this is specifically for tokens. It's not for NFTs. It would be for something like a coin or a token of some sort. Kylan Network is the example result that we have down here. It provides back the name of the token, the symbol, how many decimals it would have, and some other information as well. Up here, we've got two examples that we could use. The first one is getting the metadata for a single token. And the second one gets the metadata for an array of tokens. So you can pass through an array in the addresses field if you wish to. But it's the same idea as before. You build your options object, and then you pass that options object into the function. It saves it into the variable, and then you would handle that the way you would want to on your front end. Let's go and take a look at some examples. If we move over to here, we have the chain. Let's choose some ETH examples. We've got an address here we can search for. So let's choose ETH mainnet. We'll put the address in there. We'll search. I don't think it's going to populate on the front end. It will just be in the console, I believe. Here we are. There's an array of one result. Wrapped ether. That is the name of this contract address. Let's just try another couple. That one is the curve DAO token. And we'll just do a final one. Let's just search on Ripston. And we'll just search for this address. And we'll scroll down. The result is here. And that is DAI on Ripston. The code would be this. So we are just collecting the information from the front end, saving them into two variables, passing those variables into our options object, and then passing our options object into a single line of Moralis code. And then from there, console logging the metadata. Super straightforward function. And that is get token metadata. Let's move on. Back to the documentation. Get token metadata by symbol. Pretty much the same idea here. You're going to get the metadata, whereas the previous one was searching for the address. This particular one will allow you to search by the symbol itself. So in this example, you have a search for link. In the second example, you have an array of symbols that you could search for, and it's looking for both link and Aave. You build your options objects as before, and then pass it into this function. This would be the example result that you get, which is pretty much the same output that you had previously. It's just the way you searched for it was different. Before you searched for the address, and now you're searching by symbol. Let's go and take a look on the front end. Scroll down to get token by metadata symbol. And again, bearing in mind that there are multiple different tokens that have been set up here, you might find more than one result. For example, if I choose link and then search on, let's say, Rinkaby, and then get NFT transfers, 635 different link tokens, which is crazy. So how would you know which is the correct one? But if you've got your own token or a different token that you know is only going to return one, then this is a way to get that information. But if you know the address, it might be better to just use this previous endpoint here. If we move over to the code, it's the same idea as before. You build and get the information from the front end, as I have in that case. I built my options object and then just call it. Console log the details afterwards. Nothing difficult at all. Single line of code for that one. Okay, let's go back to the documentation. Get token allowance. That is the amount the spender is allowed to get from the owner of a contract. Now, I can't demonstrate this example because I don't have a smart contract to demonstrate that has a pre-approved spender owner set up, so I can't go and query this. But in your example, if you're running a marketplace or you have some application where you are already where you already expect this to this allowance to be approved, then this is a way to do that. You run an options object with the owner address, the spender address, and the token contract address, and perhaps define the chain as well. Pass it in, and you will just simply get an allowance back, and that will be the amount that they will be able to withdraw. If the spender is not approved, then you won't get an allowance back here. So you've got to have a smart contract that has a spender approved within the logic of the smart contract. Okay, so I'll leave that one to you to explore further. Get token price. Now that's an interesting endpoint because that actually will allow you to go and get the price nominated in the native token and USD for a given token contract address. Now, getting a contract token address might be difficult to do, but there are websites that you'll be able to do that. For example, if I go over to my front end here, in the get token price accordion, I have a link that we can go onto, and this will give you, for example, Aave's token list. And in here, there's sort of 80 tokens with all the different addresses, for example, for DAI stablecoin, USDC, Tether USD, whatever you might want to look for, Chainlink token, Kyber, MakerDAO, and you could just click on any one of these and go and collect that. Now, the chances are there's a source code as well, so you could probably go and get the JSON. Yeah, you could. So you could actually go and export the JSON, put that into your JavaScript, and then you could do a for each loop around that information and build it, or enumerate it in some way into like a drop-down list for the users. So that's doable, but I haven't done that in this example here. I've just copied a couple of them to put in here. So if we choose DAI first of all, and then just search for that, it shows us that the price is 99.7. USDC, well, that's another stable coin, as is USDT. So let's try a different one. That's going to be Link. And there we go. It replaces the price, and Aave would be there. Okay, good. Now, the code itself is a simple function. Here it is. It collects information from tokens. So, there we go. I have just a simple click listener here, which listens to the HTML button. And then on click, it runs a function called getTokenPrice, and it passes in the value that we put into that input field. So that's pretty straightforward. And then in here, with that data from the input field, we will pass it through moralis.web3api.token.getTokenPrice as an options object, with address being the token. And that's it. And then from there, we just handle that and print the information into the HTML on the front end. And that's getTokenPrice. Super simple, isn't it? So these are great endpoints, very powerful. They do a lot of work behind the scenes. And this particular one, getTokenPrice, I did actually only pass through an address parameter here. I didn't actually pass through an exchange name or the chain. Now, so that meant it defaulted to ETH for the chain, but the exchange name If you don't pass an exchange name, then all exchanges are checked in the order listed above. So it starts with Uniswap, then Sushi, so on and so on, so on. And it searches all of them until a valid one is found, but just be aware that it can take more time to do that. So that's get token price. Let's move down to get all token IDs. So what's get all token IDs? Well, this endpoint might take a while to search for because this is actually going to return all of the NFTs that are attached to a particular contract address. So for example, if you are on OpenSea and the contract address for OpenSea might have hundreds of thousands, maybe millions of NFTs, it's going to go and return an object with all of them in it. And the NFT metadata will actually be resolved as well. So that's going to take a few seconds to come through, but it's incredibly powerful. It requires just a couple of options: the chain that you want to search on, the default is ETH, and the address. Standard stuff. You build your options object, you pass it into this particular function, and it will return a result like this, maybe hundreds of thousands of times, depending on which contract address you search for. So the metadata is the thing to be aware of here, because that needs to be passed if you want to use it. So just run a JSON.pass around the metadata, and then you can just simply use it. It's all resolved, ready to go. You don't need to fetch the metadata from the token URI. If you're still fetching data from a token URI, then stop it and use this instead. If we take a look at it on a front end, the Binance Smart Chain, paste in there. If you press get token IDs, this might take a second. Oh, okay, it wasn't too bad. 481,000 of them. It separates it into pages, and page size is 500. So handle that however you want to by paginating the pages. And the data is as it said in the documentation. So they are the NFTs with all of that information with fully resolved metadata. The code for this one is pretty basic. In fact, it's one of the most straightforward ones. I've just got the information from the front end, passed it into an options object, passed it through the function, console logged the result. That's it. Okay, let's go back to the documentation. Get NFT metadata. It sounds like it's pretty similar to the previous one from get all token IDs, where we had the resolved metadata inside here, but it's not. The metadata that was resolved inside the previous one was for each individual NFT, whereas this particular endpoint is contract level. So it would be the NFT metadata, for example, from Pancake Bunnies. That will be Pancake Bunnies metadata rather than the individual NFT that is included within the contract address. So when you pass through that contract ID into this particular endpoint, it will get you the metadata for specifically Pancake Bunnies. Okay. Again, if you search for this particular contract address and it doesn't exist yet, then it will start the index processing for that NFT collection. To use the NFT endpoint, you only really have two parameters that you can pass through. Build an options object, pass it into this particular function, and then use the data however you want to. In the front end, this is how it would look. You just copy in that contract, put it on Binance Smart Chain, run a search, and it will provide you with, it's still got the previous one. Let's just clear that. There we go. Provide you with the contract level metadata for, in this case, Pancake Bunnies. Okay, let's carry on. So down to get NFT owners. This one's interesting because when we use the order option on this one, you can actually pass through more than one. You just separate it by a comma, and you'll be able to do fieldname.asc, comma, fieldname2.desc, for example. So in the order, you can pass a couple, but this particular endpoint just simply returns an object with a number of NFT owners and an array of the NFT data as well for a given token contract address. There's a number of different options you can pass through. The usual two apply, so the chain and the address. We also have format, which was for the token ID, if you remember, in decimal or hex. The offset and the limit we've seen before, and the order will just simply allow you to sort them. Building the function is much the same way. This is asynchronous, and again, we can just build our options object, pass it through our function, and then we will be able to work on the data that comes back. And there's a couple of other examples of how you can use this function. And also the order option, actually in this example, has two that you can see for yourself. Okay, when you get the results back, they'll look something like this. And it's probably a good idea if you are going to be using the order option to actually use block underscore number is the best one to do, as it says here. So let's go and take a look at that in the front end. And if we go over to the app, get NFT owners. I've got a couple of examples here for Rinkeby, Polygon, and Binance Smart Chain. And I've also got an example of the ordering here to show you how you would use that. So if we look at the Rinkeby one first, let's paste that in here and then choose Rinkeby. Do a search without any ordering first. And you can see there's 6,200 results down here, which it limits it to 500. You'll have to do some pagination, and that's where your data would be. The metadata is already resolved. So again, just make sure you run json.parse on that metadata, and you'll be able to use it in your application. If you wanted to then order it so it's slightly different, so for example, it orders it by the block number, then you just simply put those that data into your search field like that. Inside the code, it's the same as before. The majority of this is just getting the information from the front end, building the options object, calling the function, and then console logging it. Very straightforward. Okay, let's go back. Search NFTs is one of my most favorite endpoints in this entire SDK because it allows you to do so many things when it comes to NFTs. It allows you to search, go and get all of the information across the metadata of an NFT. And a use case I've particularly used this with recently is checking the authenticity of an NFT, checking the minter's address against the address that you believe it to be to see whether or not the NFT is authentic. Fantastic use cases that you can build from this. So it's a tool that enables you to get NFT data based on a metadata search. It's asynchronous and it takes in a number of options. So let's take a look through the options. We've got the chain, which is normal. The default would be ETH. Format, again, that's going to be based on the token ID, and it's dependent on being either a decimal or hex. You have the offset and the limit we've seen many times before already. And these two are new. So Q is the string search parameter. So say, for example, you want to search for CryptoPunks, then Q would be the string that you would use to search for CryptoPunks. Filter, that enables you to choose what fields within the metadata you want to search for within that NFT. So perhaps you just want to search in the description of the NFT, or maybe you want to search the name in the NFT. Maybe you want to search the description and the name, or perhaps you just want to search in the attributes of the NFT if it has any. Global will give you the option to choose the whole metadata set, or you can choose individual ones or combinations of 2 or 3 of them together if you prefer. So that's the filter. That's super useful. When you call that, again, you build your options object, you pass it into the function, and it will return an object of information. And again, super simple to use, one line of code. So let's go and have a look on the front end. Let's load it up. So scroll down to search NFTs. If you've noticed these errors down here, this is to do with the 1-inch plugin. It's missing a couple of images for the decks, which is something it's not going to be covered in this course, but you can ignore that. Okay, so we're going to search on the Ethereum mainnet. We're going to search for Moralis. I've searched for this before. And we're going to search for the name field. It brings up 3 different NFTs here. Let's just expand them all. The first one is this one here. It's not one of ours. That minter address A9A is not ours. So that is an not authentic Moralis NFT. However, Moralis Monastic, which ends in EA8, is, and also Moralis Mogul also ends in EA8. You can see by the minter address here. So you can do a very, very simple check when you do this search. Check it against an address that you know is genuine. And if it's not matching that, then you know that the NFT is not authentic. And that is just a very powerful use case that you can use this particular endpoint to check whether you're actually dealing with an authentic NFT or not. And so I've just searched in name, but I could, for example, search global. I haven't actually done this with Moralis. So I don't know what's going to return. It returns 11. So you could go through each one of these and just take a look, but I'm probably not going to do that. Maybe some of them are genuine, maybe some of them are not. Maybe I'll just check on Rinkeby. Let's just have a look and see what comes up there. Minimize that. So there are 7 on Rinkeby. Some of them actually will be mine because I remember creating some NFTs on Rinkeby myself, so it might be worth having a look through those. But so that gives you an idea of how you would use the search. The limit, the offset, and the format, I don't really tend to use, but you can. But the fields that you choose to search by could be super, super useful. And of course, you can search whatever you like. CryptoPunks. I'm not sure if that's one word or not, actually. If we do a search for that, see what comes back. That's okay, 66,000 results. So what you could perhaps do on there is then go through and have a look at a search against the minter's address, and you'll be able to see which ones are genuine or not. So again, super, super useful. If we go and take a look at the code for that one, there's probably a little bit more to this one. Wait a minute, what am I saying? Of course there isn't. It's Moralis. It's all super simple. It's just one line of code. So the first bunch is just collecting the information from the front end. The second bunch is building our options object. And then we've got one line of code, passing in that options object, and then we console log the results. How easy is that? Okay, let's head back over to the documentation. Get contract NFT transfers. We're nearly at the end of this section. If you need to find the number of NFT transfers, get an array with the NFT transfers for a particular contract address, then this is your endpoint. And again, the build is exactly the same before. Options object, pass it into the function. You get your output that would look like this. All sorts of information in there that you can use and query. The parameters, there's nothing in here that's new. We do have the order again in here, and the order can also be split into two separate ones, so you can pass across two if you need to. But everything else is the same. Make sure that you pass in an address. The chain will default to ETH if you don't select one. The format is for the token ID, and offset and the limit you can choose for the result output. Let's take a look on the front end. Okay, so get contract NFT transfers. Let's just tidy up the console down here. Got an example of an address for Binance Smart Chain. So let's just choose that, paste that in there, and then do a search. See what comes back. Might take a second. Okay, there's over 1 million results there, so I'm certainly not going to spend any time going through that. But you'll see when you go into it that the results will provide you with this information. And once you've got that information, of course, you can do searches on the address that it came from, the address that it was going to. You could also do a search based on the blocks that it was included in, or a date range. You could build that into your own front end and query it however you wanted to. And the last three then, so get token ID metadata. That's useful if you already have the token address and you just want to grab all of the metadata from that. It's cross-chain. You could do it across all of the different ones, ETH being the default. You'll need to make sure that you put in the token ID, otherwise it will fail, and the contract address of the NFT as well, otherwise it will not work. The format is related to the token ID, whether it's decimal or hex. And you build your options object and you pass it in through the function. It's exactly the same as it always has been. We've already seen get NFT metadata, but if you remember, that was a contract level metadata. So that was for the specific smart contract, whereas this now is the individual NFT's metadata given the token ID. I think that one's pretty straightforward. I can demonstrate it, but I think you'll get the hang of it pretty quickly. Get token ID metadata. I've got an example here on Rinkeby. So this will be the contract address. Go and choose Rinkeby and then paste the token ID in here. Make sure there are no spaces. Otherwise, if there's spaces at the end, it's going to mess up the string. Do a search there. Okay, that's all it was. So, and then we have fully resolved metadata from that particular token ID on Rinkeby. The code is simple. I haven't done anything other than just build the front end, pass it in through and then console log the result. Okay, get token ID owners, much the same as the metadata, except it's going to provide the owner's detail back instead of the metadata. There are a couple of other options included in here. So you have the format, the offset, the limit, and the order, which we've seen before. The address and the token ID are required, and the chain will default to ETH if you don't select it. Build your options object, pass it in through the function. You know the score now. It's always the same. There's a couple of examples here. One of them has the block number and the contract type in the order parameter. Go and take a look on the front end. A couple of examples here. I've got a Rinkeby one, so I'm just going to take that contract address, paste it in here, and choose Rinkeby. We'll take that. I think I also need to make sure there's no spaces. There's no spaces. Good. And let's just do a search on that first. Clear the console. Okay, it's just one that's come back there. One owner, it seems, of that particular NFT. And let's see if there's another example. I've got another one on ETH. 73 looks to be the token ID. Pretty different to the Rinkeby one, isn't it? Minimize that. Okay, there are 5 owners for this particular NFT. Okay, so go and do your own searches for that one. So that just shows the number of owners that you get back and gives you the details for them for that NFT. And the final one, get wallet token ID transfers. Returns an object with the number of NFT transfers and an array of all the transfers by token ID. And just looking through these parameters, they're all pretty familiar with what we've seen before. Chain, address, token ID are generally the main ones. And then the other one's format, offset and limit. And then with order, you again can pass through 2 if you like, depending on the field name. You could search any of these and just put ascending or descending at the end, similar to this example here and this example here. You build your options object, you pass it through the function, and then you can do what you like with the data. And this would be the example of the output that you would receive from that particular function. Again, if we take a look on the front end, and I've got a couple of examples here. I've got a CryptoPunk example. So on ETH, let's just choose that. Minimize this a bit. We'll take the address. And we'll take this number here, which is 6,079. Click transfer. I probably should have cleared the console. I'll do it again. Okay, so 8 times. Looks like this has moved around 8 times. So that's what this is telling us. It's giving us an information of the different addresses that this has changed from, and then the different addresses that this has changed to. So that particular CryptoPunk has changed hands these many times, and these are the details that you can look into. So again, if you need to use that in your application, that would be how you would fetch that data. Fantastic. So there we go. So that is tokens. So the next section we'll do is wrap up the rest of this by taking a look at the resolve, DeFi and IPFS section. So on resolve, this is quite interesting because what this does is it takes either an unstoppable domain or an ENS domain and returns an Ethereum address. So why is that useful? The reason that's useful is because when you're going through the Web3 API and you're putting in a token address, an Ethereum address, should I say, you can now replace that technically with a function that puts in somebody's address. So for example, instead of an Ethereum address, you could put in Brad Crypto and it will recognize that it's a URL or a domain and just convert that into its Ethereum address. Let's show you an example. And let's go down to the Web3 API, scroll to the bottom. I've built a little function here that is going to use our resolve API. So I've built a function that will be able to distinguish between whether it is a unstoppable domain or an ENS domain. I'll give you an example. If we typed in here brad.crypto, so it's an unstoppable domain, and we'll click resolve, it will say brad.crypto. That's the Ethereum address that it resolves to. If we were to put in something like vitalik.eth is an ENS domain, we can search for that. And then it says vitalik.eth, that is the Ethereum address. Okay, so that's what it would do. So essentially you could actually put this into your application instead of the Ethereum address, and it will automatically resolve to that as long as you've got a function similar to mine to handle it. If we go back to the documentation, it requires 2 options. The first one is the currency, which is what it wants to be queried against. And the available values are ETH or 0x1. The domain would just be the domain that you're going to be resolving to. Super simple 1 line of code as normal, and the example result will be the Ethereum address. There's a video here that shows how to use that in React as well, that was produced by Malik, so recommend watching that. And if we go over to the code, I've just built a function here called resolve domain. It takes the domain in. So when the button on the front end is clicked, which is this one here, it runs a function, it runs resolve domain, and it passes in a stringed version of whatever is in that input field on the front end. And then we've got some basic error handling. It checks whether there is a domain, and if not, it mentions to do so. And does it end with .eth? If so, do this try catch block here. And what we're going to need to do first of all is enable Web3. And then we're going to need to use a Web3 function that goes and gets the ENS address using the domain. And then it appends the text into the front end. And if not, it provides an error. If it doesn't end with ETH, then it goes to this else, which will try another try catch block, which then resolves using the Moralis function. And that would just pass in the domain into our options object here, and we've hard coded ETH as the currency here. We pass that options object into this function, and then we append the HTML to our front end if it works. And if it doesn't, then we get an error, and it would simply say nope, couldn't resolve. And that's it. Super simple, and it will just enable us to find out what the Ethereum address is of either an unstoppable domain or ENS domain. Back to the documentation. If we take a look at DeFi, we've got two endpoints that we can use. We can get pair address and we can get pair reserves. Now, when you go and get the pair address, we need to go and put together two different tokens, token 0 and token 1 in this example. And then when you search for that using an exchange, say for example, PancakeSwap v2 on Binance Smart Chain, it will provide us back the address for that pair, which will be down here. That's important because if we then want to find out what the reserves are for that particular pair on that particular exchange, we need this address. So that's like the first step in order to use this endpoint down here. Okay, so as far as parameters are concerned, you'll need to provide two different token addresses. So if you remember back on our dashboard when we were looking at get token price, we had this link here which enables us to go and get the contract addresses for certain pairs. You can get any two contract addresses from here. Let's say USDC versus Chainlink as an example. I may as well just do that as an example. And you take both of those, and then we'll scroll down to our, I don't have a user interface for this particular endpoint, but I have got the code which we can copy and paste into our console window here. And we'll bring up what it's found. There we go. So that's our pair address here. And if we open that out, we can see that we've got the details for each one of those two tokens and the pair address. We would then be able to take that pair address if we wanted to feed into our next example in the documentation, which would be getting the pair reserves. So to understand this endpoint, what we'd need to understand is what the decimals are for each one of the two pairs that we're using. Let me explain what I mean. Getting the pair reserves, you pass in the pair address that we previously got, and you pass in the chain that you want to search for. That's just two of the four options that I'm going to use. I'm going to ignore the to date and the to block. So coming back, if you pass in the pair address from the previous endpoint and the chain that you're searching on, and then run that options object through the function, it will return this. But you'll need to understand how many decimals each one of those pairs had. So in our example, in the front end here, we were looking at DAI versus Tether. Both of these examples here are based on 18 decimals. So if we go back to the documentation, these numbers, assuming that they were DAI and Tether, which they're not, by the way, but assuming that they were, then you could divide these numbers by 18, and that will show you the number of tokens of that asset in the liquidity reserves, or in that liquidity pool. So that's what you have to understand, because sometimes, for example, if we're using USDC, I think that's only a 6-digit or 6-decimal pair. So you'll see that this number will be drastically smaller, let's say, than an 18-digit pair for that reason. So you just got to remember that. So if you wanted to put it in your application, maybe you could automatically divide this by the number of decimals from the previous function here. See, then the decimals are included there. If we go over to our Ethereum token list, and let's just go and pick out USDC, dashboard, paste that in there, and go with Chainlink. Yeah, sure, why not? So USDC and Chainlink. Then we'll go over to the first endpoint here, copy this, the dashboard, paste this, change that, it needs to be token 1, 0 and 1. Exchange, PancakeSwap. So the exchange is required, but I'm not going to be looking on PancakeSwap. I'm going to be looking on, let's go with Uniswap v2. Back to the dashboard, change that. So that's on ETH. And let's go and copy these numbers in here. It doesn't matter which order they go around. And then we'll try and search that. See what comes back. Excellent. So we've got a pair address there. Let's copy that. And then let's go back to our documentation and try the second endpoint here. Copy that. Be aware that this needs to be pair_address, not address. And if we just put this in here. player_address. Let's go and get the address in there, change that to ETH, and then search for that. So that's the reserves. And so for USDC, you have this. Sorry, for Chainlink, should I say, you've got this, and for USDC, you've got that. So in this particular example where we've looked at Uniswap v2, that's what's in the liquidity pool as far as the reserves. And you could then divide it by the number of decimals. So for example, the first one we know is 18 digits. So there's 47 Chainlink in the reserve there. And then we could check on the second one, number 1, and divide that by 6 decimals instead. And that's $1,400. So quite a small liquidity pool in this example. And that's how you would build it together. So you can go and search it and automate that however you want to, using the DeFi endpoints here on Moralis. So there are 2 there at the moment, and more will likely be added. So let's move that forward to the IPFS storage. Now I think this one's already been covered very recently by Philip. So take a look through this video. It shows you how to use the upload folder endpoint, and it's very detailed. And that's going to help you if you're looking to build a marketplace or something in that area. And that brings us to the end of this Web3 API walkthrough. I hope you've learned a lot. I hope there was information in there that has expanded your Moralis knowledge. And in the next series of videos, we're going to look through automatic syncing and databases. Welcome back to the channel, guys. We are ready to move on. So we're going to move over to the automatic sync section of the database here. And the reason that this is important is because with Moralis, you have access to a server. And that server has a database where current users' transactions and tokens are automatically synchronized. Let's just load up our database. So in here, if we go to the dashboard, we will be able to see down the left-hand side that the users that have authenticated with applications connected to this database have already had information like their Avalanche or AVAX balance, Binance Smart Chain balance, tokens and transactions, ETH balances, owners, NFT transfers, token, all of these different tables have been created automatically. There are also a couple of custom tables in here as well. So if your user is authenticated, perhaps using MetaMask or Wallet Connect, then you'll automatically have all of that user's information in the database. And the server will monitor these addresses automatically for new transactions and transfers and add it into your database for you automatically. But there will come a time where you will want to watch an address that has not authenticated previously with your application. You might want to watch a particular smart contract event, such as a transfer function or something if you're using like an NFT marketplace, let's say. So this section of the documentation is going to talk you through how you can create synchronizations to specific users' addresses or specific smart contract events. And I'll also give you some tips of how you can avoid some potential problems in the address casing section. So let's jump straight into this. We'll start off with the first section on the left-hand side, user balances and transactions. Okay, so the first key point to recognize here is that Moralis tracks everything in real time. So when you add an address to be synced here, it will pull that information in directly for you. So sync and watch address is the first one that we will cover. And that is quite literally watching a specific address. What you'll need to do is log into your database, into your dashboard section. You'll need to go and view the server details. For example, like this. And on the right-hand side, click on sync, add sync, and the first one we're going to look at is sync and watch address. Now, depending on the server that you have created, your options may be different. For example, the server I have right here is a mainnet server, which means we have access to the mainnet chains. What you'll then need to do is choose the address that you wish to sync, and then choose whether or not you want to sync the historical data as well, or do you just want to sync information from right now onwards. Just be aware here, because if you're looking to watch an address that's incredibly active, it might have hundreds of thousands, maybe millions of historical transactions. So you just need to make a decision of whether or not you think it's worth having all of that additional information or not. But of course, many addresses might just be personal addresses, and there may only be 100 or a few hundred historical transactions. Once you've added an address that you wish to watch and you've chosen the chain, click on confirm, and then once you close this screen and go over to your dashboard, in the left-hand side, you will see watched ETH addresses, and this will be where that new address will appear. If an address appears in this list, Then on the left-hand side, it will automatically pull in the information relevant to the chain that you selected. All of this data will be populated depending on how active that particular user address has been. Let's go back to the documentation. Historical event limit, we've just explained. If a sync job is created that would result in retrieving 500,000 or more historical events, then the option will be disabled and no historical data will be populated or pulled into your database. It just means you need to contact support to upgrade your account. Just have a think about whether you really think that's necessary to do so. But for most of the time, you probably won't come across this. So that is the syncing of an address. And so you can do this one of two ways. You can either go directly into your dashboard and manually sync to an address for each one that you want to use by clicking this every time and adding a new one. If you just have the occasional address that you want to add every now and then that's fine. But there will be times where you might want to sync multiple addresses or many of them. And this process may be time consuming for you. So perhaps you want to do it using some sort of user interface from your front end or something like that. So there may be times where you want to programmatically add an address to this sync and watch address list. So I'm going to show you how to do that as well. And this is a simple application that I've just put together to demonstrate that. So there are two particular functions or three functions in this little app. The first one is to automatically add address to watch. And if you just choose your address, it's for the ETH chain only at this stage. You can easily modify it for Binance Smart Chain, AVAX or Polygon, but this is just ETH. You add the address that you want, choose whether you want to import or not the historical transactions. And when you click that button, it will run a cloud function that automatically watches that and adds it to your watch list. The function below has two things. You need to get the addresses. If I just refresh this, for example, it will be empty. If I get the addresses here, this runs a function that searches the authenticated user, which is me, and it looks inside the watched address table or watched ETH address table here and pulls in all of these addresses. The reason it can do that is because right now that particular table is open for public reading. And the next thing I can do is, for example, select one of these, copy that address, put it in here, destroy the address, and it will remove that address. So if I go back to the back end and refresh that, then that address will now have disappeared. If I want to then go back and add that, I can just simply paste that back in there, maybe import the transactions, press import, and then get the addresses again, and you'll see that it's now added to the front end. And if we refresh the database, it will have also added it here as well. We just jump over to the Visual Studio Code and take a look at how those functions were written. And this is the code. So this is a single page HTML document. Inside the head, I've just initialized Web3, Moralis, jQuery, and Bootstrap. I've installed a Jumbotron. We've got the add address section with some inputs and a button. We've also got the destroy address with some inputs and a button. And then I've got my main three functions, which would be run an import of an address, destroy an address, and get the addresses. To run an import, all I'm doing is just collecting information from the user interface and just deciding whether or not it's true or false that the switch for historical syncing is on or off. And then when I've got the information that I need, I run a cloud function, moralis.cloud.run. I run the watch ETH address cloud function and I pass it some parameters. I need to pass it the address to watch, and I've specifically used this to lowercase method here, which I'll cover why in a moment, to do with address casing. And the second parameter is sync_historical, and that information comes from whether or not the switch on the front end was true or false. So that's this particular first function, and that function runs whenever the button run import address is clicked on the front end. And that button would be this one. If we scroll back up, the next function, destroy address, that collects the information from the front end, and then it runs another cloud function, which is called destroy address, of which it passes through the parameter of an address, and I get my address from the front end. Once that cloud run has completed, after I await it, I then rerun the get addresses function, which we'll cover in a moment, and that just populates the addresses on the front end. Get addresses, it collects some information from a query in the watched ETH address. So you moralis.object.extend the watch ETH address table. You then create a new Moralis query. I've called it monster because I copied the code from the documentation. That was what it was called. I didn't change it. And then I just run a query.find to get a results object. I then create a connection to an empty div in HTML, make sure that it is empty. And then for each one of the results that I get back from the query, I run a for each loop, create a new list element, give each list element an ID of the attributes address. So basically when you create this find, inside of this find object, you go into it, into the attributes, you will find the Ethereum address. We'll cover that more in the database section of this course. And so I will give the list element an ID, and also the text will be the same thing. So the text and the ID will be the Ethereum address. That's it. So there's two new techniques in here. The first one is to do a database query to get all the information and then populate that information on the front end. And then the second one is to run two cloud functions that have the effect of automatically syncing and watching a particular Ethereum address. If you wanted to watch a different chain, for example, AVAX, Polygon, or BSC, then you would just simply need to hook into a different table when you are running these cloud functions. The destroy address would be the same cloud function, but the table that you're running or adding an address to would be different. So I'll leave how you handle that to you guys as to switch between the different ones depending on what address the user wants to look at. Okay, let's go back to the documentation. And we'll scroll down. Monitoring authenticated users. We've pretty much covered this. This just really goes on to say that anybody that authenticates with your application will automatically have their transactions and token transfers and NFTs and balances synchronized into your database without you having to do anything. And the Moralis server will in real time insert and update data into your database. So you can just, with simple database queries, use that information in your application how you need to. Feel free to watch this video for more information on Ethereum real-time and historic transactions. Monitoring non-authenticated address. That's pretty much what we've covered so far already. That's when you want to add somebody else's address to your watch list. They would be non-authenticated. They haven't logged into your application, so you want to watch them. And an example might be something like a centralized exchange's hot wallet or something like that, or an active user of a particular application. Whatever it might be, you would add a non-authenticated user to your watch list. And this section of the documentation makes a reference to live queries, which we'll cover in a bit more detail when we go over to the database section. But that essentially, once you have added an address, will allow you to make a query on the data that's in your database and subscribe to that. So you would get real-time alerts if something was to happen with the data in that table. Watching an address from code, we've just covered that. I've just run through that function with you. You can run a cloud function inside your application that will automatically add an address to whatever table you are looking for. This example is a watch BSC address. We were looking at watching ETH addresses. Whichever one you want to do, you just simply change this to either ETH, BSC, AVAX, or Poly. When you are automatically populating this information from these cloud functions, just be aware it doesn't return anything. So you're not going to get any immediate feedback from these. It will just do the job and add the information directly into your database. Okay, moving down. Unconfirmed transactions. Transactions on any chain, any mainnet or testnet can take a while to be confirmed. So when Moralis does actually find that a transaction has happened, it will oftentimes go into a pending table first and then merge with transactions once it's confirmed. So I would normally have an ETH transactions pending table here with maybe 2 or 3 transactions. And once they've confirmed, they will then remove themselves from that and add to the master table. And you'll see here that in the actual transactions table, there is a field called confirmed, and it will either say true or false. Let's have a look. So inside of the ETH transactions table, if you scroll all the way to the right-hand side, you will see that the confirmed field is here. And there's another thing to be aware of here, and that's to do with triggers, which we haven't covered yet. But it means if you are using a trigger, for example, an after save trigger on a collection, this might fire twice when it flips from confirmed false to confirmed true. Okay, let's go down to disabling user historic sync. We already know that Moralis will sync the past transactions of the users, but it is resource intensive. So there will be a load on the server, both the CPU and the RAM, which you will be able to find in here in the dashboard, each time that process is running. So if you don't need all of the history of your users, then consider disabling the historic sync in the server settings. How do you find the server settings? Well, let's go over to our dashboard and we'll click on View Details. We'll see the settings option here, and then we scroll down, the historic user sync option is there. Okay, back to the documentation. Now, if you do disable the historical sync of transactions, you can still use the Web3 API functions to go and get information from a particular address. So it doesn't mean that you're going to lose out on the information completely, you'll just have to go and collect it a different way. We've covered the Web3 API functions already. You know how to find the endpoints from the server dashboard. On the left-hand side, the endpoint section is here. And of course, we've covered it in our SDK version in our previous section over here. There may be cases where you do not want to disable the historic sync for the simple fact that you want to use database queries. But we will cover that shortly. Okay, smart contract historical events will still work. It's important to just make a distinction between two specific things here. The first part is when you add a smart contract event watch or a user address balance watch, a specific address that you want to watch like this, for example, that is one way that automatic information is pulled into the database. The second way automatic information is pulled in is when you have an authenticated user. So all of your user addresses and balances will be pulled in. So there are two different ways. One is automatic when a user authenticates with your application, and another one you've manually added to watch an address. So if on your database you disable this automatic syncing, that will only have the impact on your users that are authenticated. So meaning anything that you manually add will still continue if you've selected the import historical. I hope that makes sense. So manually adding an address or an event to watch works independently to the disabling of that previous setting. Excellent. Optimization. Here's an example of how you can save some CPU and RAM usage. It's effectively disabled historic sync of the users and just adding a smart contract event sync for the token smart contract. Contract event sync we'll be covering shortly. And the collection schema really just talks about how the information appears inside of all of these automatic tables. There could be multiple tables for transactions, token balances, NFTs, etc. And it could be cross-chain, so you could have all of those multiplied across all of the different chains. And so there are some standards as to what appears inside of those tables. This is an example of the schema for the transactions table, and you can see the types of fields that are available and the types of data that it stores inside them. And this will all relate to the tables that you'll see inside of the database for transactions, for example. Across all the top here will be the fields of which it's related to. And it's the same for token transfers. This is for all ERC20 token transfer events. Token balances. So that's user balances and watched address balances. NFT transfers, once again, that's for users and watched addresses, and that will be for both 721 and 1155 tokens. NFT owners, it's the same idea, both for users and watched addresses. And that is automatic syncing for user balances and transactions. Let's go and move over to the smart contract events. We briefly touched on these already, but the reason why you would want to watch for smart contract events is because you want the ability to have real-time alerts, for example, if something was to happen inside of your application. If you're running an NFT marketplace, for example, you'll want to know or be able to handle when somebody creates a new NFT or offers an item up for listing, or there's been a bid on that particular item or an item has transferred. Each one of those events that happens will be emitted as part of the smart contract, and you'll want to be able to listen to those smart contract events in real time. And we got you. Luckily, Moralis Server has the functionality automatically built in. You can add the specific smart contract event listener. So take a look at this video by Nicholas here. It goes into some detail. And we'll move down to how to define a smart contract event sync and watch. Once again, once you've completed this process, it will add information directly into tables in your database. And to do that, you will need some information specifically from the smart contract. You're going to need 2 or 3 key pieces of information. The first part will be a topic. The second one will be the ABI. And the third one will be the address. You'll need to get that information prepared before you start this process. Once you have that information, you'll then need to decide the table name, which would basically just be the subclass, the table of where you'd like your data stored. I've created one here called note. That's my table class that I've created manually. And then you would be able to do the same thing here. So just a quick overview description, just to help you identify what this sync and watch contract event is for. The topic, that can be provided in one of 2 ways, but essentially this will be listening to the definition for the particular event that you want to sync to. In this example, the event is called bet, and it's passed in, removing all white spaces, just the types of data that that event uses. You don't want the names, you just want whether it's an address or a string or a boolean or an unsigned integer. That would be the topic. Second option is you could provide a hash of that particular topic string. The ABI You should know where to find that if you've created the smart contract yourself. But if you're trying to watch somebody else's smart contract, then you'll need to find the ABI and collect the information from the event that you want to watch. Again, this video goes through that in a bit of detail for you, so go and watch that. The address is the smart contract address that you want to listen to. Create your table name using camel case, and then you can add that. So let's have a look and see what the fields look like here. And then we'll just close this panel here, or go over to the sync, should I say, and then we'll click on sync and watch smart contract events. And again, you choose the chain that you want to be watching for. ETH mainnet, for example. The description can be anything you like. You can choose whether or not this particular sync and watch event will pull in historical data. So you can choose yes or no there. The topic, again, that is based on the event that you want to watch. So if we go for an example over to Etherscan, and for argument's sake, let's just look at Uniswap v2. And let's just choose this one here. Factory contract. We'll just go over and have a look at the contract side over here. Or perhaps the events tab, should I say. And there's an event here called pair created. And you'll see here that you've actually got the topic right there. So if you copied that and come back over to our dashboard, and I'll just paste it in here for now, just so we can see it, you'll see that there are data types and also names. You need to remove all of the names and just be left with the type of data that it is. Remove all of the white space. You can see there's an address. See there's an unsigned integer 256. There we go. Just remove all of the white space. So you're left with the name of the event and the data types inside of the parentheses with no white space. That would be an example of a topic. Then what you're going to need to do is go and find the ABI for that particular event. If we go and take a look at the Etherscan, let's just paste that in there, for example. Back over to Etherscan. Let's go to contract, and we could do a search for pair created, let's say. Well, that's lucky. Okay, so under this, we have the contract ABI section. And in here, you can see pair created. It's a type event. So you could copy out all of this JSON in here, all of this data, and go and collect the specific object that relates to this event type. Copy that into your ABI section here. And then put in the contract address that you wish to watch. Create a table name. Press confirm. And then you will be watching for that particular event. An example of a valid ABI, you can see here you've got the curly braces. You just need to make sure that you pass it in like that. And this example, it says here it's a bet event, and you have all of the previous information there as well. You need the entire object for the ABI. If, for whatever reason, the ABI data contains an ID input, then this will automatically be passed to UID because ID is a reserved input in the Moralis object. And on that as well, we may as well just explain that the underscore, the name fields, also doesn't work. So for example, if it has something like name underscore side, whatever it might be in here, then any of those underscores will not work. You'll have to rename or change them in order to make it work. And if you need to edit any of the information, then you can do so by going into your dashboard and clicking on the edit button. But right now, if you do activate this edit function, you are going to need to provide a new table name, which means that this is a potentially breaking change. In the future, we will re-examine this and update the process for doing so. But right now, if you need to edit this watch event, then you'll need to create a new table name. Now, earlier on, I mentioned that if you get limited based on the number of results that your historical events or transactions will be pulling in, then there might be some additional steps that you'll have to follow. For example, if you start the sync job that would result in retrieving 500,000 or more historical events, then the sync historical option will be disabled and no historical data will be fetched. The contract event or watched address transaction will still be monitored by Moralis, but it requires a trigger to tell Moralis what to do with the data. So you'll need to use a before consume trigger. Triggers will be covered later on in the course. But if you do not use this before consumer trigger, then the default behavior would just be to skip the event and log a message to the dashboard. Here's an example of the before consume trigger. So if you always want to save an event, and you could use this example here. But if you only want to save the event if the transaction is confirmed, so it doesn't do a double call, then you would be able to use this. And that is for smart contract events. And the last section of this part, the documentation, is to do with address casing. I've covered this briefly when we looked at the code just a few moments ago. In the code, I use this toLowerCase method on the address. Now, the reason why that's important is because whenever you go and fetch an address, let's say, for example, from Uniswap here, if we wanted to use this particular contract address for whatever reason, you'll notice that some of these letters are uppercase and some of them are lowercase. Whenever you want to match an address inside of your database, it needs to match the cases, and the database addresses are always lowercase. So if you matched the uppercase version to the lowercase version, it will return false. And then, of course, you're not going to have that information pulled in because it doesn't recognize it's the same address. So it's always a good idea whenever you're doing this in your queries to use the toLowerCase method. Very, very important. Superb. And that is the automatic sync section. The next section is going to be pretty detailed. We're going to jump into the database, start doing queries, objects, live queries, have a look at security and roles, and there's lots of great stuff to jump into. This is where your application will start to come alive. Now, we already know what the database looks like because we've logged into our server. We can see all of the tables and classes that are created when users authenticate with our application or when we've synced and watched contract addresses or events. But now we're going to take a look at creating custom classes, and we'll do the typical creating, retrieving, updating, and deleting items from the database class. And we'll look at how we can do that manually and with code. I've got a simple application here that I've created, just basic boilerplate. I'll sign in and then we'll just be using the console here. There we go. We'll be writing our code in here. Let's go over to the documentation. On the left-hand side, we're going down to database now, and we will start with objects. Now in Moralis, everything that's stored inside of all of these tables and classes are objects. So when you want to create a new object inside of your table, you need to extend the Moralis object. This video here by Nicholas is very good at explaining how you can work with objects. I'd recommend that you would take a look through that, follow along with the instructions inside it. To give you some background information, when you are storing information inside of a Moralis database, the data is schemaless, which means that you don't need to specify specifically ahead of time what key value pairs will be included within each of the objects. You just simply set any information that you want to, and the backend will store it. Any fields that you want to add, you can add them, no problem. So in this example here, we're talking about an NFT game where the characters are going to be monsters. We scroll down. Whenever you're setting information into an object, just be aware of the following: that keys must be alphanumeric strings. Values can be strings, numbers, booleans, or even arrays and dictionaries. We would recommend that you name your classes with a capitalized first character, and that you name your keys in regular camel case with the first character will be in lowercase. To create a new subclass in your Moralis database, you just simply need to use the Moralis object extend method. An example would be down here. Initialize a variable, and then you use Moralis object extend, and then you give the subclass a name. That will be the name of the table once it's created. Once you've created the new subclass, you then can create a new instance of that class. For example, here, monster equals a new instance of the legendary monster subclass that was initialized here. And alternatively, you can use typical backbone syntax like this. If we scroll down, the subclasses can contain a lot of information. For example, a more complex subclass of a Moralis object would look something like this example here. Inside of this, there are three different things that they have. There are instance methods, there are instance properties, and there are class methods. Just be aware of how the object is structured and how the information appears within that object. The method would be saved on the object and can be called. These instance properties will initialize immediately. And in this example, this is just adding a sound property to the particular monster. So monster.sound would now have this string raw attached to it. And in this example, the class method is used so you can spawn and create a new monster. So for example, down here, monster equals monster.spawn. So that's running this class method. And then it's passing in an attribute of 200, which would be the strength. And in this particular method, or this particular function, monster.set is going to add a new monster in the monster class, and it will have an attribute called strength, and it will be given the number of 200. which you can then save to the database. In this particular example, there's no command to save anything. So you could run this code, but nothing's actually going to be saved in the database. We'll have a look at saving objects in just a moment. Okay, if we move on down, you could even use new Moralis.object and pass a class name. And that will also create a single Moralis object with the class name that you've chosen. If you're familiar with ES6 syntax, then you would be able to use extends Moralis object like this, effectively creating a class-based component which passes the class name to the Moralis object constructor. You can then add the sound that was there before. You also then had the instance methods, you can add those, and then also the class methods you can add as static. However, just be aware when using the extends, the SDK is not automatically aware of your subclass, so you will just need to run Moralis object register subclass, similar to what we do on other platforms. And that's not just for Moralis.object. You can also use extends for the Moralis.user if you wish to. There's some examples of how to do that here. And in addition to queries, login and sign up will return the subclass with that custom user in this example. Okay, so that's the Moralis object. Now let's take a look at saving, retrieving, updating, and destroying objects in our database. So what I've done here is I've just separated the documentation from this mini app that we have, and we're going to go over to our database and just create a brand new subclass. In this example over here, the subclass would be called monster. Let's copy this code, paste it over here. And there's a couple of things I'm going to do to change. I'm going to call this creature instead of monster. And I'm going to call the name of the table creature as well. And creature is with a capital C when you're creating a new subclass. And this lowercase creature will be a new instance of the creature object. There we go. And then we've got three attributes we're going to set here. I'm just going to set the strength to 512. I'll set the name to something different. Sirio. Can fly will set to false. You could create as many other attributes here as you want to, and they'll all appear in the database with separate field names. If you don't run save at this stage, then this just will not work. Nothing will get saved into the database. Also, this is saying monster.set. Well, of course, it's now creature.set, and it will be creature.save. The save method is thenable. If you want to run some additional logic, you can. So, for example, you will get the object back. In this example, it's just called monster. I'll leave that as it is. And we're going to alert that a new object was created with an object ID. But if it doesn't work, then we'll get an error, and we'll simply alert a string with the error.message. Let's see what that does. Oh, I must have created a typo somewhere. Let's go back and edit that because consta doesn't exist. New creature, probably saw that already. And there we go. New object created with the object ID. It's pretty small. You might not be able to see that. Now, we haven't awaited anything, so we're not going to receive the contents of the promise. But if we go back to the database and refresh, see a creature table. Here it is. Oh, there. And inside the creature table, if we just maximize the screen, we can see strength 512, owner name Sirio, can fly is false. The object ID was created automatically here, and you've also got the created at and the updated at, which is automatically generated as well. The ACL would be covered in more detail in the security section of this course, but it stands for access control list. And as standard, you get public read and write access to this new item, this new row in the class, and also the class itself will be publicly read and publicly written. So actually somebody could get access to the information in this database as standard unless you change the settings. We'll cover that in a later part of the course. Okay, let's go back to our code. So we've just created our first creature. You can run this code as many times as you like to create as many creatures as you like. Now, each time you run that, a new one will be added to the database. You don't need to worry about conflicts. For example, if you wanted to name something else with the name of Sirio and it had the same strength and all of the attributes were identical, because the object ID that Moralis creates for you will be unique. So there will be no collisions in your classes. Let's go back to the code and we'll try another example. And this time we're going to remove all of the thens and just run this. I've created some new code here. We're going to create a creature called Beric with strength 1024 with the can fly attribute set to true. And then we'll just put save. But if we go over to the database, refresh this, you'll see that you'll have the second one still in that database there. There's a couple of things here. The first thing is this creature subclass wasn't manually created by us. We didn't have to do that before we added data into the table. Moralis takes care of that automatically. If you try and extend and the subclass doesn't already exist, then it will create it once you save the information. If it is already there, it won't create a new one. It will just add to it. And those 4 columns we didn't need to create. They were automatically generated by Moralis. That will happen in every subclass that you create in your database. Let's go back to the documentation. That's pretty much what we've just explained here. This particular example runs things a slightly different way because what we did in our code was to run moralis.object_extend and then ask for a new creature and then separately set the attributes to that creature. But you can pass it directly in as an object to the save method. And when saving items or saving objects, you can save nested objects. There's some information here about how you can do that. So in this example, the child is automatically created on the server just before saving the parent. But in some situations, you may want to prevent the default chain save. And if you want to do that, there's some examples of how here. Essentially passing through this inside of the save method. As for cloud code context, well, this will make a bit more sense when we're more familiar with cloud code and triggers and how to use those. You can pass across a context dictionary that's accessible in the cloud code. You simply build your context dictionary as an object, and then you pass it through in the save method like this. It's typically an operation that doesn't need to be saved in the database, but that you want to trigger. And the application of this could be incredibly useful and will probably make more sense when you're more familiar with cloud code. And that is saving objects. So let's go and take a look at retrieving objects. I ran the code a few times just to get a couple of extra creatures inside of the database here so we can retrieve them from the front end. If we clear the console now. So as you can see, saving data to your server is super easy to do, and getting it out of the server is also just as easy. If we just copy this block of code here, now it's all publicly accessible because we haven't set any kind of access control list or class level permissions at all. So everything is publicly readable and writable, which is dangerous because it means somebody could come along and delete everything out of your table, which is why you need to look at the security side very carefully. And we'll cover that soon. But for now, let's just have a play with retrieving objects. But the code here, so it checks to see whether the table exists. And in our case, it will, although it's not called monster, it's called creature. So we'll just change that. We'll create a new variable called query, which will be a new Moralis query, and it will query our creature variable. And then the next line we have here is query.get, and this looks like an object ID. So if we go over to the database, and if we double click on one of our object IDs here, let's copy this, go back to our app, paste that in there, and we may as well save what we get back into a variable. We'll call it result. And I'm not going to have any of this thenable stuff. I'll just leave it as that. Let's see what that does. And we'll look inside there. And we've got a promise result. We haven't awaited it, so this is why it hasn't resolved it immediately. But let me just go into the attributes here. And here we can see. So that object ID was for owner name Chris, strength 1025, can fly true. So if we now just add a bit more information to this original one, let's go and put the thens back in here. So we get our creature back here. Let's just tidy the code up. Okay, so that's tidied up. And if we have an error, then we'll just alert the error. So we'll just see what that does. And it passes us back that subclass of which inside that had our attributes. Now in here, we could actually run gets. So instead of just console logging, we could run something like that. So we'll go and grab strength, and if it fails, then we'll get an error. Return that, then there you go. It returns the strength of 1025. And again, that's still searching this particular ID. We could change the query that we're looking on and get a different result. If we want to get all of the information, you could run something like this. In this case, we're just console logging all 3 attributes, owner name, strength, and can fly. So they're the 3 attributes that you can get. If we go back to our table, you'll notice that there are things like updated at, ACL, they're also created at an object ID, but you cannot use the get method for those for the simple fact that they are reserved values. You will need to fetch those in a different way, such as this. c.id, c.updated at, c.created at, and c.getACL and run it. That will probably return 0 because we don't have an ACL for any of these. It's just standard default public read and write. So that will probably return null. But if we run this, you can see that you get the object ID, get the 2 dates that we asked for, updated at, created at, and null for the ACL. So that's how you would fetch that information. Let's go back to the documentation and scroll down, and we'll clear the console. So if you need to get information from the Moralis object, you've got another method here called fetch that will allow you to get the latest data currently in the Moralis cloud. And there is another method here called isDataAvailable that you might want to utilize just to do some checking within your app. There you go. So that is creating and retrieving information directly from your database. Again, another video here for updating objects. Well worth taking a look at this. Updating an object is super simple. You could just set whatever attribute you like, and it will overwrite whatever you previously wrote. Always remember that if you don't save it, then it's not going to be stored. In this example, 5 attributes were set, then they were saved, of which with that object, more attributes were set. The attributes were changed here. Canfly was set to true instead of false, and energy was set to 1338 instead of 1337. So Moralis will automatically figure out that only 2 of those attributes were changed, and it doesn't worry about the other 3, keeps them as they were. So you'll notice in this example that this monster energy went from 1337 to 1338. That effectively incremented. Well, there are counter methods that you can use in the Moralis database. One is called increment and one is called decrement. If you just simply pass the field that needs to be incremented or decremented, it will go up by 1 each time it's called. Or you can pass a second argument with a different number, for example 5 or 10, and that would be the amount that it would increment or decrement. Arrays can be stored as a value inside of your object. So there are 3 operations that you can use for updating arrays. You have add unique, and remove. Add simply appends information to the array. If you try and add 2 of the same thing to the array, then this will allow you to do that. However, add unique will not. It will only add a single instance if the 2 are identical. And remove simply will remove all instances of the given object from the array. Now, these are 3 separate operations. So if you try and use all of them together before saving it, then it will not work. You'll need to have a separate save in between each one of these operations. So that's updating. Destroying objects is deleting an object. Again, this will typically require some sort of query to retrieve the object that you'd want to destroy first, but you simply have a destroy method. You can delete single fields by using the unset method. Just make sure that whenever you need to remove something from a field that you don't set it to null. That has some unexpected functionality. Excellent. The next one is relational data. Again, there's another video here by Nicholas that goes into a bit more detail. With relational data, you can create relations for one-to-one or one-to-many. And there's some examples here, or many-to-many relationships. And again, another couple of examples here. And these create relations between one class and another class inside of your database. We'll have a look at that in just a moment. And data types that you can use within a Moralis object will be any of the following. So I've just logged into my database, and here you can see that I've got a class called unit, and inside of here I've got a number of different objects. The objects have various attributes, but essentially what this is would be a database of soldiers or units for some kind of fighting game. And the attributes include things like the upkeep, so the cost of the unit, the movement points. This shows the number of spaces that the unit could move. It has a ranged attack. The first number would be the amount of damage it can inflict. The second number would be the amount of attacks that it does. HP would be the number of hit points for that unit. Abilities could affect its ability in some way. The name is the name. This user is the pointer. This is the user that created this particular unit. So that's relational data. We scroll across. We have a melee attack. Again, that's the amount of damage it can inflict and the number of times it will attack during its turn. The XP is the amount of points that it requires to level up in its evolution. And the accuracy is the probability that attack is successful. Now, this would be based on a game called Westnorth. It's an old turn-based game that I used to play when I was younger. I just wanted to use it as an example to create this data. So in the database, I've got 34 units currently. So let's have a look at some examples of creating, retrieving, updating, and deleting these units. I've got a front end here which just has a couple of buttons. One of them is going to be to get the units, which just goes to the database, queries them, pulls all the information in, and then displays them in HTML. And this button is just going to create a brand new unit. So every time I press this, I've got one down here. Every time I press this, I'll just do it a few times. It was Cathray was the last one. We've got now another 5 units here. So in the database, there's probably going to be a few more. I might have pressed that a few more times. I pressed it 6 times. So we now have 40 different units. Now the code that I created for this was just simple HTML. Again, it's got the Web3, Moralis, jQuery, and Bootstrap libraries loaded. Got a basic Jumbotron with some body content. I've initialized Moralis and I have a login, log out function. Just checking whether a user is logged in, standard stuff. And this is where I've created a new class. So there's a few things that I've done in here. I've extended the Moralis object and I've created a new class called unit. And in each instance of my unit, I've got some instance methods and some properties. And I've also got some class methods as well. But what I want the ability to do is to generate a random number because I want all of those attributes to be generated for me. I want to generate a random name. I want to generate random attributes. I want to generate random abilities. So each time I run unit.create, I want to get a random name, random abilities, random hit point, movement points, experience, random upkeep, a random attack, and random accuracy. So that uses the instant methods and the class methods here. I have a function for creating a unit, which just simply runs unit.create, this class method here, and it saves it, so that will store it into the database. For the HTML render, I've got a getUnits function, and that will run a new Moralis query and find everything. There's no criteria, it's just going to find everything and return it. And for each unit that it finds, it will generate some HTML card and put it onto the front end. As we go down the app, I have actually created some additional functions such as add ability, add unique ability, and remove ability, so you can play around with the different updating array functionality. I've got an unset property function here as well, and a destroy, so we will be able to remove items from the database. And at the bottom of this app, there's a run query function. That's not important right now, but that just simply runs a new Moralis query, getting information where the HP is greater than 22 and where the XP is less than 41, and then finding it. And for each one of those results, we will return an object with this data and put it into this query array, and then we console log that. So if we looked in the console log of the application now, there should be an object already. And there it is. So these are all the items in the database that fulfill that particular query. So this button is running a create unit, so that will run the first function here. And that will run this class method to create a new unit and then set a whole bunch of different attributes and then save it to the database. So let's say we wanted to delete an item. We could go to this one here, for example, Catherine Door, and that will be the object ID we will delete. If we go back to the code, there is a function already for destroy object here. So we can actually just get this. So we query the unit table. We then go and get the item by the unit ID, and then we destroy it. So if I copy these lines, go back here, and we'll just replace this in here. It's a string rather than a variable, and then we run that. Now Catherine Door has gone. And that was the code that we used. We ran the query. We then searched for the particular object ID, which was the name of Catherine Door before, and then we run the destroy method. Another example, let's say we wanted to update the item. Let's say this item here, Kaylatastic. Let's say we want to change the experience points to 45 from 40. We go back to the code. So we'll run a query. We'll get that object ID in there. And then with my unit, we will rerun these two lines. So my unit.set, and we want to set experience points, which is XP, to 45. and then we want to run save. I made a mistake. I tried to save a number as a string, and it needs to be a number. Let's see if this will allow. There we go. And if we refresh that and get the units again, Kalatastic now has experience points 45. Okay, so we've created, we've retrieved, we've updated, and we've deleted data. If we go to the database, the relational data is this one here. This is creating an attribute called user, where it's actually setting the Moralis user to the creation of the item. So if we click on that, that actually takes us over to the user table, and this particular user created that unit. Now that just showed a single user, but if you click on user, it will show all of the users that exist in the database at the moment. Back under the unit, these items were created by a different user. And that gives you a good introduction into objects. So go ahead now and have a look through all of these videos that appear here from Nicholas to fill in some of the gaps. And then we'll head on over to queries. Now, queries is a huge section, and I would recommend spending quite a lot of time on the MongoDB documentation and also reading through and studying these videos that Nicholas has produced here, which will answer a lot of the questions that you will have. But queries will search through your database, which as you get more and more data in it, may have huge amounts of records that you'll be able to filter through, and returns you a results object. And you have a number of different ways that you can go through that data and filter it. The more effective your technique for filtering, the better the results will be. But let's have a look through some of the basic examples. Again, if we just go back to the code that I produced, we looked at a query example here, which had two constraints. We had a greater than and a less than here, and I was searching my entire unit table for all units that had HP that was greater than 22 and XP less than 41. And then it just found that information. I ran a for of loop. I built a custom object, and then I pushed it into an array called query array and returned that back into the console. Back to the documentation. In this particular example, they're looking in the monster class. They're then creating a new query of the monster class, and they're looking for where the owner name is equal to Aegon. They then run the find method, and in this example, they've run an alert, and then there's a for loop with another alert. But what you do with the data at this stage is entirely up to you for your application. You just use the results object and work with it however you like. Now, constraints, another good video here. Take a look into these. There are lots of different ways that you can look for particular items in your database. Not equal to or equal to, greater than or less than or equal to, less than or equal to are some examples. You have a limit method. You have a first method. That just means you just want to get the first one. And you have a skip method, which would be very, very useful for pagination. And again, another video here that's well worth looking through. Let's say your items have come back and maybe there's like 150 results from whichever query that you've created. The with count method will simply show you the total number of rows that satisfy your query, and it will add an additional item into your results object. Just be aware that count operations can be slow and expensive depending on how much data you have in your database. You have ascending and descending methods as well, which allows you to sort the results. You have contained in, not contained in methods. Exists, does not exist methods. Some examples here. And then you can start getting into some more detailed queries. For example, matches key and query method. That's where it looks for matches from another query. And there's an example of that here. So with matches key and query, you would have the inverse, so does not match key and query. You can query if, for example, there are pointers or relations inside of your database. Like before, in our database, we had a relation for the user pointer. And you could use dot notation to search within that relation. So for example, in here, in this matches key.query, you're looking for the object ID. That would be the class name that you'd be looking to search within. And the dot notation object ID would be the field. And you're looking to search this particular query, which was this query up here. So you're looking actually in the pointer, and in my example, it was the user table, and you're looking for this particular query. If you want to restrict the number of fields that are returned from your query, then you can use select and choose the fields that you want in your query. It does automatically build in the object ID created at and updated at fields as well. That would be select. You could also use the exclude to remove any undesired fields. If you do use select or exclude, it doesn't delete any data from the database. You would always be able to fetch the remaining fields by later calling the fetch method. There's lots of different constraints, and combining those together will enable you to make some quite detailed searches. There's a section here on querying array values with some examples, and also about how you could use the dashboard if you wanted to use the API console, the JS console from the dashboard. We did all of our work in the front end using our console log, so haven't needed to use this tool. If you're using queries on string values, you're able to use the starts with method, similar to the MySQL like operator. Or you could use the full text method, although they can be quite resource intensive. There's some examples of both here. Relational queries are interesting because they will enable you to search across different pointers or relationships that you've set up in your database. Again, there's another video here on relations. And the example below is the relationship between a comment and a post. It's looking at finding comments for posts containing images or for posts without images, relational queries by object ID. In this example, there is an include method, which includes the post data in this example. And if you wanted to, you could have multiple fields by using the include method multiple times. There is a count method that you can use instead of find if you wanted to just count how many monsters, for example, or how many of the items that you're looking for would come back in the query. That can be a very useful method. There's a section here on compound queries, and again, there is another video here. It's specifically for advanced constraints. So they would typically have some kind of logical combination, some sort of subquery, so ands, ors. And in this example here, there are two queries. One has search where wins is greater than 150. This one here has where wins is less than 5 in the two different queries. And then there is an or. So it could return results from both of those. You do the same with and that uses this or method. You also have the same with and. But for the anded query constraints, you just run multiple queries. And this effectively acts as the AND operator. For example, there are 4 queries here. And then we are using this Moralis query AND method, where we're running an OR and another OR. And you could wrap those together using this AND method and find the results as normal. And if you need something a bit more complicated than those types of compound queries, then you would be able to make use of aggregates. Now, aggregates are worth studying. Going on to the MongoDB documentation, for example, will give you a lot more background into how to use aggregates. But once more, there is a handy guide here from Nicholas for queries using aggregate. Aggregating data is incredibly powerful, and if you have a lot of data in your database, you will be using this quite regularly. Essentially, what you'll be doing is building a pipeline, which could be an object or an array, which will follow logical stages. Perhaps you want to find some information in the database first, then perhaps the next stage you will want to remove some information you don't want, and then with the data that's left behind, maybe you want to group that in some sort. There could be like 3 different distinct stages there. That's what your pipeline would be building. So that's what this series of videos will talk you through. And there are some key stages to be familiar with. Match is the first one. Match is most similar to the equal to method. Just finds information in your database that matches your query and returns it to the next stage of your pipeline. So in this example, it's going to match whenever the name is barbecue. And this pipeline doesn't have any more than one stage, quite a simple one. And the new query runs the aggregate method and it passes in the pipeline. You have some comparison operators here. So for example, this one has got $GT. That's for greater than. So now we're looking for matches where the score is greater than 15. And you'll see that this is inside of an object. The match is also an object. And the pipeline is also an object. So it can start to look a little complicated when you're adding lots of stages. But when you look at it logically, it's not that difficult to get used to with some practice. So that would be the match stage. Another stage is to look up, similar to the left outer join in SQL. The video on it here. But essentially it allows you to look up the results of another class, of another table, and bring it into your query. And if we scroll down, we've got an example here where a pipeline's being created. The first stage is a match. It's an expression where it's actually looking as an OR. And it's looking for where the from address equals this user address. or whether toAddress equals the user address. So that's these two. And that would be this match object. And then it takes all of that information and it passes it into the next stage, which is where it's actually going to be looking in a different table called token. And it wants to get information from the original database and the new database, the original table and the new table, and save that information as token. And in your data, once it comes back, you will have an output array as token for any matching documents in the token table. And that array might look something like that. You could get a little bit more complicated than that. So the first stage in this particular pipeline is the same as the previous match. It's an expression which has an OR. It's either looking for where this is true or where that is true. And it takes all of that information, passes it into the next stage, which is the lookup. Now from this one, we're looking in the ETH token balance. We're creating some variables here. A token address is going to equal the token address column. User address is going to equal user address, which is actually a variable defined here. It was passed in from the request parameters. And then it builds a new internal pipeline inside of this lookup stage that has its own match stage. And it's looking for an expression, and it wants both of these conditions to be true. Passes that information back as ETH token balance, and then can return the results. But again, it's well worth taking a look through the MongoDB lookup docs if you're not familiar with this kind of syntax. So that would be the lookup stage if you're looking to look inside of another table for your queries. Project is a stage that allows you to choose the data that comes back inside of your results object. Again, there's a video for that here. So in this example here, this project stage, name one. That's basically saying that inside of your results object, you want the name field to be included. If maybe there's multiple fields, then you could separate those and have name, attribute 2, attribute 3 with a 1 next to it. And then your object would include those fields as well. Another stage available is group. And group pipeline is similar to distinct. So you can group by a specific field and it will give you all of the distinct results. And you can perform certain operations on that, like sum operations and totals and averages and things like that. In fact, here are the collective calculations. The group stage will look similar to the other groups, and Nicholas's video will go into some detail about that. The sorting stage is pretty straightforward. With either a 1 or a -1, it will allow you to choose the field that you want to sort your rows in, whether it be ascending or descending order, ascending being 1, descending being -1. You have a skip stage and a limit stage, typically for use when implementing pagination or just restricting the number of results you want to come back. And there is a count stage, which is a pretty straightforward one. So the main ones really that you'll be using would be match, lookup, project, and group. The order in where you have these stages in your pipeline will affect the results that you get back, because each one of the results from the stages gets passed into the next stage. But with this one, you're actually asking for a particular match, and then you're asking for that from the lookup stage, and so on and so on. So depending on the order of these stages will depend on the results that you get. Now, I've only briefly touched over these because a lot of this will involve the use of cloud functions, but the videos that Nicholas has produced here, I would recommend starting at this stage, going through that one by one, just completing that series of videos. Also, if you need more information, you can go onto the MongoDB documentation and find out more about aggregates there, because the Moralis database is essentially a MongoDB database. So aggregating is a pretty advanced technique, but it's incredibly powerful. So once you're familiar with this and your applications are pulling in a lot of data into your database, you'll want to master this particular technique. Okay, the last two options in queries will be distinct and read preference. Okay, so the distinct method will allow you to find unique values. You'll need to use the master key. Distinct is not an aggregate method, it was just part of a regular search method, so similar to equal to, for example. So really there are two ways that you can do your queries. You can use the typical constraints, you can use multiple to limit the results that you get back, or for more complex queries you can either compound the queries or use the aggregate functionality. And a combination of these techniques will enable you to master how to get information out of your database and onto your front end, as essentially any application is going to need to be able to do that. Fantastic, so let's move over to live queries. In the previous section, we looked at how to build queries. We looked at building simple queries and more complex queries. We looked at aggregation. But there is an issue with queries, and that comes down to the fact that whenever something changes inside of our database, that query that we originally had is no longer going to be correct. So for example, I have an array of data here that fits a particular query that I've run, and it's returned 12 results from my database. But these 12 results will always be like this until I run a new query to check whether it's still correct. So for example, if Tommy here, if his attributes were changed somehow, let's say the user changed them, or it was automatically changed, or something else happened that interacted with Tommy's object that changed it, the numbers may now no longer fit within this filter. And maybe, for example, Tommyson and a couple of the other items here changed as well. How would I know that that query is still valid? Well, the only way we'd be able to know is to rerun it, is to rerun the function or whatever returned this object. We'd have to run it again. And it adds a manual process that we might either forget to do or do incorrectly. There's a process there that we might miss. So what ideally we need is a way to be alerted in real time whenever the query like this one changes in some way. And that's where we can introduce live queries. Live queries, as an overview, enables you to subscribe to any query that you've built. It'll provide you with direct feedback whenever something is added or changed from that query. Whenever you subscribe to a query, there will be events if something happens. So if a new record is added or changed or updated, removed, whatever might happen, you will receive information that you can use in your application. And again, this particular section has been covered with a number of different videos from Nicholas. So once you've finished with my video, I'd recommend pausing the course and taking a look through this to get more information on how live queries will work for you. Behind the scenes, a lot of work has been put into making this as easy as possible to use for you, because we're maintaining a WebSocket connection to the Moralis Live Query server. And in most cases, you won't need to deal with the WebSocket connection directly. You can use our standard functionality and reap the rewards from what we've built for you. So the first video is how you would create a subscription, how you would simply build a query, whatever query it might be, and then subscribe to it using the subscribe method. The subscription is an event emitter, so you'll get live query events, and the first time that you call this subscribe method will automatically open the WebSocket connection to that live query server for you. And as soon as it runs, you will begin receiving events, which means you'll need to provide some form of event handling. Now, there are a number of different events. There's open and create, there's update, enter and leave, and also delete and close. Now, they might sound a bit confusing, so I'll try and break them down to be as simple and straightforward as possible. Creating an event. Now, that will fire whenever a record is added to the database that would match whatever query that you're subscribing to. Okay, so assume your database is empty and you've now added a record that matches the query. That would be in a create event. And to handle that, you would write a piece of code like this, subscription on, and then create. You get an object that you can use, and then handle that however you want to. That's creating. That's when a new record is added. Updating. That's whenever a row that matches your query is edited. So it already has to exist. It's just been changed. The enter event. Now that's whenever an existing record that didn't match the query previously now does match the query. So there was an item in the database before, it didn't match the query, but now it's been edited and it does match the query. So it's now entered the query. And again, you get an object back for that. Leave is the opposite to enter. So you've already got some items in your database that do or did match the previous query, but now they've been edited and they've left the query. So the data still appears in the database, it just doesn't match the query anymore. That would be a leave event. Delete event is simply you had a piece of data that matched the query previously, it's now been deleted, you get a delete event. And the close event happens whenever the WebSocket connection to the live query server is lost. Each one of those events, apart from close event, will provide you with an object that you can use and handle however you need to. If you need to unsubscribe and stop receiving events from a Moralis query, then you can use the unsubscribe method. If you need to manually close the WebSocket connection to the live query server, then you can use the close method. Just be aware that it does cancel the auto connect and it unsubscribes all subscriptions based on it. To reset everything up, you'll need to call subscribe again, and that will create a new WebSocket connection to the live query server. You can set up a server URL to the live query server. Most of the time you don't need to do that. But if you need to, this is how you would do that. And if you get stuck with this, you can always open up a ticket in the forum. Now, when it comes to the WebSocket status, you are given access to 3 events to help you monitor everything. You don't specifically get any object back, but you can just handle the event however you need to. Whenever a new connection is established to the live query server, you'll get access to the open event. You could use this as an example. Losing connection, you can use this event. And the error event does provide you with an object that you can use. So that'll help you manage your WebSocket connection. And similar to before, where you could set up your server if you wanted to separately, there is an advanced API that you can use. I mean, our standard API is most suitable for the majority of cases. But in more advanced cases, like having multiple live query servers, we've exposed the live query client for those scenarios. And that's basically a wrapper of the standard WebSocket client. It requires Moralis.liveQueryClient, and then you can create a new instance of that. You'll need to provide some server-specific information, and the details are down here. I'm running the open method. We'll send a connection request to the live query server. When you use the subscribe method, in this way, the query is mandatory for whichever query you want to subscribe to. You can pass a session token if you wish, and if that particular session does meet the access control list, then updates are available. And because the Moralis server is a fork of the Pars server, you can find out more about the live query protocol by following that link there. And the subscription that you get will be exactly the same as if you use the standard API, which you're probably going to be using most of the time. Unsubscribe method and the close method, similar to before. And the event handling is much the same as before as well. We always try and maintain an open WebSocket connection. So whenever a connection is lost to the live query server, Moralis server will automatically try to reconnect. Reconnect happens as standard. But of course, if you use either of the close methods, then that auto connect function is cancelled. Using the standard API, we automatically send the session token to the live query server whenever you create a new subscription. It'll be the session token of the current user by default. For the advanced API, you can set any session token. There's just a little bit of extra management. You'll need to be aware that when you log out or the session token is invalid, you'd need to unsubscribe from the subscription and subscribe again. Otherwise, there's a potential security issue. But like before, that's for the advanced API. With the standard API, the session token is generally handled for you. The next 2 sections that we're going to take a look at will be roles and also security in the Moralis server. We'll start with security first because roles will eventually feed into the security side. And the Moralis server gives you a number of different ways in which you can secure your data. The first way that you can secure your data is by using keys. So for example, when you're initializing your Moralis instance, you'll be using an application ID. We've also seen in other parts of the course that there are some functions that require a master key. So this concept of keys exists in Moralis. And of course, keys are like top-level admin passwords. You should never share this with anybody. And ideally, you should never share this in your source code. Any user was to go and view the page source, they would be able to very easily look down your JavaScript and find that your keys appear automatically in the code. Now, of course, I've just written everything in vanilla JavaScript. And if you're using React or another framework, you'd be able to hide these keys somewhere else. But it just goes to show that this sort of information is publicly accessible unless you protect it. So the Moralis server does give you other ways in which you can secure your data. And there are 2 main ones which would be covered in this part of the course. The first one will be class level permissions, and the next one will be object level permissions. So we'll think about it as class level permissions as CLP, and object level or access control lists as ACL. So if you remember when we were creating new classes, new tables in our database, you didn't have to manually go ahead and create the class. It was automatically generated for you when you added a unit. And by standard, this unit class is publicly available to both read and write. So whenever a new class is created, it automatically provides permissions to the public. And I can show you the class permissions by going to security, class level permissions. And you can see here that the public automatically get access to read, write, and add fields. Now you might not want this, and it would be the same for the users. So for example, let's say you had 1,000 users using your application. If you haven't changed any of the permissioning for this user class, then by default, a specific enough query would be able to look inside of your user database and find out how many users you have. And maybe you don't want that behavior. Maybe you don't want the ability for people to do that. But Moralis gives you the option to switch that off. So for example, you could uncheck read, save that as a CLP, and that will now mean that nobody will be able to read information from your user table. But what about if there is a profile page in your application? What about if this user here, tester, wants to know information that's stored about their account? Now that we've switched off the public read access, no one will be able to access it unless they've been given specific permission to do so. We go back to class level permissions. We can click this icon up the top right and choose the advanced mode, and you'll see that there are actually more operations in here that we can effect. So for example, under the read category, well, read takes care of the get, the find, and the count. So you could individually set these if you wanted to. Write takes care of create, update, and delete. So you could remove or edit any one of those. And of course, the add side of things would be adding fields. So what you might want to do is to allow the public to get information. For example, if they have a specific enough user ID or an object ID, but maybe you don't want them to be able to just publicly search or find information in that database. Maybe what you want is to have a specific role, like administrators, that do have full privileges. Maybe you want a specific user ID to be able to have full privileges. This is where you would be able to set that if you wanted to. For now, I'll just cancel this. There's a video here talking through Moralis database security. After this video, I'd recommend pausing the course and taking a look through that. But essentially, you just need to be aware that the Moralis functionality out of the box does require some configuration, especially if you want to take it to production. We've got some suggestions for some defaults and precautions, and we'll run through those together now. So we're going to be talking you through how to set up class level permissions and access control lists, which will be your application security mechanisms. But just remember that the master key would be able to override those. So really what you want to do is restrict the amount of power that the public have over your data, but you would use the master key inside of your cloud function code. As a rule of thumb, that's often going to be the best solution. So class level permissions would be the first one. After this video, take a look through this security video from Nicholas. It would be like a blanket permissioning across the entire table in your database. And probably every class inside of your database could benefit from having these permissions tweaked to some degree. When we looked in the database a moment ago, we looked at the different types of operations that fell under read and write. Get was able to fetch objects in the table if the object ID was known. Finding is a permission that enables the querying of all of the objects in the table. So it's quite common to disable the find, but continue to allow get to the public. When it comes to writing, it's quite common to disable write for the public, or maybe just specifically provide access to a role of people, like administrators, for example. It's also quite common to disable adding fields to the public, because once the app is live, it's pretty rare that someone needs to add fields to your table. You're able to grant permissions to certain users if you wish to, or completely lock down permissions on all of these operations. So when a user is trying to complete one of these operations, it will run up against the class level permission. If it fails the class level permission, it will not be able to complete one of these operations. But if it passes the class level permission, then it will run into the object level access permissions, which will be the access control lists. That's the next layer of security. So object level would be every individual item within the database. So we've looked at a blanket permission for the whole class, but you can also have access control lists for each individual item inside of your database. We click on this one, for example. This is how we could edit an access control list. And again, you can edit the read or the write access. You could add a specific user, or you could add a specific role once you've created one, like an administrator. And what will often happen when you're creating items for your database is that you will create an access control list there and then at that moment. That would be best practice. So take a read through this information here on access control lists. If we're doing it with code, you get the current user object, store it in user, and then you use the setACL method and run a new Moralis.acl and pass in the user object. So if we head over to the unit table in the database, you'll notice here that each one of the units, no ACL was set. So it is just set to public read and public write by default. So the class level permissions are set to public read and write, and the access control list is set to publicly read and write. Now, if I went to the user table and just change, like I have with these two, the ACL for the users to public read and write, you'll notice that one of them is different here, because what happens is when you log in, when a user logs into your application, this ACL will automatically be set. So whilst you can change it in the database, it will be overwritten when somebody logs into the application. So let's try and log in with a different user here. A3 is the Ethereum address. So I'll try and log in with this address instead. And then if I go to the database, refresh, there you go. So you can now see that this access control list has been reset just by re-authenticating and signing back in. So overwriting the ACL in the user database is probably not the best thing to do, because it'll be overwritten when the user logs back in. But your own custom classes won't have that behavior unless you set it. The best way to set an ACL automatically in code is by using Cloud Code and triggers, which we've not yet covered. But essentially, you're asking the server to listen to whenever a new user is created. And before the user is saved, create an ACL. And then you would use some code that would look similar to this, create an instance of Moralis.acl. And then you would set the public read access to true or false, set the write access, which would mean that everybody has access here. You'd set individual write access to the logged in user's ID and set that user to true. It will mean that only that user will have write access and no one else. So how do we set the ACL to an item in our table? And how do we do that with code? Well, you'd have to go to the function wherever you're creating your object. Now, in an ideal world, you'd be doing this using Cloud Code rather than on the front end, but I won't be using Cloud Code, and this will just demonstrate how it's done. So in my create, this is a class method that I have whenever a unit is created. In here, where I'm setting the attributes, I can now set an ACL before I save the unit. So I'll need to do two things. I'll need to go and get the Moralis user, and I'll also need to use unit, and then I'll call it setACL method. And in there, create a new instance of the Moralis.acl. And I'll pass in the user object. But I need to get the user object, so I can just create that. And we'll save it like this. And now each time this unit is saved, it will set the ACL as the user object. So when we go and look at creating a new item, it should now have disabled the public read and write access and only allow read and write access for this specific user. So let's save that and we'll go to the front end and we'll test it. We'll run create get unit. It's run this. So now if we just go straight to the database and refresh, we should now see, here we go. The very first one that we've created, it now has an ACL. And if we click in there, public read and write is disabled. And this particular user, which is this particular user here, if we click that user pointer, that's the Ethereum address that ends in EA3. So if I come back to my front end, have a look at who I'm logged in as. I'm logged in as EA3, so I'll just run this moralis.user.current and we'll get the ETH address. And you can see it's EA3. By adding that piece of code into the create unit function, we have now added an ACL to each and every unit that is created. So we could run that multiple times. I'll just click that a few times. I'll just refresh the dashboard, go down to the units table. We can see there's now 48 units rather than 40, and each one of them have that created. And if I just go and log out and log in as another one, log out, sign in, just change the account. So now I'm logged in with a different account here. I'll go and press this a few times, go over to our dashboard, refresh, and we'll have a look and see that each one of these now has a different ACL to this one. So if we did a query, we'll be able to find all of the public read and write ones down here, but the individual user that's doing the search will only be able to find the ones which its user ID matches the ACL. And the code that I added was simple. It was just using the user ID, and we've just created a new ACL. We didn't set individual read or write access. We just gave all access to that user. If you wanted to set different ways, then you could use this idea here. This example is setting public read access and setting write access. Of course, you also have public write access and also set read access. And that gives you an idea of how you would be able to set object related or access control lists. Now, what Moralis doesn't do is support column level permission access, which means that you can't expose movement points and ranged, but maybe hide hit points and abilities. This particular class, if you had specific fields that you wanted to hide from your user, then you'd need to create a different class and have that class as completely protected, and this one would be readable. So you'd need to split the data up into different classes. And to summarize what we've done here, typically your class level permissions will be done inside of the dashboard. Your access control lists will be done on an object level, and that should be done in code. And more often than not, that will be done using cloud functions. Now, this example actually shows a new method called setRoleWriteAccess. There would also be setRoleReadAccess, and that's based on roles which we have yet to come back to. And there are some examples here that are worth reading through for ACLs and class level permissions. And below there's a bit more information about the format of an ACL if you're interested in learning a little bit more, and some details about pointer permissions and requires authentication permission, and a bit of an explanation about the examples above. But really, we've just got to be aware that CLP and ACLs interact, and you need to be able to pass both of them in order to get access to the data that you're looking for. You'll need to pass the class level permission, and you'll need to pass the access control list. Otherwise, the request will be rejected. There's a bit more information about that here. And here are some special classes in Moralis that don't always follow those rules. So if we take a look at find, for example, it says normal behavior footnote 3. So it's basically saying that the read ACLs don't apply to the logged in user. So you might disable read access on all objects in a table, but the user that's logged in will still be able to find their details. However, if you disable finding in the class level permissions, it's still going to return an error. And there's some other examples here that's worth looking through and familiarizing yourself with. If for whatever reason you come across one of those cases that's unusual, then you can use cloud code and just use your master key, because you'll be able to bypass the ACL or the CLPs. Because cloud function code, as we'll find out shortly, is very, very useful for validation. So for example, if there's some invalid data that's going to attempt to be stored in your database, then cloud code could weed that out. And validation functions will typically be using triggers, before save, typical examples. And we'll be looking at cloud code shortly. Validation is important for security. You want to make sure that only certain values are accepted and that the data is sanitized correctly. But it's not just validation that you can do with cloud code. You might also want to bypass certain class level permissions or access control lists for certain functions. And the example in the documentation here is, let's say you've locked down permissions for a user to write to, let's say, a post object, but you can, using Cloud Code, allow them to like a post, which is a write function if you like. And you would do that using the master key. You can write as many cloud functions as you need, and you'd be able to call that function from the front end if you needed to. Moralis does allow the user to modify the database by creating new classes and changing the structure of the existing classes in the database. The Moralis server settings does allow you to switch that facility off. You might want to consider that if you're taking your application into production. Otherwise, a user could technically fill up your database with all types of new classes. So there's a number of ways that you can secure your database. You'll still be able to use your master key to bypass any other features that you put in place, but access control lists and class level permissions are well worth setting when you're ready to put your application into production. At this stage, I'd recommend going back up to the top of this section and look at both of the videos that you saw at the beginning. First of all, the Moralis database security, and then the Moralis object security. And then we'll head back over to roles. In the previous video, I introduced you to the security of the Moralis database, and that specifically dealt with things like keys, but also access control lists and class level permissions, ACLs and CLPs. And they're super useful because they can give you control over the user-based permissioning of data inside of your Moralis database. But you're specifying directly a set of users associated with an instance of an object. So in one of my tables here, we've set that certain users are able to access these particular rows and others are not. Some have public read and write access. And so we've got some kind of control over who can access the data inside of this database. And that's fine when the database is quite small. But as the application becomes a lot larger, it's more difficult to manage who has access and who doesn't. The more common way of handling the permissioning is to assign roles. So in a CMS, you typically have an administrator role, maybe an editor role, and each of those roles would have different permissions. And you could assign users to those particular roles, and it would take effect throughout the whole database. And that option is available with the Moralis database. The roles will provide a logical way of grouping users with common privileges to the Moralis data. As standard, you don't have any roles set up. They're completely empty. It's a class on its own that you can add roles to. And you're welcome to add roles manually if you want to, or you can use code. And that's what I'm going to show you how to do in this tutorial. So once we've created a role and we've produced a control list of what it can and can't do permission-wise, we will then be able to go inside of our objects and take a look at them in here. We would be able to assign a role to a specific object, or just ensure that any new object we create has that preset. So again, this table is a table of units. It's to do with a game. And the code that we had to create these units was over here. I had a class method called create that automatically creates the unit. And in a previous section, we looked at setting an ACL. It was just a blanket access control list. And in this video, we're going to make that a little bit more specific now, because that is just too general. Let me show you what I mean. If we go back to the documentation and just quickly going back to our security section, in our object level access control, this is what we previously used. But now I want to split that up. So not only do we have object level access control, but we have role level access control as well, which means I need to make use of these, or specifically this method, set write access and set read access. And on top of that, I'm also going to set the role write access and the role read access. So there'll be 4 methods that I'm going to use there instead of just a blanket one that does it for specifically the user. If I come back to the code, there are a few things that I'm going to need to do here. So we're going to create a new ACL, but also outside of this create unit class, just want to write a couple of new functions. First function that I'll do is just to create a brand new role. And the second function we'll do will be to add users. Add users to role. And we can call these functions and build them into our application somehow. So if we start with this one here, let's just call this one create role. We'll make it asynchronous. And inside the function body, we'll do two things. We need to assign an ACL here. And then we need to create the role. Creating the role is nice and simple. We can just run new Moralis role as per the documentation. And we want to be using the Moralis role property here. And to create a new Moralis role, we're going to be rewriting something similar to this. So we'll let our new role be a new Moralis.role instance. We need to give it two things. We need to give it a name and we need to give it an ACL, which we've not yet written. So we'll do that up here. Finish that in a moment. And we'll just call this something like the admin. Once we've finished, we can save it. And then we need to write some ACL. So we'll just do a new Moralis.acl. And inside of that, we need to set the public read access and the public write access. We'll set those both to true. There we go. So now we've created a new role-based ACL. We can pass that into our new Moralis role. So whenever we run this function, we will have a new role. And what you could do is make this function a little bit more complex. So you could pass in some arguments here. So maybe you'd pass in the name. Instead of hard coding the admin, maybe you would name it in the function call. You could declare these as part of the function call as well and pass those in, however you want to work it. But for now, I'm just going to hard code it. So save that. Go back to our application, refresh, and then we'll run create role. It will return a promise. And if we go back to our dashboard and refresh, we should, in the role, see one. We do. Excellent. So we've got a brand new role here called admin. We're not using it anywhere in our application, and we also don't have any users assigned to it yet. That's the next thing we need to do. We need to go and assign some users. So what we'll do here for the add user function is we'll run a query where we'll search for this admin role. We'll get that result back. And then we'll add the current logged in user to that admin role. Let's call it something like add users to role. We'll make it asynchronous. And inside of the function body, we will do a couple of things. So we need to create a new query. So we'll run a new Moralis query, and we need to check inside the Moralis.role table. Then with that, so we want to check the name field. And perhaps what we'll do is we'll pass in a name into this function. So when we run the function, we'll run in a string of the admin. And then it will check the name field in our database under the role. We'll check the name for the admin. Okay, so that's that bit. What do we need to do then? We want to get a result. So we'll get the first one back. And we'll await that. And if we get something back, then we want to add users to it. So how do we do that? So let's go over to the documentation. You can add users and roles by using this code here. So we want to do the add users to role. So for us, we can use the method getUsers and then chain the add method to that as well. Let's go back to the code. So we can do result, getUsers, and then we will chain current logged in user. And then after that, we need to save it. Looks good. So add users to role, I'll save that. Go back to the front end and we'll do a search for the admin. Okay, I have an error. Query is not defined. Line 181. I want a query. Okay, because it's role query. There we go. Copy that, save it again, go back, run that again. And now, if I go back into the database and refresh that, and if we click in users, we should, yeah, there we go. We see a new user added to that role. I'll just come back to the application. I'll log out. I'll go and sign in with a different one. This one is 65D. And we'll log in with this one. Then we will rerun that function, go back to the database, and now we should see two. There we go, 2 users that are now part of the admin role. Excellent. The final thing we need to do is come back to this ACL for whenever we create a new unit. And rather than have this blanket ACL, we now need to set one. So every new unit gives the admin access to read and write it. So I'm going to blank this one out and write some new code in here. So I'll take this line here. So we'll let our ACL now be a new Moralis ACL. And then we'll start adding some things to that. There's 4 things that we need. We need to set the read access and the write access. There'll be 2 things in here. We need to pass the user, and that's true. Because it's not set public read access, it sets user specific. We're going to be passing in our user into this and give them the true flag. So the user will be able to read and write, but the public will not. And we also need to set the role write access. What I'll do is I'll copy both of these. And instead of the user, we'll now call the role. And for us, it's going to be the admin. And make that a string as well. And we'll pass in the ACL there, and then you can save the unit. So if we save that, and we'll go and create a few units to test this out. 1, 2, 3, 4, however many. If I refresh this, go over to our units, we should have more than 56 now. We've got 60. And if we go and take a look at the access control list, we can see that not only has the user got read and write access, but also the role of admin has read and write access as well. So now every time a new user is added, the admin will be created. So you don't need to handle your users anymore. You just need to make sure that the role of the admin, the users that are in here, are correctly managed. So that's just one role, but you could do that multiple times. So that's just the admin role, and you could set different permissions for each one. And you could have hundreds of different roles if you wanted to, and apply them to your tables in whichever way you like. So now we know how to set access control lists, class level permissions, but also roles and access control lists for those roles. So I hope that video helped. Take a look through the rest of the documentation in here to explain a few things about role objects, also role-based security for other objects and role hierarchy. But the video shows you how to not only change the details in the dashboard, but how to write those permissions inside of your code. Congratulations, you've got to the end of the database section. So for all you lovely technical people, here are some technical details on data storage for your Moralis database. First things first, you don't need to worry about how data is saved while using the Moralis SDK. We will do whatever we can do to make sure that the data is saved in your database correctly. But by knowing a little bit more about how the data is stored on the Moralis platform, you'll be able to avoid some possible issues. So first of all, if we start off with data storage, Moralis stores data as JSON, so feel free to use any data type that can be converted to JSON. There's a section here called Data Types and Objects. This guide shows some platform-specific examples. Your data will normally be stored in objects, so you'll be familiar with using key value pairs. Just make sure that you don't use any $, full stop, or underscore types as at the beginning of your keys. They're reserved for the framework to handle additional data types, and they'll throw an error if you use them. Key names have to start with a letter. Make sure that you're only using numbers, letters, and underscores within the name of the key, but values can be anything that is able to be JSON encoded. As far as data type lock-in, be aware that whenever you create a brand new class, you don't need to define the object schema yourself. Moralis will take care of that. But a field is locked once it's set. So if you set a field name to the type of number or string, then that field will be restricted to specifically either that number or that string, whatever it was initially set to. If you try and change it to something else, then the server will throw an error. And one special case is that a field can be set to null no matter what it is. The data browser, which you're pretty familiar with already, is the web user interface where you can do your updating and creating of objects in your apps. Always keep in mind that the object ID, the created at and the updated at fields cannot be edited, and they're set automatically. And those little hints will just make sure you don't run into any problems with the data in your Moralis database. Excellent. So that wraps up the database section. Let's move over to Cloud Code. I hope you're learning plenty as we go through this course, because in this next section, we're going to be looking at Cloud Code. We'll start off with Cloud Functions. So what are Cloud Functions? The short answer is that Cloud Functions are how you run JavaScript code on the server side, rather than the client side in their browser. So Cloud Functions are basically server-side code, and the server-side code is not revealed on the client side. Because of course our front end, if we view the source, we can view all of our JavaScript functions hidden away in our JavaScript files at the bottom of our code. Server-side code is not accessible that way. So what's the point of them? Why do we need to use them? Well, there's lots of different reasons why you would use Cloud Functions, but one of the most common use cases would be for validating data that gets stored in our database. Another example would be efficiency and being able to handle common and complex functions without putting too much of a load on your users having to download all of that code. And of course, security. So we'll look at all three of those different benefits. But when it comes to validation, we're making sure that certain objects inside of our database meet certain criteria, but not revealing specifically what that criteria is. Perhaps you want to make sure that the numbers fit within a certain range. Perhaps you want to make sure that strings are no longer than a certain length. Perhaps you want to make sure that the fields aren't empty, whatever it might be. You can run validation on the data that's attempting to be stored in your database. So that would be one use case for Cloud Functions. As your database grows and you get more and more data and objects stored in there, you might have hundreds of thousands of records. And if you're looking to query through all of that, that could be quite memory intensive. So if you were serving all of the data down to your client on the front end and then having them process all of that data on the front end to get the result they want, that might slow down the effectiveness of your app. So why not just push all of that code and have it all on the server side? So your client just calls one line of code in the application and the server processes all of that information over that side. It will just compress and reduce the size of your application. So if we come back to that security part, there are a few ways where we can secure our database using things like access control lists or class level permissions. But we've mentioned before that you can bypass all of that when you're using a master key. So if you had a class in your database where all of the data was completely locked down to the public, you would be able to search for that if you used a master key. But of course, what you don't want to do is you don't want to expose that master key anywhere in the front end of your application. So you would use Cloud Functions to be able to pass that master key through and complete those queries on that locked down data. So there are a few different use cases for why you would want to use Cloud Functions. You'll be using a lot of them. So let's jump into how we get started with them. So on docs.moralis.io on the left-hand side, scroll down to Cloud Code and then click on Cloud Functions. The very first tutorial that you should watch after this video will be this one here from Ivan. And the good news is, when you're defining Cloud Functions, they're all in JavaScript. It's built using the same as the Moralis JavaScript SDK. When you update your Cloud Functions and your Cloud Code, it automatically becomes available to mobile environments instantly. So you won't have to wait for a new release of the application. You'll be able to change the application behavior on the fly, and it will not slow down your development. And this text goes on to explain how you can reduce the bandwidth for a user that's using the application by processing things on the server side. Cloud Functions accept a JSON parameters dictionary, so you can pass through items into your function if you need to. I'll show you how to do that more. But in this example, we can see here that the way that a Cloud Function is written is to write in the Cloud Code moralis.cloud.define, provide it a name inside of a string, and the function then passes the request object. And in this function, it's querying the review table. It's getting items where movie is going to be equal to whatever the parameter or the movie parameter was in the request, finds the results, and then there's a loop. And it's returning a sum of all the results divided by the results length to get an average. Okay, let's scroll down. Inside of Cloud Functions, there are some packages that are automatically available for you to use. that don't require or don't need to use a require statement. And you can use the crypto package as part of the Node.js documentation. So down here, you've got access to all of these different classes that you could use, and there are hundreds that you could use in here. So rather than going through all of those, because I don't think we need to do that, if you just pick a random one here, let's, I don't know, this one here. So if we look at one that we want to use, let's perhaps say this Diffie-Hellman generate keys. I'm not familiar with this, but we could probably do a simple Google search on that. And there will probably be some documentation somewhere. Wow, there you go. Okay, first shot, that's good. And so we could probably copy all of this. So I will go into our Cloud Function code. I'll just log in, so I'll speed this bit up. And once that's logged in, I'll go to my server, into my Cloud Function code, and we'll start writing a function in here. I'll just paste what I've got on my clipboard for now. Go back to the documentation, just get a copy of this code here, paste it in there, call this one crypto function. I'll just remove everything that's in there and replace it with everything we've just copied. The majority of it we don't need, it's just comments, but we'll ignore it. I'm not going to go through this line by line because we don't need to, but essentially what it's doing, it's requiring crypto, which we don't need to do. So DH is using the create Diffie-Hellman, and it's got 512 in here. We look at the documentation. This generates private and public Diffie-Hellman key values. You just need to provide it with an encoding string. We're just using the code that came with the example, 512. And then it's going to do some work on that. But at the end of this, DH key looks to be the item that we want to get back. So it's console logging that. So we're going to just simply return DH key. And in here, we'll just put crypto dot create Diffie-Hellman, because it's initialized as standard in Cloud Code. So we can now save that and go back to our front end. We can rerun it, and there you go. We've got a string back. You may never have come across that function before, but as you can see here, there are hundreds here that you'll be able to play with. And you might well find that you'll use some of those inside of your application. But to use them in a Cloud Function is super straightforward. Just put crypto dot whatever it is. Perhaps even Google it. Somebody's probably found a way of introducing that into a function some way. Okay, let's come back to our documentation. That in our Cloud Code, there were a lot of examples of console logs. That's fine in the front end if you're building front end code, but in the back end, console log does not work. So if you need some form of debugging or informational printing of messages, you can use this solution here. If I just copy that, go back into our code, I'm going to remove this function now because we don't really need this. I'm just going to remove that, and we'll just call this hello world. We'll initialize the logger here. I'll show you how to find the logger in a moment. And this is just going to provide a string of hello world in the log. So if I just save that, copy the name of the function, go back to our front end. Now, where is the log? Well, if we go to the dashboard where our database is, on the left-hand side, you'll see logs. And you've got an info and an error section here. This shows that our code is just refreshed. So we're ready to run that now. So we can rerun a function. We'll call that hello world. We're not sending any parameters in. It says undefined because we didn't return anything from our function. But if we go to the logs in the back end, you will see it here. Just refresh by clicking info, and it says ran cloud function hello world. And as you can see, there is the hello world message. If we go to our cloud function and just make one addition, just so we can show you how parameters might work here, we've got hello world, but let's just turn that into a template literal. And in there, I want to actually give it a variable that I want to pass it. So that will be in the request.params, and we'll just call it name. Okay, so we're going to pass a name into this function, and then in the log, it's going to say hello Chris or hello whatever name. Okay, super simple. But let's run that. So we'll save that now. But in here now, I'm going to pass in the name parameter, put it in a string, and run that. Again, you don't get anything back in the console, but if we go back to the dashboard over here, refresh that, you can see here it now says ran cloud function hello world, and it shows the inputs that you gave it. And we gave it a name of Chris, and there you can see it. Hello Chris. All right, so that's a basic example of running a simple cloud function with a request parameter. and the request parameters you'll be using quite regularly, I would imagine. Okay, so that's the console log. Printing logs in real time in the console. There's a video here I recommend having a look at after this video. It shows you how to run a command where you can use the Moralis admin CLI get logs, and it will run a live real-time log printing function. We're not going to need this for the moment, but what we will need to do is configure our command line interface, because rather than writing cloud code this way, which is fine if you're happy to log into the dashboard each time and do that, but what you might want to do is set up cloud functions in your IDE. So we're going to go through this here where we actually install Moralis admin CLI and then watch a folder on our PC. So every time we write code in our function, let's say this cloud function file that I'm going to put together here, it will automatically update in the back end here. So we can manage our cloud code using our regular code editor. So let's head on over to Visual Studio Code and go and get this set up. I'll copy across this function before I do that and just paste it down here. Now I've created a folder inside of my project called Cloud, and inside there I've got a cloud functions.js file, and this is where I'll be starting to write my cloud functions, and this database.html file is the file that I was using to build all of the data in my database. In cloud functions, I've just copied this other one down here, and we've got some instructions that we'll need to follow. So we go back to the documentation. If you need any additional help getting it set up, there's another video here, but we are going to run this command in the folder that we're working on. Then we're going to run this command to actually watch my cloud folder. And then afterwards, we'll be able to start running cloud functions from inside of Visual Studio Code. So I'll copy this one first of all. I'll go over to Visual Studio Code. Now I'm going to right click on cloud and open that in the integrated terminal. And I've just realized, now I'm using a Windows PC and I can see here that it's opened up a PowerShell. Now, I've had problems with PowerShell before, so I prefer to use the command prompt to run the command I want to run here. But that doesn't open up normally in the folder that I want to be in, so I'll just cd into cloud. Here we go. Make sure that I can see the cloud functions.js. I can. I'll copy what's on my clipboard to npm install -g Moralis admin CLI. This tutorial assumes that you already have Node installed. It doesn't take long to run this, only a few seconds. But once that package is installed, you'll be able to run the other command. Let's go back. Copy that. Now, if I just paste it up here, just so you can see it, Moralis admin CLI, we're going to run watch cloud folder. You need to provide your API key here, your API secret here, and you need to change this to a specific path to that cloud folder that you want to watch. So I'll get the cloud folder code first of all. I'll copy the path, delete that, and inside of a string, I'll put the folder path that I'm looking for here. Next thing I need to do is go over to my server dashboard and go and get my API key and my API secret. You'll see the details you need in here. API key, API secret. Copy those. And once you've copied those, collect that whole piece of code onto your clipboard and then run it. It will ask you which server you want to watch. And for me, it was the very first one. And that is now done. So if we go back to the dashboard into our cloud function, you'll see that it's added all of this extra code at the top and this exports at the bottom. And you'll see that what's included in here is what I had from my Visual Studio Code. But it was before I saved it, so I just have one function here, the test function. But if we go back to Visual Studio Code, you'll see that this is unsaved because I added another function. So if I save that, you can see that changes have uploaded correctly. We'll go back, and now we will see the other code in here. Excellent. We now no longer need to use this window to write our cloud functions. We can do it directly from Visual Studio Code. How good is that? So down to calling cloud functions. Well, we've already jumped ahead a little bit there because we did do that once already. And you'll notice that in this example, they've built a parameters object, and inside of that object, they have movie as the key and the matrix as the value. And then they've passed that parameters object in as a second argument to moralis.cloud.run. And in this example, average stars was the name of the cloud function. We don't have a cloud function called average stars, so we can't really run this snippet. In general, there are two arguments that pass the cloud function, and that's going to be the request and the parameters. But you can also get access to request.user inside of Cloud Code, where you can pass back the user making that request. So what do I mean by that? Well, if we go over to our cloud function code, by habit I was about to do that, but we'll do it in Visual Studio Code, and we can actually just return an example of what I mean. So we could return request.user. So it should provide us with an object, the user object, for whoever runs the request on our front end. So I'll save that. We'll just wait a few seconds for that to upload. And if we come back to our front end, we've refreshed the application. And in here, if we just rerun that function, now we don't get undefined. We get the request.user. We get the user object. Albeit this particular function is incredibly basic and it's not actually getting any data from our database yet, but it just shows you how to construct a function and how to get information from the request. Okay, let's continue down using the master key in Cloud Code. So the master key is pretty much your most important key. Never expose this in your front end application. But there'll be times, depending on what it is that you're searching for in your database, if you're doing a query, for example, where you'll need to pass that inside of your Cloud Code. And you just simply use this object here. That'll be an example for the find method for a query. You've also got an example here for the save method on an object, or save all. And it's generally always going to be the same. Use master key true. Okay, so let's move down to implementing cloud function validation. We ran a very, very simple function in our Visual Studio Code, which just had the name of our function, what we wanted to do, but there is a third argument you can pass, and this would be a validation object. And a validator object in this example here would be this one right here. And it's using two specific options. It's using fields and require user. Require user just means that somebody needs to be authenticated. And fields, it's checking the database for movie. And really all this validation is doing is just making sure that there is a movie field. So the movie field is not empty. So inside of this request, there is a movie field. That's an example of simple validation. Let's take a look at it as an example in our own application using our database. So we go over to our dashboard browser, go to our unit table. Let's pick an example of a cloud function where we're going to sift through all of the data in our database and return every one that has movement points equal to 6. So we're going to need to define a cloud function and then return the results that equal that query. A few things to do. In our Visual Studio Code, let's write that out. I'll just close the terminal here and write a new function. I'll just remove that validator object for that previous function because we're not going to use it in there. I'll copy this function and we'll use this one. I'll call the function movement. Okay, so let's construct a query. So we'll call this query, which will be a new Moralis query. And which table do we want to search? Well, we want to search the unit table in our database. And that query, we're going to be running an equal to constraint because we want to look for, I think it was movement points, which was MP, where that's equal to 6. Let's just call that res, and we will make that equal to await query.find. Don't need to worry about the master key here. And then we could return and see what we get back from that. Chances are we're going to need to drill down into some data because this might return more data than we need, and we'll just try and carve off all of the things that we don't want. If I save that, moralis.cloud.run will run our movement with no parameters, then nothing we need to pass through. Okay, here. So we can see that we get our response. There are 12 objects that would fulfill the criteria, but you can see here we're getting all of this extra data that we just don't need. All we really want will be contained in the attributes. So we kind of want to return a different version of this array, removing all of the data that we don't want. So we could use a map. As an example, we could just create a result, let's call it. Where we're going to take the res, we'll map it, and for each unit, we'll provide back the unit dot attributes. And assuming that I haven't done any typing mistakes, we can now just return the result. Let's see if we get any errors. We'll save that. Again, if you try and run the query too quickly, you'll get this kind of error here. But if you give it some time to run, and make sure you run the right function, because I've just realized I ran hello world there and I didn't mean to. But after all of these errors, it actually did run my function. So after running it again, this is return 12, and inside that, this is a new array, and now you can see all of the attributes. You don't have any of that extra data that you didn't need. And these are the results, and all of them, movement points, will be 6. Superb. Okay, but maybe what we want to do is have this a bit more dynamic. So rather than hard coding in to our query that we're going to be wanting to find movement points of 6, maybe we want our parameters to decide what we want our movement points to be equal to. So in our request params, we could send through a number which it will check. For now, let's just change this 6 to request.params, and we'll just call it points. We can call it anything we like, but let's just call it points for now. Save that. We'll go back to our front end, and inside here now, we can send it some parameters, and it was points that we were going to send. So maybe we'll try and send 5, just so it's a different result to before. So we could rerun that. We get 12 back again, and this time these are for 5. Let's try and run another one with maybe 4 instead. 15 in this one. Maybe run another one with 3, and there are none. Another one with 7, let's say. And again, there are none. Okay, so just a bit of simple maths here then. So we can see that 5 points, there are 12 records. 4 points, there are 15 records. And for 6 points, there are 12 records. So if we add all of those together, that is 39 results. But in our database, there are 60. So we are missing 21. Why do you think that is? If you want to pause the video and try and figure that out. If you haven't already figured it out, then the reason is because when we run cloud functions, are going to be coming across as public. If any of the objects in this class have an access control list, then the cloud function is going to fail it, because the cloud function is not a user, and the cloud function is also not a role. So it will fail the access control list. And there are 21 records here that have some form of access control list. So we saw 39 because it was publicly available, but we didn't get the other 21 because they had an access control list. Make sense? So how do you bypass an access control list? We've said it before. You use the master key. So if we go back up the documentation, and we'll just go and collect this master key object here. This is the example of how you would use it inside of the find method for your query. We'll go back in here and we'll just put the master key in there. That's going to bypass the access control list. So now we should get a lot more results from our cloud function when we save it. Okay, so if we research 6, there are 19 results. Let's go with, should be none for 7. Should be none for 3. Should just manually change the numbers. I'm just going back through the old one. So 20, 21, 19, well, that equals 60. And there you have it. So we're allowed to run a search for 3 and 7, even though it's not going to return any results. So we're effectively wasting a call to our cloud function by trying to run something with it returning nothing. So what we should be doing is adding some validation on this function. So if the request comes in for an invalid input, like a 3 or a 7, then it should throw it out and not allow that query to run. And that's what you would use the validation object for inside of that third argument for the cloud function here. So let's run some validation here back in our documentation. So this was the simple example that you could use, but we need something a bit more than that, because just having a field is not enough, because we need to make sure that our number is either a 4, a 5, or a 6. So in the documentation, there's a more advanced validation example here, where actually they've nested more information inside this field, and that's what we want to do. So we'll copy the entire object, and then we'll edit it, paste it in here. So we're actually using two options. We've got fields and require user keys. Well, we're not going to use the require user keys. We will use the fields, and our field is going to be called HP. Is it required? Yes. What type is it? Well, it's a number. You don't need to put this, but if you want to, you can. And in here, in our options, we can actually provide some logic. So the value that we get back, we want to return a Boolean. Is it true or false? Is, and then we can do some logical expression here, and we'll maybe use an AND operator. The value is greater than or equal to 4, and value is less than or equal to 6. The error here, we could just simply say, must be between 4 and 6. So let's see what that does. Okay, we've got an error. Validation failed. Please specify data for HP. I needed to put MP because it's movement points, not hit points that we're looking at. That's my mistake. And the error is actually, again, mine because it's to do with the request and it's points that we're sending through here. So perhaps we should even just change our code. We'll just change this through to MP. And then in our front end, we'll call MP instead of points. And then everything will connect up nicely. So in here, we'll just change points to MP because that's the name of our field. And here we go. The error now is saying must be between 4 and 6. Let's try it with 3. Should also error. It does. But if we try and send it with 5, then we get our response. So that's one example of how you could use. You can add together and chain together different ones if you wanted to. So if we wanted to do a query with XP instead, maybe our query is going to have something where XP, we're going to do a less than XP. So we're going to put in, maybe we're going to search for where the XP is less than 40. So maybe our movement points need to be 5 and our XP needs to be less than 40. Whatever you want to choose. And we can do our validation in here as well. It's also a number, and it needs to be between, let's have a look at an example in our XP field. Our lowest is 30, our highest is 60, so we'll say it's between 30 and 60. There we go, 30 and 60, and we'll just say it must be between 30 and 60. So now we could pass in a couple of different parameters. We could pass in an MP or an XP parameter. In actual fact, we must because they're going to be required here. So if you don't pass them through, it will fail. We'll save that, go back to our front end, and this time we'll run a search for just MP, knowing full well this will fail because it wants us to specify data for XP. And so let's say this particular one, we want to look for anything where it's, I think it was a less than was the query, less than 45. So there are 8 examples in this case where XP for the particular user needs to be less than 45. Can't see the XP in these ones. Maybe just for the sake of an example, because we can see it quickly, I'll just change XP to HP, which will be the hit points. 65 is the highest, 20 is the lowest. Okay, so it's between 65 and 20. Just go back here. We'll change this to HP. HP. 20 and 65, I think we said. All right, okay. That's just to make it easier as an example. That's the front end, and we'll just change this to that. Okay, so in this example then, this is all of the results where movement points were 5 and hit points were less than at 45. And you can see the results here. You can see them quite clearly. If we try and do a search where the hit points are too high, we'll get an error. Or if we search for where the hit points are too low, we're going to get an error within the validation fields, and you'll get results. Now I've just changed movement points to 4, hit points less than 35, and these are the ones that you would want. Okay, now your data is going to be different to my data, so I appreciate that you might not have all of this in yours. It just goes to show how you can search your data for any type of field that you want and use cloud functions to return the data to you. So far we have constructed cloud functions, we've understood the request, the parameters, and the request.user. We've also understood the validation object, how you can use constraints for how you can use queries inside of a cloud function, how you can pass the master key through, and what happens if you don't. There's lots of different things that we've covered there, and we've really only scratched the surface on what you're able to do with cloud functions. You as a developer will find all different kinds of use cases, and in the forum there are lots of examples of how you can use them in different ways as well. We've even got our own examples, our demo applications in our GitHub repositories and YouTube videos that would have used Cloud Functions in some way that now should make more sense to you after having seen these basics. So that would be our validation covered off. And in this example, before data is being saved to this Moralis user, it's checking that it has an account type set. And the default would be viewer. Maybe they have certain permissions over somebody else. Maybe they have a role, for example. And constant, which is whether the field is immutable or not, is true. And you can see that the full range of options for the fields are explained down here. Okay, so that's just an example using a trigger here, which we've not yet come on to. All right, excellent. Let's see what this one is. So you can also pass a function to the validator. So down here, we've got two examples of where they've defined a cloud function called admin function. They would do some code in here, and then the validator, it's not an object, it's a function. And the function is up here. Just be aware that the validator runs first before your cloud code. So if you run through a really complicated, expensive function, then it's going to just delay the time it takes before the cloud call will be able to run. Okay, and so we have called our cloud function using our front end code. But you can also call cloud functions with a simple GET request. The URL would look something like this. You need to pass in your full Moralis server, followed by /functions/the cloud function name, and then pass your application ID and any additional parameters that you want to. So in this example, it's going to be running a function called hello, passes through an application ID, and it's going to pass through a name parameter of cryptochad, which is a string. Whenever you're using this particular option, you have to be aware that the parameters are always going to be strings. So inside of your cloud code, you're going to need to handle that and perhaps transfer them back to different type of data, for example, a number. Let me show you what I mean real quick. I'm going to come to this example here because it's simple, hello world, and I'm going to pass in two parameters here. And in here, I'm just changing this template literal here to hello name. Your favorite number is number. Save that. We'll go back to the front end and then we'll run that function. We need to pass, I think we called it num. We'll just put in a random number. We'll go over to our dashboard and see what it comes back with. Hello, Chris, your favorite number is 54. Okay, great. So you'll see here that the input for that cloud function call is correct. The name was Chris, which is a string. The num was 54, which was a number. So let's go ahead and convert that to a call that uses an API. Back to our front end. In here now, rather than await moralis.cloud.run, we're going to need to convert this into a query string and fetch it. We've got to build that query string. We're going to need the application ID and some other numbers. And I've just prepared the fetch here. So this is a URL string that uses my server. It looks inside the functions for hello world. I've got an application ID, and then I am passing the parameters of Chris and the num 23. If I press return on there, I've just realized that console login doesn't do anything because it's all going to go into the server logs. So if we go to the info here, refresh, I ran an example of that before, and there it is. Hello, Chris, your favorite number is 23. And you'll see that before, when we originally did this in our code, down here, the input, let's see where I can find it, here. The input originally was name, Chris was a string, number was 54. But in this example, Chris is a string and num is also a string. Now the result is the same. You could get some unusual results if, for example, your filter is looking for a number and it's being fed a string. So if you were looking to run a different function, let's say I was trying to run this movement function and I was trying to pass 23 into this function here, this HP or this MP. Well, maybe not MP because it needs to be between 4 and 6, but HP, if I was trying to pass 54, let's say, as a string into this, then it's not going to provide any results because it's going to be searching a field that has numbers in it for the string of 54. So inside of your cloud code, you'll need to do some conditional logic to search the request.params.hp and convert that to a number. Not sure what I mean? If not, let's just quickly run this. So the function was called movement. We can change this to movement. And I may get an error with this one, but I think we can just remove all of these handle parts. And I think I need to pass in, was it movement points? 5. And what was the other one? Hit points, I think it was. And we'll just say something like 54. Okay, we get an error. So let's see what the error is. Invalid type for MP. Okay, let's go back to our code. Well, of course. This is the perfect example. So our MP and our HP fields, they are required, and they're required to be under the type of number. But of course they're not, they're strings. So we could turn this to string, or just remove it, in fact. We could rerun that query. And then when we rerun that query, it does run. We'll go back to the dashboard, see what it says. We can see that we've got movement points, string of 5, hit points, string of 54. What does it return? Nothing. What should it return? Well, we could change this to 5 and 54. It should return 13 results, but it's not returning anything because it's looking for these as strings. And of course, there aren't any. It's numbers in there. So inside of the cloud code, you'll have to convert these strings to numbers. I'll give you an example. So maybe the new HP will equal the request.params.hp. And the MP will equal the request.params.mp. And you could convert those to numbers. So you could just simply do this. Or you could have some sort of conditional logic that says, if it's a string, if type of is string, however you want to handle that. And then you'll just pass in these instead. So we'll see if that works. Okay, it works on the front end. Let's see if it works with the API. We'll go and check the logs. And there you go. We got all the results back. And now we can actually change the way we handle this by just adding in all of these once more. And there you have it. There was 13 in this version, and now there's 13 in that version. So we had to do a little bit of work to just convert it, but I personally ran up against that issue myself. Great. So that's how you're going to call your cloud functions using the REST API. Okay, Web3. Now, Web3 functions are available within the cloud code automatically. You'll just need to initialize a new Web3 by chain instance. So depending on whichever chain you're going to be using, perhaps it's Ethereum, inside of your cloud code, and that's the key part here. Don't try and run this from the front end. It won't work. You can initialize Web3 by running this. It won't do that much on its own because the reason you're going to be initializing Web3 is to utilize some of the functionality. For example, constructing a contract instance like this, as Moralis does bundle the Open Zeppelin API for ERC20, 721, and 1155 contracts. And so you could bring that all together by using an example like this. Now, if you need a specific course around smart contract programming, there are YouTube videos available on our Moralis YouTube channel. There is also a smart contract course, I believe, in the Moralis Academy. But if you need more information, then post it in the DAO, request it in our community, and we'll do what we can. And that brings this first section to an end. We've gone through a lot of information there. I hope a lot of things were starting to pull together, and there were a couple of aha moments. Play around with the cloud functions, explore the validation object, and once you've had a look through all of those videos up the top, then come and join me in the next section, which will be HTTP request. With Moralis Server, you are able to send HTTP requests from cloud functions. Why would you need to do that? Well, within your application, you might need to call external APIs. And the way that you would do that is to wrap the HTTP request to that external API inside of a cloud function. And using Moralis Cloud Functions, you'd be able to send GET requests and POST requests. You'd be able to use port numbers. You would be able to pass headers if you needed to, query parameters, and even follow redirects if required. There's some information about the response object down here, but I want to show you a couple of examples of how we can use an external API, wrap the call inside of a cloud function, and use it within our applications. Okay, so let's get started. We need to define a Moralis Cloud Function wrapper, if you like. So let's just write this out as moralis.cloud.define. We'll give it a name. We'll just call this request1. And the syntax is the same as it always is. So you could just copy a previous function that you have. And then inside here, we're going to need to return something. Now we'll go back to the documentation and go and get the code we're going to use. So let's go and take this one here. and we will actually return that particular cloud function. There's a few things we're going to need to do to change here. First of all, this URL needs to change to a CoinGecko API. We need to change that. And that will return a promise, which we will then be able to do something with. And this is the bit that we need to edit, because we're not going to be console logging anything, but we do want to be working on this HTTP response.txt. And we're going to need to pass that and save that into some sort of variable. So we'll call this results, json.pass. Now we haven't declared results, so we may as well just do that up here. So we'll just let results equal an empty string for now, and then we'll fill that afterwards down here. Make sure we call it results. And I may also as well just let the URL equal the CoinGecko URL that we're going to be using, and we'll just pass that in here as a URL instead. We'll tidy up some of these comments. One was for success, one was for error. And then once we've got the results, we can return that. That should give us back what we need. If there's a problem, then we will get a response. We've got an empty variable called results, which we will fill. We've got the CoinGecko URL, which we need to go and get. That'll pass into our HTTP request, we'll pass the result, and then return it back to us. Excellent. That should work fine. Let's go and get the URL that we need then from CoinGecko. So if we go to Google and search for CoinGecko API, this one will work. And when we load that up, we want to go and use the markets, the coins markets endpoint. I'll go and try that out. We'll change the currency type to USD, maybe change the results to 50. And then we'll execute that to get the request URL. Copy that back to our code. Paste that in here. And then let's try this function out. It's called request1. If we go back to our front end, and then we can run this. So we'll await moralis.cloud.run. The name of the function was request1. There are no query parameters, and then we'll do a search for that, and it should return 50 results with all of the information that we want. Great. But what if we wanted to change that query? What if we wanted to get maybe 10 or 100 different results back? It would be good if we could pass through some parameters inside there to affect the results. So we could type in something like number 10. Now at the moment that won't do anything because the parameter is just going to be ignored. But if we come back to our cloud code and write a new function, copy this one, and we'll call this request2. What we can do instead is pass through a variable. So in here, in this request URL, we could look at this number here and have that as a variable. What we'd need to do is convert the string into a template literal, so we can pass in JavaScript as well. And this 50, we'll make a variable by using the variable syntax, and we want to give it a number, and we'll let the number equal the request.params.num that we'll be passing it. Make sense? If we save that and then go and run request number 2, got rid of my previous one, so we'll change this and let's see if this works. There we go. Maybe we can change that to 100 and it will do the same thing. Okay, excellent. But what about if we want to change the result that we're getting back? What about if we don't want all of this information? We don't want symbol and name and image and all this stuff. We just want it to say something like Bitcoin and price. That's it. So we want to try and return some kind of custom object. For example, something that looks exactly like this. So if you pause the video here, see if you can create a solution that instead of providing all of the previous data that you had, i.e. this, we want to try and convert the response so it gives us that. Pause the video, see if you can complete that, and I'll see you in a second with the solution. Okay, back in the code. Hopefully you managed to do that easily enough. If we just copy request 2, we'll call this request 3, and we're going to make some changes to do this. All of this information will be exactly the same. All of this information will be exactly the same, except for when we get into our function here. Now, we've got the results here, but I want to actually now do something different. So how do you take an array, change it, and then respond with a new array? Well, you use a map. If I create a new variable, let's just call this res, and we'll do a results.map. And for each result, we're going to do something. We'll create a new object, and it's just going to have a key value. Oh, I've just missed out. And so what do we need? We're going to need the, let's have a look. So what are we going to need? We're going to need the ID, and we're going to need the current underscore price. ID and current underscore price. That will be result.id and result.current underscore price. So I'll do that first of all here, result.id, and we'll make that equal to result.current underscore price. Oh, underscore price. And once I've created that object, we can return it back inside of the new map. Got an error here. Missed something out there. And we're not using res because we're going to be returning results still, so we can just simply do that. Any errors? Doesn't look like it. Let's save that and we'll test out request 3 in the front end. And then we'll open up that object, and there you go. Excellent. So there's a few examples of how you could use a cloud function to call an external API with the HTTP request that's available for you in the Moralis server. And as I said at the beginning of the video, if you needed to specify a port number, you can do that inside of the request URL. The valid port numbers are listed down here. If you need to follow the redirects, then you can use the follow redirects option and change that to true. For query parameters, you could do it a few ways. You could use a template literal like I did previously in our API example, or you could pass it through as a parameters object inside of the HTTP request. If the URL requires it, Moralis will then append your query to the end of your query string, or you can pass through a raw string that would look something like that. Setting headers is simple. You can follow this example down here. And a post request example is down here as well. Another super powerful tool that you can use as part of your application using the Moralis server. Continuing down through our cloud code section here, we now come to triggers. Now, triggers are pieces of code that are run on our server every time a condition is met in the database. More often than not, triggers will have to be run in cloud code, otherwise they won't work. They will run whenever something happens in our data. Now, there's some examples here that make reference to the standard tables that we get in our database. The examples that I'm going to use will actually be using the data that we've already got. A trigger can generally be identified with a before or an after. That'll be before something happens or after something happens. Down the right-hand side, you can see some examples. We have save triggers, delete triggers, file triggers, find triggers, session triggers, and live query triggers. And the majority of them, if not all of them, have before and after variations of that. Some of the examples in this documentation will be relevant to your database and some of them won't. But we'll work through these and I'll show you some resources for where you can get additional information if you want to use them in your application. Before we get started with triggers, the one thing that you just need to be aware of once you've understood a bit more about how they work is that there are potentially some consequences for using them. For example, whenever you are editing the database or whenever you are adding a record to the database, sometimes it may go into a pending class first and then change to the master class afterwards. So there could potentially be two events there that would fire your trigger. And this is explained a bit more under the consequences for triggers down here. Have a look through that. Another common question I had at the beginning was to understand, well, what's included inside of the request object and what data can we get out of this whenever we're passing through a trigger? Because here's an example of an aftersave trigger, which is moralis.cloud.aftersave. You name the class that you want to be looking at, and then you're going to run a function, which will take a parameter here, which is going to be the request. So what data is included in that request and what can we use? That might be a question. We'll cover that as well. Another question that I find is, well, if the trigger fails, does it actually stop any data from being saved in the database? So these are the kinds of questions that I want to cover in this particular video. And I'll start with the easy one. Does it prevent the items from being saved, or does it prevent the operation that you're trying to do before the trigger? Typically, as a rule of thumb, the before triggers would prevent the operation from running, but the after triggers would not. I'm remembering that the Moralis server is a fork of the Pars server. You could also find more information on the parsplatform.org website. There's a note here about local dev chains. If you are using Ganache or Hardhat for your application at this stage, then just remember that the way that the blocks are mined might affect your transactions. So your trigger behavior might not work exactly how you intended on a local dev chain. There is a tutorial video here for some basic triggers from Nicholas. It doesn't cover everything down the right-hand side, but it will give you an introduction if you are completely new. And then we can start looking at the triggers. So we'll begin with save triggers first. We have two that we're going to look at. The first one is before save. The second one is after save. And then we'll briefly touch on context dictionaries, which you can pass in. It's a more advanced technique to add additional functionality to your triggers. So what is a before save trigger? Well, it will allow you to run a function on data that's in your database perhaps before the intended save happens. Now, a save might be when you're adding an item to the database or just when you're trying to edit the data inside of your database. So as the name implies, before saves are calls that run before saving a new object to the database. So this example here, we've already seen something similar to before, because this is to do with implementing data validation, which we've done in a previous section in Cloud Functions. And specifically, there is a before save trigger. There's nothing in the first function body, but they have passed across a validation object. And that validation object is checking the fields that are being passed through to make sure that stars is included because it's required, and that the stars are somewhere between 1 and 5. And if they're not, then they would throw an error that would simply say that that's required. So this isn't new. We've seen something like this before. And like it says here, the reason for having the validation is because you don't want the user to have the ability to give -6 stars or 1,000 stars in a review. So you want to reject and throw that out before it's saved into the database. There's another example here, which is a comment example. And so it's checking the length of the comment. And if the comment is too long, then they're effectively truncating it and modifying the information once it's being saved. So you'll notice again, moralis.cloud.beforesave, and the first argument here is either going to be a string, which would be the name of the class that you want to hook into, or it can be a predefined class, such as moralis.user, like this one here. And the function itself that you pass through takes just one parameter, which is the trigger request. And inside of that trigger request, you could have various properties that you could hook into. Now, in previous videos, we've looked at the request.user, we've looked at potentially the request.master and some other things. But in this example, you could also hook into these request.installation ID, type string, and that would be the installation ID if set triggering the request. The master is just to see whether or not the master key was used. The request.user would be the Moralis user that made the request. Request.user is a pointer to the Moralis user, and that is the user that made the request. Request.object would be the object that triggered the hook. Request.IP is the IP address of the client making the request, and you could also get access to the request headers, the request trigger name, and that might be useful if you want to keep a log of the different triggers that were used. And you've also got request.log and request.original. So let's take a look at a before save trigger in action. Over in my Visual Studio Code, I copied the previous example from the documentation and made some edits, because what I want to do is I want to use my database to weed out any creation of a unit where the upkeep would be more than 2. And this is a really basic example, but it's just to show you the kind of output you'll get. So in the code, I've just hooked into my unit table. I'm looking in fields. I've got this validation object that I'm using. I'm looking at the upkeep field. It has to be required. So now the option will return whether it's true that the upkeep is less than 2. If it is, everything's fine. If it's not, because the object wants to save something at either 2 or 3, then I'll return a message. I'll just edit this to, you must set upkeep under 2. So we'll save that. We'll go back to the front end. We'll try and create a new unit and see what happens. And I'll press it a couple of times until I get an error. So that's the, oh, I got an error straight away. Okay, I'll press it another couple of times. There you go, got another error, another error. So I pressed it a few times that didn't get an error, but there were 4 times where I did. So now we've got a number of new units. Upkeep is all below 2 because the before save trigger is throwing out anything that would be over that. Okay, so that's before save. We come down now, we also have after save. Now the after save trigger will not stop data from being saved into your database, as it explains here under the async behavior section. And one example that you could use after save for would be adding information maybe to another class in your database somewhere. So in our example, if we've created this unit class, perhaps we want to log some additional information somewhere else. So I showed you just a moment ago this here where we've got all the different properties from the request object. So let's just say, for example, and again, this is another very basic example, but we want to create a request log like actually this I've pre-done. Hooked onto the after save trigger, and I'm just going to be adding information into the database, which will log some of that information that's available to us. Now you might have a class here that maybe has like an address of the unit, maybe your address details for this particular unit, maybe you want to find out where they live, maybe you're going to add some information to a meta class, a class that stores things like the weapon that this unit has, or the color of their outfit, or some of the information that makes that particular unit unique. And you don't want that information to be available, and so you have it in a separate class. Maybe you'll do that. Whatever it might be, once you've created a unit, it's then going to be saving additional information somewhere else. So let's see how we would do that. So this request log class can be written just like this. The moralis.cloud.aftersave will hook into the unit. The aftersave works much the same way. In terms of the parameters for this, you would either pass through a string for the class that you want to hook into, whatever class you want to use. And then the second parameter would be a function. That'll be the function that you want to run after a save. And the function should just take one parameter, which would be the moralis.cloud.triggerRequest. And again, this is only available in Cloud code. So what is this doing? Well, the first thing it's doing is it is creating a moralis.object.extend for request log. That's the name of the class that we're going to be creating or adding to in our database. And then we're going to do a new request log, and we're going to set some properties to that request log. We're going to set user object, IP, headers, trigger name, original master, and installation ID. And all of those will come from the request object. And then at the end of that, we'll just return request log.save. And then that will save all of these properties after we've saved our initial unit. So that's how that was written. Now this one I'm just going to set to less than or equal to 3. It will never fail because we've also got other validation somewhere else. So I'll just leave that there, and I'm just going to create a few new items just to demonstrate this after save trigger. So we had 11 requests in the database. Let's go to the front end. We'll just 1, 2, 3, 4, 5, 6, 7. Refresh the database. And now we've got all of these extra ones here. Now you'll notice here that in the database, I've got an original field that says undefined for the majority, but it says, or there is a pointer for the other ones. And the reason that that has happened is because we created a new item. It didn't have anything originally. But if I went into a unit, for example, and just change, let's say this upkeep from 3 to 2 and go into the request log, now we've got a brand new object here, and it does have this original pointer because there was data there before. The pointer doesn't show you what the data was, it just shows you which particular unit was edited. So inside here, you've got the headers if you need them. You'd have the IP address of the user, which is me. You've got here, it shows you whether a master key was used. And as you can see, false for the majority of them because they were created from the front end where we didn't need a master key, but we actually edited them just a second ago using this dashboard browser, and that did use the master key. So that's how it will show you there. It shows the installation ID, and then we've got the object for the actual unit that was edited here. And we've got the user that created the request from the front end. It says undefined on these because these were produced in the back end in this browser. Okay, now your table that you will create here would probably look very different to that. I just wanted to demonstrate the data that appears inside of that request object when you're using your triggers. So let's take a look at how to use the before delete trigger. I'm going to copy this code into my Visual Studio Code. I'll put it down the bottom here. So let's just analyze this function very quickly. So this is going to register a before delete function. And like before, the first argument could either be a string or it could be a Moralis object. In our case, we want to hook into the class in a database called unit, because that's where I'm going to be trying to delete some objects. The first part would be defining a query. So it wants to run a new Moralis query into a class called photo. We don't have that in our database. And then it wants to find where the album equals to the request object. Then it's going to provide a count. It passes the master key. And then if the count is greater than 0, which means that there are some photos in this album, then it will throw an error, and this before delete function will stop the delete from happening in the database. Okay, so that we want this to be used in our function, but this doesn't really make any sense. I'm just going to put some simple logic in here and say if 2 is greater than 3, which it isn't, then throw this out, which means that this expression will resolve to false, and therefore this throw command will not run, which means I can delete as many things as I like. So let's just test that. It should allow me to delete however I want to delete. So I'll go to the dashboard, go into the browser, go to the unit table, and I'll select a unit here. It doesn't matter which one it is. Delete the row, click yes, and it's refreshed. I had 72, now I have 71. I can go to the front end of the application, and I've got a command here called destroy object. Just go and get all of my units, copy the object ID, paste that in there, run that, and again it deletes the object from the front end as well. But if we just swap this through, so now let's say our logic, which would be in here, could be a query in our database table. Eventually we will have some logic that will resolve to either true or false. Now if the logic is true, then we're going to throw we can't delete, and then you put whatever the reason is. Okay, let's go to the front end, try and delete something. And we'll go and get the units, and let's select this one here, run the old function, paste in the object ID, and now we get an error. Can't delete this unit because, which was the error that we had before. So we'll check it from the back end as well. Let's just select this one here, edit, delete this row, and down the right hand side, error deleting the unit. If we go to the logs, then we will see the same thing. Before delete failed, and the reason was down here. Excellent. So I've just given you an example with logic that's just true or false using a mathematical expression, but you would be using your own query logic using a Moralis query or perhaps something else as part of your database that we've covered already. So that's before delete. Let's take a look at after delete. Similar to we've mentioned before delete will restrict the deleting of an object from your database, but the after delete function will not. This will happen after that object has deleted. So let's have a look at an example of the after delete trigger. I'll copy this code and paste it into Visual Studio Code and just tidy things up. So this is running a query. Then it's finding all of the items that were in that query. It returns a promise, and then Moralis.object.destroy all, it will delete everything that comes back from this query. We're going to ignore that, and we're going to run something else. So we're going to have some sort of logic, and then we're going to handle. And what are we going to do? We're going to be looking at the after delete in the unit table, not the post table. And so first of all, we should check whether our before delete is going to block anything. So if 3 is greater than 2, which means that's true, which means this runs. So it's going to block everything. So we need to do the inverse of that. So let's just turn that off. We'll also go back to our previous after, and we'll just copy this because we want to do the same thing in here. So this is what we'll do if we get something that's true. So let's write some logic, and a normal logic would involve some kind of query or something inside of your database. But for me, I'm just going to do something really super simple. Just define a couple of variables, then define a logic expression. That will evaluate to true. So if it's true, then we can run this code. Put that inside the curly braces. We'll save that, go back to the front end. So if I just go and get the units, copy this one, for example, Run the destroy object, paste that in, see what we get back. Well, it looks like it deleted it. So now if we go back to the database, if we go to our request log, and there we go. So now we have a new after delete trigger in here. So let's see what happens if we try and delete a couple of units from the back end. Let's delete these first two. It deletes both of those. And we go into our request log and you'll see that they both appear here. So this is just an example where I've taken information from our request object, but of course you might want to do something else with your data and save a different type of data in a different class somewhere else. But I've just shown you the process of how you might go about doing that. Great, so that's the delete triggers. Super simple so far. File triggers. Well, throughout this tutorial course, I haven't actually updated or uploaded any files, but there are tutorials for how to do that in our Moralis YouTube channel. I recommend checking that out to supplement this documentation as well. But the first one here, this registers a before save file function. So in this example, there are three examples here. The first one is how to change a file name. The second one is returning an already saved file. And the third one is saving a different file from the URI. And you'll notice that in each of these examples, they have registered a before save file function. The function takes two parameters. The first one is normally going to be a subclass within the database that you'll want to hook into, although neither of these examples seem to have done that. And the second argument would be a function, which is what both of them have used. Now, the function itself passes a request as a parameter, and the request is actually destructured a couple of times in here. For example, here, they've destructured this request object to get the file properties, and in this example, they've destructured it to get the user properties. So this would actually be the moralis.file object, and this would be the moralis.user object from this request. I'll show you some of the other properties that would be available using the file trigger here. Installation ID, master, user and file were the two that we were looking at, and that's the type that we were just discussing there. So if the user is set, it's the user that made the request, and if the file is set, it's the file that was triggering the hook. And you've got access to the IP, the headers, the trigger name, and the log as well. And so in this example with the destructured file property here, they're saving the data from the file.getData method. And then they're creating a new Moralis file with a different file name and returning that new file before the file is saved in the database. So the user uploads a file, it's going to run through this function and rename it. This particular example, returning an already saved file. So in this particular example, perhaps the user has uploaded a file and the application is just going to respond by saving the original one because it already exists. So there's some examples of the before save file. You can add metadata or tags to your files as well using this particular trigger. There's an example of how to do that here. And in this example, they have destructured both the file and the user properties of the request. They've used file.addMetadata, which hooks into the user ID now, the new destructured user ID, and file.addTag. So two methods used there. And again, using the before save trigger. Okay, after save file, here's an example here of registering an after save file function. It's available only in Cloud Code, as the same with all of the other ones that we've done so far. And if we break down the example in here, the after save is just passing through a function. It's got the typical request object. And this time the file size and user properties have been destructured from the request object. They've run a new Moralis object called file object. That's basically equivalent to extending a new class name called file object and then creating a new instance. And with this new instance, this new instantiated object, they're setting some attributes. They're setting the file size, and they're created by using the properties that were destructured from the request object, adding a session token, and then saving the file object. So after saving a file, it then creates its own custom object and saves that into a database under the file object table. So whenever a file is uploaded, it's basically adding data somewhere else as well. And you can do that in your application using something similar to this. This before delete file function could prevent a file from being saved into your database. However, the after save file would not prevent it. We looked at save file just a second ago. Now we can look at delete file. It's the same idea as some of the previous ones we've already looked at. So in these examples here, the first one actually is an after save file trigger, which is similar to the previous one that we had here, maybe with just less properties that were set. The after save file has a function, And the request object has been destructured. We've got the file and the user properties in here. The example has created a new Moralis object called file object, and it's set a couple of properties and then saved it. The before delete file, it destructures the request object. We have the file and the user properties, or the Moralis file and the Moralis user object. This time it does a query into the file object table that was created. It looks for where the file name is equal to the file name. So the file name in the database is equal to the file that's been uploaded, or trying to be deleted, should I say. It returns the very first one from that list. There's some conditional logic to see whether the ID on the file matches the ID trying to destroy it. And if that fails, then the delete will also fail, and there'll be an error that says you do not have permission to delete this file. Okay, so that gives you an example of how you would use before delete file. After delete file, let's take a look at this one. Moralis.cloud after delete file. Again, it runs a function, takes the request parameter. It's been destructured, so we now have the Moralis.file object here. There's a query inside the file object class, and it wants to find where the file name in the database equals the file's name that's being deleted, or that was deleted. It returns the first result and then destroys it. So in this example here, this is assuming that you have additional file objects that you created when you saved a new file. So when a file was saved, they created extra data that was added to the database. Moralis server won't realize that that extra data exists, so you would have to go in and do that using this process. So in this example, once a file is deleted, it just cleans up the extra file objects. Okay, the triggers are not too difficult to get your head around once you've used a few before. They all follow the same principle as each other. Depending on the operation that you're looking to complete, it will then hook into that and do something either before or after it happens. Now, find triggers, again, we don't need to really go into much detail on demonstrating this because I think it will make sense. I've covered already about the properties before. Well, this example actually displays them all for you. So if you hook into the moralis.cloud.beforeFind, you can pass through as argument one either a string for the class that you want to search in, or you can pass in the predefined classes such as the Moralis user. The second argument will be a function. You can pass through the request parameter. And this example here, we've just created variables for all of the different properties that you can hook into if you want to. And there's quite a few examples that you can run through here. You might want to also make reference to the parse documentation so you can find out some extra functions that might complement this, but you can select keys as an example. There's asynchronous support. So if you get some kind of promise, for example, maybe you're using like the each method in the parse documentation or some other function that returns a promise, then this example could be useful. You could return a different query. This utilizes the or method, returns either this query or that query, depending on whatever comes back. You can reject queries by throwing a new Moralis error or rejecting a promise. And there's also some read preferences that you could set here as well. So that would be for before find and after find. And after find would be in case you want to change somehow the results of the query before they're sent back to the client. We've got a couple of useful session triggers that you can use as well. You've got before login and after logout. So maybe in your code or maybe in your tables, once you've added information to a particular user, maybe that you've got an is banned flagged. And so you just want to make sure before they're logged in, you're checking to see whether the user is banned. And if so, you throw an error denying them access and reminding them that they have been banned. That's just one example. You might have various other fields in your tables for which you could check before the user logs in. Just be aware of a couple of things. First of all, the before login trigger waits for any promises to resolve. And until the before login trigger completes, the user is not available on the request object. The trigger will run on username and password logins and also any MetaMask or Wallet Connect logins, but it does not run on a sign up or if the login credentials are wrong. After logout is typically a cleanup operation. You get access to the session object that was deleted on logout. And if you need to, you can then use that to perform some user tasks. And in this example, we pass a request object into our function and the session object is destructured here. The example gets the user and sets their isOnline to false and then saves it with a master key. So that's an example of user status. There's lots of other ways you might want to incorporate that. So whilst you get access to the session object, it has already been deleted. You can just use the information to find something else if needed. If there is no session object for whatever reason, then the trigger will not run. Okay, and we'll finish up with the live query triggers. So we've looked through live queries already. We did that in the database section. We've got a number of different live query triggers that we can use: before connect, before subscribe, after live query event. You've also got on live query events. So the before connect trigger, maybe you just want to restrict access to only users that are logged in. So you could use the request object, look for a request user, and if you don't have one, then you could throw that connection out. So that's the actual connection to the live query server before any live queries are even subscribed to, which would be the next one. That's the before subscribing to a live query. And in this example of this before subscribe trigger, there are two things that it's doing. First of all, it's checking whether the user is admin or not. And if not, then it throws them an error saying that they're not authorized. And then the next thing it's doing is restricting the results to a subset of just two keys, name and year from the query. Because in this case, they wanted to transform the subscription query. You may not need to do that. You may not want to do that. With after live query event, we saw something similar to this with the after find trigger, and that's that in some cases you might want to actually change the results of a live query before they're sent to the client. There are two examples here. So in this example, when it creates the after live query event, it's doing two things. It is getting access to the request.object and also the request.original. You'll notice before when I sent you this, when I showed you this, you had the request object and the request original. So this is essentially then forking off. So you're having the request object showing this is the name, and you're having the request original showing this is the name. And I'll leave you to take a look through the other examples for the last parts of these triggers here, as I believe we've covered the most common ones already. That brings us to the end of the trigger section. So now we'll jump over onto jobs. In the jobs section of the cloud code, you will find out how you can both define and schedule a job, which will enable you to run cloud code functions either at a set time or a specific time, or have it as a repetitive running, which could be a super useful feature for you, certainly when you're using smart contracts. But for now, we're just going to be taking a look at a basic example where we're going to rerun a cloud function using a job. Define moralis.cloud.job, you give the job a name, and then you pass through a function. There are some properties that will be available inside of the request, such as params, headers, log, or message, and you can destructure those if you wish to and use the details inside of your function. I'm actually going to do something different. I'm just going to return the running of a cloud function instead. So what cloud function am I going to run? Well, if we look back on the database here, I had a function here that was called run create unit, and the create unit code looked something like this. We created a class, we added some methods into the class, and we had this create class method that enabled us to create a new unit where these details were all randomized. So I'm going to convert this into a cloud function. So I've copied the code and pasted it inside of a new cloud function called moralis.cloud.define. I'll just call it create unit, and everything else is the same as before. However, let's just close this terminal here. I had to make some changes, but because now this is going to be running on the cloud, there will be certain Moralis-based functionality that won't be possible to get. You'll notice in here, in the create side, I'm using moralis.user.current, which on the front end is fine, but in Moralis backend, that doesn't make any sense because the ID was going to be set to the user. But if I'm running this function from the cloud code, it's not going to have an ID. So what I'm going to do instead, I'll just have a conditional that says if there is an ID, then set the user's ID to that. But if not, then we'll just leave it. And that way it will return as undefined when it stores in the database. If we try and set it to anything else, then it's going to throw an error. And there was something similar, I think a bit further down when we were setting our access control list. So again, I've just put a conditional here to see if there is a user. And in the function, in the actual create method, I've passed in an ID. So now the create method is going to expect some sort of ID. So whenever you call the create method, you can pass it that. And this is actually passed the request.user. And so when it's setting the access control list, if there is a user, then it will set the access control list. But if there isn't a user, then it will just ignore that. So there will be no access control list. But I don't think creating a unit is the ideal use case for a job. It's just to demonstrate how you might get a job to work. So I copied that, and then the next thing I needed to do is create the job. So in the documentation, I copied across this piece of code. I removed everything else out of it, and I've declared a variable called run, which is an asynchronous function to moralis.cloud.run create unit. I haven't passed in any parameters here. So whenever this job runs, it will run our cloud function. So let's test that out. So if we save that and go up to our jobs section in the Moralis dashboard, you'll see that there is automatically a sync eth address job here. And now we have this one, my job 2, which is what it was called. And we can run that. So at the moment, if I just go to the browser, we've got 69 units here, it seems. Go over to the jobs and we'll just run now. It says success. So we'll go back to the browser and here you'll see a new user. So now we have 70. Rexstore is new. We'll go back to jobs. We'll create another one. Back to the browser. And there's the next one. And now we've got Taineray in our database. Now it hasn't got a user pointer and it also hasn't got an ACL, but it just goes to show you how you can use a job to then call a separate cloud function. If we go back to jobs, you can schedule the jobs. You can go up here, choose schedule, give it a description, pick the cloud job that you want, put in the parameters if you have any parameters that you want to pass. I don't have any. You want to start it immediately? I'll say yes. Should it repeat? I'll say yes. And how often should it repeat? I should say it's on an interval. And what interval do you want to repeat it? So I'll say every minute. And it's about 6 o'clock here. So we will say after, say, 5 o'clock. And then we'll schedule that. And here you'll see that it's been set. And so this says that each day, every 1 minute after 1700 hours, starting 10th of October. Okay, so we're actually 10th of November, but I think this is probably an index related problem at 1749. Go to our browser here, I can actually see already a new unit has been created. I've got 72 there now. Walkerson was created. I wonder if in another minute another one will be created. So I just left that for a couple of minutes and come back, and now we've got 74. So you can see that that is running, and it's running just fine. And you can see in here, if you go down to job status, you can see that the job ran. There were a couple of times where I was testing that it was failing, but now it all seems to be working absolutely fine. And you can see that the last 3 that succeeded here were all on the minute. And that is how you would work with jobs using Cloud Code. We're getting pretty close to the end of this course now, guys, so I hope there's been a huge amount of information in here that has been useful for you. I hope you've managed to get a better understanding of how to use Moralis inside of your builds. And the last major topic in this Cloud Code section will be webhooks. So I've assumed that the majority of the applications that you'll be building will be using some sort of JavaScript framework, maybe React or something else. But you might be coming towards this, you might be coming into Moralis using a different environment, and you might want to be using some different tools. So webhooks will help you get access to your cloud functions from a different environment. You're already familiar now with before save, after save, before delete, and after delete triggers. Webhooks are currently available for those, and of course for cloud functions. To specify a new webhook, you just need to go over to your dashboard and head to the webhook section. That'll be here. And you can create a new webhook. And this would be specifically for functions that are external. So in this example down here, this is a function. We're going to call it Hello World. And the webhook URL is a Heroku app. So it's actually something external that you want to be able to call from within the Moralis SDK. So I've written everything here in vanilla JavaScript, and a lot of our other applications will be in React, but sometimes maybe you've been doing things in a Ruby or a Rails environment or a Python environment or whatever it might be, and you've built some sort of function that you want to be able to get access to using the SDK or using the webhooks here. So this is how you would use this. A webhook request for a cloud function will contain the following parameters: master, user, installation ID if it's available, parameters, and the function name. Webhook servers are produced in something like Express or whatever it may be. Now you might have a webhook URL from various different methods. You might have built your own server, you might be using Express, you might be using something like Heroku, wherever it might be that you've hosted your application for which you're looking to use as the webhook. You'd need to put that into that webhook URL. Once you've done that, you would call this function exactly the same way as you would a normal cloud function. When the webhook is called, there'll be a JSON object that goes through, and the JSON object would have this information preloaded. And to respond to the webhook, you would be able to send a JSON object with an error or success set, and you will activate your webhook from the dashboard as I've just shown. You can use some triggers with your webhooks as well, such as before save, after save, before delete, and after delete. And these are the parameters that will be sent to the webhook. But you can also define before consume. So before consume webhooks, we've briefly seen before. If we go back to have a look at the smart contract events, we had this before consume trigger here. And the example is when historical data is not synced automatically, a before consume trigger needs to be created on the table name. And really the main reason for this is because when you're looking to get a large amount of data, say for example from a smart contract event, let's say a transfer event that could have millions of events per hour, which would effectively kill your server, you'd need to define a before consume webhook and set the table name used on the plugin creation when you did the sync and watch event. And if it's over a certain value, you could just return true, and that should solve your issue. Of course, if you have any other problems, you could post something into the forum. But that should give you an idea of how you can get started with your webhooks. Okay, and the final section over here will be config. So in the Moralis dashboard, you have a section for config, where if you need to, you can create a parameter. Maybe you want to set some sort of variable in here. Maybe you want to call it something like my secret something, and it's going to be a string, and the value is going to be very original, Chris Bailey. And then you can set whether or not it requires a master key to get access to that, and it's probably a good idea to do so. From here, you can create the parameter, and then it will be saved in here. In your cloud code, you could then use that parameter because it exists. You could use that parameter because it would then be set in your dashboard. You'll have to use the master key in order to retrieve it. So in this case, we could just write a simple cloud function. We'll copy these 2 lines of code inside it, and we will go and call my secret something, and we should get back Chris Bailey. In the cloud code, it would look something like this: Moralis cloud.define. We'll run the test config. We will look for my secret something, and then we will return that private param. Once we save that on the front end, we can then run await moralis.cloud.run or run test config with no parameters, and we should get back, there it is. So that could be another way for you to hide some environment variables that you want only to be accessible from your server. And that brings us to the end of the config section. So huge amounts of information we've gone through, especially with the database and the cloud code, and we can start pulling all of those together now when you're building your applications. And now if you were to, for example, go back through the demo applications and some of these tutorials, a lot of the techniques that are included in there that might have been advanced at the time will now make a lot more sense. The syncing side of things, the cloud code and functions and triggers, using the Web3 API and the SDK, all of these kinds of things will now make sense to you. And if not, go back, revisit the videos from the beginning and watch it all again. But I hope that that has helped level you up as a Moralis developer, and we'll finish off with these last few sections as we wrap up the rest of the course. So let's cover off the remaining sections of the documentation, including Web3, files, tools, and plugins. In the Web3 section, we can look at the Web3 provider and Ganache and the hard hat setup. Let's talk about Web3 integration first of all. Now, in your browser, there are a couple of ways that you can integrate Web3. You'll be able to use the Moralis enable Web3 method to get a fully functional Web3 instance, and that will enable you to make contract calls, such as this example here. You can also use the wallet connect provider. You'll just need to pass through this object in the method call. You would just need to make sure that you have wallet connect installed in your application. If you only needed to access some Web3 utilities, for example, this from way method, then you would be able to access it using this. But if you do it this way, you'll just need to understand that some of the other methods will not work, and you'd need to reassign the Web3 variable with the enable Web3 method later. We've already looked at how you can get a Web3 instance in Cloud Functions. Moralis offers you an execute function method, which will enable you to run smart contract functions, either call or send smart contract methods. There's an example here. You can pass across the contract address, the ABI, the function name, parameters, and a value if needed, and that would be in way. This example has 3 parts. The first one is the ABI, stored inside of an ABI variable. It then creates an options object with those options here, and then the options object is passed into the execute function method. Before you can run this method, you'll need to make sure that you have an enabled Web3 provider, following the instructions above. If you're using Wallet Connect, you'll have access to using the callbacks promises events section, which is a little bit further down in this page of the documentation. And below, you'll find an example of calling a send contract method, such as a standard smart contract method like approve. Or another example below that, which is the swap native for token smart contract method. And there's an example of that here. The options can be reusable. So if you need to use the options object for calling multiple contract methods, then you can do that. Here's an example of how you would write it. And this was the callbacks, promises, and events section I mentioned a moment ago. And this explains that the Moralis execute function method supports promise events, and you can hook into the different stages of your blockchain interaction, such as the transaction hash and the receipt and the confirmation stages, without having to wait for the entire transaction to process. So that's the execute function method. Moralis also lets you hook into Web3 change events. So for example, whenever you change an account in MetaMask, for example, if you're swapping from one account to another, it could do something. If you're changing the chain, then it would do something. Or if you're connecting or disconnecting from MetaMask or from your Web3 wallet provider, then it will allow you to do something. So one example might be on the accounts change, maybe you want to link or add the function to that user's account. Maybe they've got a few accounts they want to be associated with. When they change the account, you could offer them an option to link the account to their profile. And that comes down to this next section, linking. Moralis gives you access to link and unlink methods. If, for example, that method runs on the accounts changed, the function has access to the accounts of the user, and that's typically in the form of an Ethereum address. So when you run the link method, you would be able to add that Ethereum address to that particular user's accounts. And there's an example of how you might do that. Unlinking is the opposite. You could use the signing message option and choose a custom message that the user sees when linking an address. And then we've got some other handy functions and other handy methods that you can use. For example, ensure Web3 is installed. It returns a true or a false, and it just simply detects if a Web3 provider is activated. You would run the Moralis ensure Web3 is installed method, and then you would be able to check the result of that. You have another one, which is MetaMask installed? Also returns true or false, does what it says. You run the Moralis is MetaMask installed method, and then you can check the result. The next one, get chain ID, will return an integer value of the chain that your user is currently logged into. You can easily Google a list of those. We've covered this before, but you could use chainlist.org. So for example, 56 was in the documentation there, and we can tell that from experience, that's going to be Binance Smart Chain. You have access to the switch network method. You'll need to pass it a chain ID, but you would be able to programmatically change from one chain to another. It will require a signature. And final one is add network. You need to pass it a number of options, and this will have the ability to add a new network to the wallet. So as you'll agree, lots of very useful functions available for you straight out of the box. Okay, let's take a look at files. With files, we've got you again on the documentation. There's a very good video here about working with files from Nicholas, and that also was covered in the Create or Cloning Rareable series, which he produced a few months ago. So it's worth spending some time going through all of those videos to learn a bit more about creating Moralis files. But Moralis.file lets you store application files in the cloud. And that's particularly useful for files that would be too big to fit in the regular Moralis object. And that's typically for things like videos, music, maybe even images, and other large binary data. And there are a couple of ways that you can create a file. Also remember that by creating a file, you have access to the triggers that we covered out in the cloud code section. So the first way that you can create a file is with a base 64 encoded string, like this example, or alternatively, you can create a file from an array of byte values, like this example. If you want to specify a content type with a third parameter, for example over here, then you can do that, but typically Moralis will auto detect the file type that you are uploading based on the extension of the file. If you're using your browser, you'll need to use a HTML element for the input type. Just simply use a file input tag, select the type to file, and include any other data that you want to, such as an ID. You'll need to build a click handler and get a reference to the file. This one's actually using jQuery. It's selected the file upload from the ID. It's checking if there are any files, makes a reference to the first file, creates a name, and then runs new Moralis file with that information. A couple of things to mention. If you are uploading a file with the same name multiple times, for example, photo.jpg, you don't need to worry about file name collisions because it's the object ID that separates one item from another, and that's created automatically in the Moralis database for you. But it is important that the file has a file extension, otherwise it's not going to know what type of file it is. Once you've created the Moralis file, you'll need to save the Moralis file, otherwise it won't be stored in the database. And you just simply use the save method. It returns a promise which you can then work on if you need to. In Node.js, you can fetch images and other files. Here's an example. When it comes to objects, you will be able to associate a Moralis file with a Moralis object, but you'll just have to complete the save as in the previous step that we've just gone through. Here's an example. And a useful tip here is that when you're saving files in your cloud code, make sure that you use the master key. Here's the example of how to do that. You can retrieve the file contents. Here's an example using jQuery and an example deleting files as well. And at the bottom, adding metadata and tags. You just simply need to use the add metadata and add tag methods, which when you create a brand new file would be methods that are available on that file. Okay, so that's files. We'll take a look at IPFS. Moralis has native support for IPFS. Once more, there's a video here that will go into detail for that. You don't need to configure the IPFS in the Moralis server now. It's enabled by default. If you need to save files to IPFS, you can use the save IPFS method. There is a maximum file size limit here, currently set at 1 GB. The video will explain a little bit more, but when you're using this method, it gives you access to a couple of new methods, which would be the IPFS and the hash method, which you'd be able to use to get additional information about the file that you've saved. It's not just files, it's objects as well that you can save. Moralis will automatically create the buffer from the base64 provided, and that means that you could even upload other base64 encoded files like images. You can get IPFS files using a GET request. For example, this link here takes you to this, and that uses the default Moralis gateway here. So take a look through the videos that are in this part of the documentation. That will familiarize yourself a lot more with how you can use IPFS with Moralis. We'll head on over to tools now. At Moralis, we've created a number of helper functions because we find that some of the standard Web3 methods are inconvenient at converting. Maybe users want to input a normal, regular monetary value of something that they're used to, but instead they need it to be in WEI. For example, 0.5 ETH is actually that many WEI. So 1 Ethereum would have 18 decimals, so half would, I guess, have 17 decimals. So I'm not sure how big that number actually is. Maybe like 500 trillion. So generally you'll need a converter function, and Moralis does have this. So inside Moralis units token, for example, you would be able to convert that to WEI. You could do the same with units.eth, which would be for a native asset. You can convert from WEI, but just be aware that you'll only be able to use these helper functions using the SDK. They're not yet available in cloud code, and that will likely be added soon. The CLI we pretty much covered already. You can update your cloud code, you can update plugins, you can use your local web development environment, you can get logs. There's a few things you can do with this. And as you scroll down this list and look at things like watching cloud folders, connecting to local dev chains, updating or creating servers, deploying or undeploying, adding contracts, etc., the majority of these items in this part of the documentation have videos that you'll be able to watch and learn plenty from. Okay, we'll move over to website hosting. Now, this is mainly for static hosting only. So if you need to put your website live, then you can use your Moralis server to do that. Here's a video explaining how you can use the CLI to do exactly that. On sending emails, Moralis has an integration with SendGrid. So there's information here about how you can complete that integration, and also on our YouTube channel. And if you went into type SendGrid in our channel, you'd be able to find another one here by Malik that will help you as well. React Moralis, we have now an Ethereum boilerplate that you can find on GitHub. There's again a video about that here. Ethereum Dapp boilerplate literally will save you months of development time using our React boilerplate. You can find that by searching for Ethereum boilerplate in Google with a top result. And you'll go over to our GitHub repository. It's got nearly 1,000 stars on here, and you'll be able to fork this and use it in your application. Full documentation is available down here as well, explaining all the different components that are available and the different hooks that you can use. And we'll be seeing a lot more of this over the next few months, as there'll likely be some additional videos and courses that we will add to this on React for you. If we go over to the plugins section, we will be utilizing this a lot more over the next few months. But if we go to our Moralis dashboard, you can find your plugins over here. When I started recording the content for the course, we had 2 plugins. We now have 4. So I would imagine this will just continue to grow. We've got the Fiat on-ramper. You can buy crypto using this plugin directly from your application. We've got the 1inch plugin, which will enable you to build decentralized exchanges directly in your application. We've also incorporated this into our boilerplate, React boilerplate. We are now going to be providing with the power of OpenSea. With just a few lines of code, you can have the power of that in your Moralis Dapp, and also lazy minting NFTs with these Rarible NFT tools. We're going to take a look through those and keep an eye on them when new ones are released.
Wow! Welcome to this final video in this course where I congratulate you on your amazing feat. You've done all the videos in this course, you've done all the moments, you've done all the different chapters, and now you know what Moralis is, how it's used, you know about how to log in users, get their data, sync smart contracts, how to watch for real-time alerts in your applications. And what is the next step? Well, the next step is that you put this knowledge to work, because while this course may be over, there is a whole new world in front of you. This is how it is with learning. You learn something just to discover that you don't know anything. And this is kind of the experience you have all the time in programming. And this is something that I have all the time in programming as well. That as soon as you think you understand, you quickly realize, oh, there's so much more to learn. Let me explain to you what is coming next. And this is, by the way, how it's always says that you think that you've made it to the top, you're here, but then you quickly understand that, wow, there is another top. All right. So what you can do now is that you can use Moralis, you can build everything you want, but you do it in vanilla. All right. And like we discussed at the start of this episode, you should not be using vanilla in production projects. In production projects, you use something like React, you use something like VueJS, but the reason why we did vanilla, like I also told you in the beginning, is because everyone needs to be able to follow this, even if you don't know React or Vue.js. So if you don't know React or Vue.js or some other such library, I highly recommend you to learn React. So if you search React Moralis Academy, let me try to find it, Moralis Academy. You just search React Moralis Academy like this. You will find the first one, React Web Development. So this, you should learn this. Go and join our academy and learn React properly. Because here you're going to get a real instructor. You can do this remote. You can do this on your own free time, but you need to know React, guys. If you are to do something for real in production, you need to know React. Now, if you already know React, then it's amazing. Because then you can go here to Ethereum boilerplate and you can start playing around with this. You can start building anything you want based on this. So let's say you want an NFC marketplace, you can use this boilerplate. You want prediction market, you can use this boilerplate. And actually, we have a full playlist on YouTube doing exactly this, taking that boilerplate and molding it into different things. For example, if you look in the description, you will find this playlist called Web3 Programming Projects. And here you see, for example, how I cloned OpenSea, how I created a chat app for iOS and Android, how I created Web3 social network, how I minted NFTs, how I built a DeFi dashboard, how I did the Ethereum login, how I minted a bunch of stuff, how I did a prediction market, and so on and so forth. So as always in programming and technology, you know a lot, but there's always a lot to learn. So as next step, I would say if you don't know React, go and learn React. You find it in the link below, but you can also just search React development. Then start going through this. And once again, if you haven't signed up yet, sign up in this Interested in Moralis Expert Certificate. You go to moralis.io/certification and you're gonna find this. We will email you when it's time. On that note, guys, I want to congratulate you once again, because what you have achieved is monumental. You've achieved monumental things by following this whole course through, by ensuring that you know what you're doing here, and by ensuring that you know the tools they require to do different things. And I hope to see you in the next video, in the next course here on this channel. So big shout out to you. Have a good day and goodbye, guys. Goodbye, goodbye, goodbye.